Oh, no, no, I can't. Okay. Good. How's everyone today? Is that all? I only slept for like 3 hours, but you must have slept more than me. And you are not very loud. Okay, if you don't make it loud, I'm not going to start a conference. Bye. Is that all? This is the live stream. I only slept. So we are streaming at the same time in many places. Let me move this one. You can see it's not. Okay, perfect. Okay, what time is it? Okay, 10 minutes late. So, how many of you are from Singapore? How many of you are from Thailand? Vietnam? Anyone? No? Oh, maybe one. Okay, which other places? Indonesia? Hungary? One. Greece? Okay. Okay, we're gonna start now. So my name is Aris. I'm the founder and the organizer of Cityjs. I've been doing this since 2018. This is the second time I'm doing it in Singapore. You can call me crazy, like I don't know how it happened, but it happened. But I like it. I like Singapore. It is a community conference. Basically, when we started it, we were like 3 meetup groups in London. And I was running meetups in the first place. I didn't think that I was gonna do a conference. I have a meetup called JS Monthly in London. Thomas, you have been there, you have presented. I went to a talk and I saw Kyle Simpson, who's gonna be our keynote speaker today. And he was talking about clans and about, different teams and different kind of, stuff like someone likes TypeScript, someone likes JavaScript, right? Someone likes this, someone doesn't like this. We all have that. And I was going to other conferences and there were people talking about TypeScript at that moment. So I had this idea of creating I wanted to do a meetup in the first place about bringing 2 speakers, so Kyle and another speaker called Dylan Simon, to do a debate talk between TypeScript and JavaScript. But they told me, look, if you want to do that, you cannot just do a meetup. You have to do a conference. And so I thought, okay, I never thought I was going to do a conference. And then we started talking about, so what is going to be the name? Because I was working for City University in London, I thought, what should I call it? City University? Cityjs. In one night, I picked the domain, cityjsconf, and I downloaded a Bootstrap template that I bought for I don't know, it was £2 or £3 or something like that. I reskinned it, I changed the colors, and I just uploaded, and the website was running. So that's the story about Cityjs. That was in 2018. And so we did 2018, we did 2019, And then the pandemic came, and as we know all, we have to stay inside, and everything has to happen virtually. So I started doing like, I did a virtual event. I don't know how many of you know GatherTown. It's like a virtual world where you can move your mouses around, but actually I gave the people the opportunity to use the cameras and see each other from their homes. But people, they didn't want to see each other. They were just avoiding people. So thank God the pandemic sort of ended. It's still, there's still, the virus still around, but I started thinking, okay, now it's finished. I can still continue with a virtual event. So I was thinking last year to do a virtual event, but the people told me, no, we don't want a virtual event. So I ended up doing here an in-person event. And then here I am again. So right now, Cityjs has 8 events around the world. One of which is where I come from, Greece, in Athens. The main conference runs in London. This year we had Kent Dodds in our conference and Mr. Tamas Spiros. Okay. It's supposed to be creating communities, providing growth for places that they don't have the ability to run conferences, like Sao Paulo, Nigeria, India. We are thankful for our sponsors that sponsor us, and ticket prices are very low compared to other conferences. Like there's some conferences like they can charge like 600 pounds for one day. Our price is like quite low. We have a code of conduct. So basically, we don't want to, have any sort of discrimination, any sort of harassment. If anybody, do something wrong to you and you feel like you want to come and say it to me, okay? And I'm going to make sure they are kicked out of the conference, okay? And if you want to read about it, this is the page where we have COC/COC and the rules of what we have to follow. I think the exit is quite clear, it's there, right? And yeah, so, I live in London and I pass quite a lot of time in Greece because the weather is as good as here, very hot. And with me, this time, I'm bringing a very special friend.
Hello, Aris.
It's like my boy, Dan. And Dan is from England, so he's going to have a lot of English jokes.
In it.
So, it's in your hands now.
Thank you very much. Hello, everybody. There's a lot of you here. Let's give a round of applause for Aris as well. So, Aris actually has a full-time job as well, and so this is something he does on the side. And so I've seen Aris blood, sweat, and tears putting into this conference. So if we could just give one more big round of applause for Aris for putting this off today. And so, as Aris mentioned, I'm from Britain, and there's lots of Asian names in this conference, and I've got 15 of them to remember. And so I do apologize if I get any of them wrong. And so we've got some sponsors today, and they are actually down here, but I believe we have a slide filled with them. Ah, here they are. Okay, so without these sponsors, this event wouldn't happen. We have the food, we have this wonderful venue, and we've flown in some great speakers from all over the world. So let's just thank Storyblock, Cloudinary, Vonage, Ulysses, Ulysses, anybody know? Ulysses, AWS, Odds, Auth0, VMware, Ascender, I think so, I think that's right, Reddito, Stickermule, and Cascade. So let's just give a round of applause for all of the sponsors today. And so out here you'll find the booth with all the sponsors. They've given away freebies, food, and some challenges that you can complete as well. So let's get on to the first. Oh, we've got some more sponsors here as well. This is the community partners. Awesome. So let's give a round of applause as well for the community partners. Okay. And so let's get on with our first speaker. We have all these socials here, and so please post photos of the talks, of you having fun, of the food as well, on any of these socials here as well. Okay, well, let's get started with the first speaker. And so we have Ho Chi Jin, who's going to be talking to us about accessibility.
I don't need it. I can just like direct
Oh, can you?
the
Okay.
HDMI.
Oh,
Yeah.
it's here. So, this talk, I have to say, it's not about JavaScript, because this lady here, she really likes CSS, but you know, we have to use, you know, wherever we can, we should avoid using JavaScript and using CSS. So, yes, she's going to tell us all about it.
Desi halia kosong panas. Can. Okay. Screen brighter. Okay, masuk professional. I have a clicker. Okay. Hi. Hello everybody. Welcome to Cityjs. Thank you all for being here on this lovely Friday morning. I'm not sure why the organizers put me in this opening slot, because like he mentioned, there's not a lot of JavaScript going on in this talk. But so maybe that's why, because like all of you clearly paid money to see the hard-hitting, hardcore JavaScript rock stars later in the day, right? But I need to warm up first. Yeah. And that's what opening acts are for. You know, like Taylor Swift. Paramore also open for Taylor Swift. Opening acts are very important, everybody. Opening act. So because this is the Singapore edition of Cityjs, I feel very obliged to stay true to the culture. So for the benefit of the audience who are unfamiliar with English spoken in Singapore, there is a range. So this is best explained in a graphical form. FYI, this is a legitimate HTML range input that has been styled by CSS. So if you are interested, you can ask me how it's built. I will explain it to you. So today, right, I will keep the where's my mouse? I will keep the level somewhere in between Queen's English (RIP) and Extreme Singlish, where Angmo catch no ball. If you don't understand Angmo catch no ball, that means you cannot understand Extreme Singlish. So in general, the R sound will sometimes become L, like ready will become lady. Then ver, V-E-R, we just omit. So like government will become garment. Or like never mind become never mind. So as you can discern from the past 2 minutes, grammar is optional. So like that. So middle. So I will try to keep it relatively understandable. Try. So other than that, it should be, like I said, mostly comprehensible. If you feel a lack of confidence in understanding the next 15 to 20 minutes, please sit next to a friendly Singlish speaking attendee, and I'm sure they will explain all of this to you. Yes. So my name is Hui Jing, is a Chinese name, so our family name comes first. My family name is Chen. In Singapore, is a very common surname. Throw a stone, hit someone's surname Chen. Yeah, and these emojis are the story of my life. I have been gainfully employed as a web developer for more than a decade. Of course, not with the same employer. But regardless of who it is, an employer who pay your CPF on time is a good employer. Yeah. So right now, Interledger Foundation is the company paying my CPF. They're very punctual. I love it. We are a non-profit organization. We are trying to build a payment network based on TCP/IP. So it's like the internet. And our goal is to try to make paying someone as easy as sending an email. But that's not what we are talking about today. They just pay my CPF. Today, I'm going to talk to you about I-18N, which is short for internationalization. So maybe you learn something, maybe you won't, but it's my hope that you will at least be mildly entertained. And if you fall asleep, just try not to snore too loudly. You must be courteous. Keep the snoring like quieter. So basically, there is no canonical set-in-stone definition of I-18N, but the W3C offers this guidance on their website. So it tells you that it's about designing and developing in a way that ensures easy localization for specific audiences. Then localization is actually very broad. It's a very broad category. It will cover things like, like numerals, time date format, currency symbols, all the way until maybe like, graphical reference, icons, that kind of thing. So that's very, very broad topic. So what does this imply? This implies that I-18N is a lot more than just translating the content to another language, right? There's a lot of nuances to how you present that content, which will affect the experience of a native speaker. Now, I'm very lucky, right? I got a job, right? So I got the opportunity to work on a lot of projects that require internationalization. Then, I know just now I just said that internationalization is more than just translating content, but it's very important to get the translation part correct. This is like 80% must. So for this talk, because of time constraint, I just picked a few of the funnier or like more interesting anecdotes that I personally encounter. So it's like story time. So let's talk about numbers. Specifically, let's talk about big numbers. I'm Chinese, right? So I can only talk about this numeral system. But other language also got specific words for powers of base. Like India has the word lakh for 100,000 and crore for 10 million. So for us, right, our word is for 10,000. It's called one. Japan and Korean also use a similar numeral system. So Japanese are called ichioku. Korean called ok is 10,000. Then after 10,000, we go 40. So the next word is 100 million. See, English don't have word for 100 million. We got, it's called E. But conversely, English got word for 1 billion. We don't have. 1 billion is 100 zeros. We don't have that word. So that's the situation with large numbers. Everyone got their own word, right? So you keep this in your mind, then you park in the side. Local storage, we segue. Now we segue into translation string. So translation strings, right, is a way for us to mark strings to be extracted from the source code, and then you pass it over to a professional translator to translate. If your project doesn't need multilingual, you probably won't use this interface. You probably just have the string there. But like if you're doing multilingual sites, this is a very common pattern. And it's a good idea. Why? Because all your content goes into a single file, single source file, and then you can pass this file to people who actually can translate the content properly. Unless your developer is so linguistically gifted, or can write, copy, and translate to multiple languages, don't own self do. Oh my God, it's so terrible. Do not ask your developer to write copy. Anyway, most languages have a very similar pattern. This one JavaScript, but like I've seen this pattern in PHP, I've seen it in Rails. So translation string, you keep in separate data file, can be JSON, can be YAML, whatever, and then you use the strings back into your application code using T function. Everyone also calls it T function. I guess, naming things is hard. So there will inevitably be instances where you want to pass variables into the translation strings, especially for things like data or statistics, because you want to keep this information consistent across all the different languages. So you got interpolation. So you think this is quite straightforward, like, oh yeah, okay, interpolate lor. Most of the time it is quite straightforward, but then the caveat is it depends on what you're passing into the string, like what variable you're passing, how do you split it up and pass it to the translators who are doing the workflow. So, oh shit. Wow, why is somebody jump so far? Oh my God. Slowly? Okay. So, in my previous place of employment, we did it like that. So there was a set of business stats that needed to be consistent throughout the entire site across all languages. So we would substitute them into the translation string with these variables, total country, total store, that kind of thing. So that's the output, but the translators, they only see this source string. And so then they take it, they say English, translate, they give it back to us in their respective language. So for the most part, this is not a problem for them, they translate accordingly. There's only one instance that got problem, because the number that was returned for total GMV billions, for some reason the person decided, who did all this organization, decided to store the variable in like billions. So I don't know who it was, it's now my previous place of employment, but I guess he only speaks English maybe, right? I don't know, man. So this is what we got back from the translator. So I understand that this graphically doesn't mean anything to people who do not speak Chinese or Korean, so I explain the problem to you. The following translations have expressed the value of 200 billion, because the number that we stored inside the variable was 200. So they express 200 billion as 210 million. So it's not the translator's fault, because when they got the string, they didn't know that the number stored in the variable is 200. Like if you ask me, right, if I got a string and then it used billion, in my mind, billion is already a big number, so it's maybe 5 or 6 billion. So fine, I will just translate it as like 10 亿, which is like 10 million. So, but regardless, a mistake is a mistake, right? Users don't care how or why you made a mistake. They only see that like, wow, this company cannot speak Chinese, cannot speak Korean. This is like kindergarten kid learning how to use big number words. Very bad, rookie error. So actually, how it goes is that we have language reviewers. So the Korean language reviewer was supposed to review some other content, and then he was very apologetic. He was like, actually, I know that I know you told us to only look at the section. But like, this is your homepage, I cannot ignore, I cannot unsee. When I got a ticket, like, oh shit. The Chinese, Japanese also must have this problem. But when I check, right, only the Chinese side got. Right? How come Japan okay? Japan grammatically correct, why? Because back then our Japan team was very stacked with native Japanese speakers. So the moment they said, oh, cannot, then they went in and changed. So they went in, they manually replaced the character for Jew with 0, then it becomes, grammatically correct already, can. So, of course, people fix already, I just steal and use lah. So this is the resultant fix. And so what you can notice, the difference between the Japanese and the Korean Chinese one is spaces. Because when you're doing translation, especially with string interpolation, this is something that always gets overlooked, is the spaces, because many people are touching the file, go there, come back, change things. Spacing is always the one that gets lost. Because for Chinese, right, if you don't read Chinese, when you look at a block of Chinese text, we have no space between Chinese characters. It's just like all together. But if it's a Chinese character and a non-Chinese character, right, we will have a space between. So for example, if it's a number, right, Chinese character before, Chinese character after, got a bit of a space. And then Korean has its own like spacing rules. It's called Tyosugi, and they also have their own set of rules. So it's something that is a bit important when you're doing the review, when it comes back, right? The spaces get lost in translation. It's something that often gets overlooked, and usually, if you're not a native speaker, like you don't care. But if you're a native speaker, like I not nice, right? Like when you watch Hollywood movie, like, wow, your budget for your movie 100 million and you couldn't afford to pay for actor can actually speak the language, then you're like, oh shit, so terrible. Yeah, don't do it. So the TLDR is that interpolation is very useful, but should do it sparingly and very deliberately. Yeah, because of all the things that could go wrong, right? Other than what I just described, right? There's also other things that are very different between languages, right? Like pluralization. English is what? Singular, plural, or two. But no, like other languages will have pluralization rule, like for 0 is like that. The sentence structure for 0, for 1, for 2, for few, for many, for other is different. right? So some language even got gendered nouns. So the point is like, if you hard code your word order, or you try to manipulate text at the code level, you're going to make life for your translators very hard, or you just won't get the translation correct. And it's actually, my take on it is that if you're trying to go for a global audience, and you cannot get the translation right, you rather not do it. Because if you don't do it, then it's net zero. If you do it and you do it wrong, then it's negative, which is worse, right? Yeah, I must think about it like that. Like sometimes you got a colleague, then you're like, if he's the same level as a potted plant, that's great, because he's not going to ruin your project. But if he's the type of person who like make things worse, then you're like, a potted plant would have been better, right? Same concept. The people who build and maintain I18N libraries, actually they've done a lot, they've thought about this, and they've done a lot of the tricky work. So it's a good idea if you are going to, multilingualize your site to use these packages, because they are tried and tested, they are maintained. Like for example, JavaScript has the go-to one is I18 Next, right? And I'm sure that every popular framework has its own flavor of I18 Next. So if you have to, just use it. Like don't try to do it yourself. Very hard, very hard. Next story. Okay, story number 2. Story number 2 involves Vietnamese characters, because they are Vietnamese in the audience. Yay. Some of you, I keep using CJK. The acronym means Chinese, Japanese, Korean. But sometimes the acronym also include V at the back for Vietnamese. Because historically, Vietnamese in the past also used Chinese characters and some original Vietnamese characters in the writing system. Just that now it's different. Colonization? No. I'm not sure if everyone is familiar with Unicode, but like Unicode is a standard for character encoding. And the Unicode Consortium's mission is that like everyone in the world should be able to use their own language from their phones and computers. So I think it's a cool mission. So in general, the characters for a particular script, they're usually defined in a range. Right? The range is usually like next to each other. For example, for Thai, it's 0E00 to 0E7F. So usually it's like that, usually. But like Vietnamese is very interesting because their current writing system is a 29-letter Latin-based script. It's a Vietnamese alphabet. So it's very tricky because the Vietnamese alphabets, they exist in non-contiguous Unicode range. So tricky because like, I don't know if you got type designers among your friend group, but designing fonts is very tiring. Why? You have to design every glyph, and then you have to design how the glyph look together, nice or not? Not nice, okay, change. Then like 2 together, nice, but 3 together, not nice. So it's a lot of work, right? So they are not going to design like every single character in the universe. No, they're probably going to go for what they expect their audience to use. So even the Latin-based scripts, when they design, they probably just go up to like Latin 1 supplement, and they call it a day. So unless they like, oh, my font I specifically doing for German, I specifically doing for Greek, then they'll do it, right? In general, it's like, oh, okay lor. So when you are trying to pick, or your designer is trying to pick font for the new project, right, must make them check that the supported language is in there. Otherwise, you will end up with a situation where the missing glyphs look very obvious on your site. And the situation occurs because what browsers do is that when they try to parse your content and they cannot find a corresponding glyph in the font that you choose to represent the character, they just go and use a fallback. The fallback usually is a system font. And then, if your fallback font just nice doesn't match the chosen font, then it becomes very obvious. And I'm very aware that all of you here, right, there's confirmed got a few people like, okay, very nice, what? Got anything wrong, meh? Got anything wrong here, meh? Got something wrong, okay? The point is, I can tell, it's very glaring to me, and I don't think it should happen because it looks very unprofessional, right? Like, so, but I mean, some products, you all will go and commission a font. And when you commission a font, or you buy a font, font's very expensive. I don't know if you tried. You all don't bad habit, go and bootleg font, don't do it, don't pirate it. But if you really go and buy a font, sometimes you can go up to like a few $1,000s. If you commission, even more expensive. So ideally, like I mean, as an Asian person, I can understand. Like if I pay for it, I'm going to use it everywhere, which is legitimate. I also support this idea, use it everywhere. So it doesn't mean that just because the language you support is not part of the font, then you don't use. No. You use it everywhere else, and then only for the language that the font doesn't support, you pick another font. You pick a better font stack. So you can use CSS to do it. They finally got code already. CSS. Woo! Okay, anyway. Basic web development best practice is that you must declare a lang attribute in your document. If you want to know why, you can kind of ask me later, I explain to you. Now no time to explain. But assuming you, or most likely your framework has set the lang attribute correctly, you can use this pseudo class to just target Vietnamese content, and then you can provide a proper font stack. This one, I really suggest you discuss with your designer to come up with a font stack that fits the branding. Must communicate, developer, designer, you cannot just live in your own lane one, you all must be friends. So, okay, now that we talk about commission font, this one is an edge case. It's an edge case, I feel, because it involves Apple and it involves Korean. So if you don't use a Mac, or your site don't need to support Korean, you'll not run into this, but I run into it. So most CJK fonts will also have Latin-based character set, because we cannot escape from English on the web, okay? That's just a fact of life. English people invented the internet. But anyway, for Apple, right, their chosen default system font for Korean is called Apple SD Gothic Neo. And it's actually not bad. Even how to say, the Latin characters also look quite decent one. But the problem is it doesn't have support for Latin 1 supplement range. So Latin 1 supplement range is where all the letters with the accents exist. So for cases like this, right, what's going to happen if you try to use, if you didn't declare a font and then Apple uses Apple SD Gothic Neo on your content? You're going to end up with a blasphemous situation where Beyonce does not render correctly. Cannot, sacrilegious, this one, no. For cases like this, what you want to do is that you will specify your Latin-based font of choice first. Do it first. Why? Because again, this is how the browsers pass it. When the browser sees a font stack, it will go left to right. So it will take, okay, let's say I declare work sense. It will go through at if it has to render that accented E, right? It will check, does work sense have this character? If got, then I put. But if it don't have, then it's going to go to the fallback font. So even if you're doing any CJK things and these Latin-based fonts don't have the CJK character, it's a good thing. Because then it won't try to render, it will just go back to the default font that has the character. So your site will end up actually still looking very consistent. So yeah. Declare your Latin-based font of choice first. That's the reason why. So again, discuss with your designers what is a nice font stack. Because usually this part, people don't, they just like any howly, and then the developer owns up any howly, and then become like that. So yeah, I time it very well. It's 20 minutes already. So there are some links. If you're interested, you're probably not interested. Never mind. Yeah. So yeah, thanks. I hope you all warm up enough. And open your brain for JavaScript, okay? Yeah, okay, thank you.
Would you like one of these or a plug-in one?
No, I'm fine with this. Just make sure I'm mirroring my screen. Great, thanks everyone. Happy to see so many people here. So my talk today will be around why GraphQL is more than a type system. There's a lot of, I've been giving talks around GraphQL for the past maybe 4 or 5 years. And it's great to see so many people already are using GraphQL if I've heard about it. But I think around social media there's also conversations going on. When you shoot GraphQL, is GraphQL your best solution? Do you actually need it? And in this talk I want to give you some background on why you might need it, but also why you might not need it, and how using GraphQL somehow can be overhead, but it can also help you in future. So I think as a software developer, I like to say it depends. The same as with every technology. When using GraphQL, it also depends. So first of all, thank you for having me here in Singapore. It's great to see all of you here. So I did a workshop on Wednesday, I think. So thank you for everyone joining there. If you joined the workshop, you're also almost speaking at a conference now. You already made it to the slides, so it's the first step in maybe next year or at a different conference. Try yourself and speak for an audience like this. And also great to see so many of the other speakers and sponsors yesterday. A little bit about myself. As Dan said, my name is Roy. I'm from Amsterdam, so a pretty long flight. I think it was like 12 hours. As I said to someone, hopefully one day I will make enough money to fly business class, so I don't have to sit in a chair and hurt my neck. But, well, maybe one day. I work for a product now called StepSend, which is a solution to make building GraphQL APIs easier. I also write programming books, mostly around React or TypeScript or GraphQL. So hopefully these are technologies you're familiar with as well. And I create videos on YouTube and go to conferences like this. So if after these 30 minutes you haven't seen enough of me, just make sure to go to YouTube and you can find more. Or just speak to me whenever you find me working around here. So the first question I'd say is, why do developers love GraphQL? And it's a question I usually ask people when they do a workshop or when they ask me questions around using GraphQL in their products. I guess the main reason for GraphQL to become popular one day was, as a front-end developer, I really hate interacting with REST APIs. So who here hates using REST APIs? Or who sometimes dislikes it? Maybe dislikes is more polite. Well, I'm guessing you're just being polite. As a front-end developer, my main problem was when I was learning the front-end development or learning to work on a front-end project, I was using REST APIs. And one thing I always hated was it's really unclear what you can find where. You have all these different endpoints. How do you call them? How do you find your data? How do you get data that's missing? As a front-end developer, it would be easier just to have one API that gives you all the data you need, which is exactly what GraphQL does. So let me quickly browse through this. As I saw from the small poll we did, most of you already know GraphQL or are even using it, so we can make this part quick, but it's good to have the full context before I'm going to bore you with more complicated details. So GraphQL is what we call a query language for APIs. I have a slide somewhere where I say GraphQL is like SQL. I guess most of you know SQL. Even though you might be a front-end developer, you sometimes have to interact with a database. And SQL is, well, a query language for a database, where GraphQL is something I like to call a query language for APIs. It looks a bit like this. You usually have a request that consists of multiple parts. We like to call this a document that you send to a GraphQL API, which contains sort of all the info you want from the API. And this is what you see on the left, and what you see on the right is the actual response. You can also see from how it's described. Your request, which you see on the left, has the same structure as your response, which you get on the left, which you get on the right. And this is something I always hated about REST. You send a request to a REST API, and you usually have no clue what will come back. You're pretty sure it's JSON. With GraphQL, you also get JSON. But with a REST API, you don't really know the information you're receiving, whereas with GraphQL, you can just send a request, you define it in the way you like, and you will get a request in the same format. Usually, you even get the same structure of order. So if you're maybe a developer that likes to have their data in order, then this could be very helpful. I like to say you ask what you need, and you get exactly that. If you grew up in the 90s like me, you might know the Spice Girls song. So you tell GraphQL what you really, really want, and you will get exactly what you really, really want from the GraphQL API. It is, well, like I said, if you grew up in the 90s, it's pretty cool. I even see a Buzz Lightyear t-shirt there, so it really means it's from the 90s. So GraphQL is a query language for APIs, and it also does, and this is the main reason for me at least to use GraphQL, it offers me a single endpoint for all my resources. So the thing I hate about REST, and it's fine if you say dislike instead of hate, or maybe you find it slightly uncomfortable to use a REST API, also okay with me. It offers a single endpoint for all your resources. So if you work with a lot of different data, you have data coming from databases, REST APIs, maybe multiple tables in a database, or maybe completely separate systems. REST APIs can be quite terrible, especially if they all use their own convention, their own sort of way to name things or structure things. With GraphQL, it's slightly different. So on the screen, you can see an example of a GraphQL version of a Twitter or X, I guess you call it X today, version of their API. They have typical REST API, so they like to structure their data by data entity, meaning that every table in their database will have a separate REST endpoint. They obviously will do some sort of abstraction to make your life a bit easier, but they don't do it completely. One of the things they don't do is if you send a request to the Twitter REST API endpoint to get all the tweets containing the word Einstein or Singapore or Cityjs, you will get a list of all the tweets containing this keyword. What they don't give you is the name of the author of the tweet. And this is because they have this REST API that is structured based on data entity. So they will have a relationship identifier to this author, like an author ID, or I'm not sure what their internal naming usage is, but the person that wrote this particular tweet. But they won't give you the name, meaning that in a REST API, you always have to send 2 separate requests to this API to get all the data you need instead of just one. So I created a GraphQL version of this API, and as you can see, I have created this nested relationship where I can get both all the tweets containing a keyword and also the user that wrote this tweet. So this is something that most GraphQL APIs will solve for you. You have one single request instead of all these separate requests. As mentioned, this is one of the key reasons for me to use GraphQL, and I will highlight this further later on as well. But this always bothered me when working with REST APIs, having to send all these different requests, needing to await. I remember when I started writing JavaScript, it might be 15 years ago, I was using jQuery, and it was pretty hard to stitch API results together. It was even harder as we didn't really have async await, so you sort of got lost in promise hell. I hope most of you don't remember promise hell, but it was pretty terrible, and REST APIs definitely helped you to get stuck in there. And finally, it's based on a type system. Saboon here is using TypeScript. Oh, nice, quite a few of you. So one of the things I also dislike about REST APIs is it doesn't have a type system. It's really hard to create types for the data you have in there. If someone changes the REST API endpoints or its response or the structure, you will have to retype your types. If you start using a new REST API endpoint, you have to create more types. So GraphQL is based on the type system itself. So not only do you get type safety in all your requests, you can also use this later on. This means that if you're interacting with a GraphQL API, and tooling is also an important reason for me to use GraphQL, it brings you a sort of visual way to discover your API, also to work with it. And typically in there you can find a visualized version of a GraphQL schema. So this schema is where the type safety comes from. And you can see a visual representation in most of these API tools. It used to be quite hidden because if you wanted to work with GraphQL, you needed to use Graphical, which was sort of a built-in JavaScript library where you could interact with the API. I think today most sort of API tools, even Postman, they have integration for GraphQL, so you can have auto-completion when you send a request, or they will give you a visualized version of the schema. So I see more and more API tools to start working with GraphQL, which is great. So it improves developer experience. I guess that is sort of my main reason to use it, because as I said, I don't really like REST APIs. They have particular things I don't like or even hate, and GraphQL will solve these. Not only by being a query language or having one endpoint for all these resources, or by being so generous in giving us all this tooling, it most of all improves my developer experience. And tooling like this, so this is Graphical, is one of the reasons it improves my developer experience. It's not only the tool, it's also the schema you have, the auto-completion you get here, and having one single endpoint instead of needing to stitch all these things together. And also, the type system is quite important for me because I like to work with TypeScript when I build a front end. And GraphQL can also be your BFF. So this is not best friends forever, but this is also your backend for front end. If you are a front end developer, maybe in a large or slightly large company, you probably have a backend for front end. You maybe work on one part of the application, or maybe you work on one of the 10 applications they're developing in-house, you probably have a backend for front-end. And GraphQL can be this complete backend for front-end. I will iterate a bit more later on, but it's really good to see that you can have one API format instead of 6 different ones. So when you use GraphQL, I guess this is the main reason I gave this talk, because as I mentioned in the beginning, I guess there's maybe some discussions around it, or maybe some unclarities around when to use GraphQL and when not to use GraphQL. I guess one of the main reasons to use GraphQL is, as I mentioned, multiple clients using the same data. Imagine you have this one API, you have this database containing your customer data or maybe orders. I used to work in e-commerce a lot, so you can find a lot of the examples I create are around orders and customers and products. It's, I guess it's a habit of working with all these different e-commerce projects. So multiple clients using the same data is a very good reason to use GraphQL. Imagine you have this one API that serves multiple clients. It could be a web app, it could be a mobile app, it could be different mobile apps, it could maybe even be white labeled apps. If one of you ever worked on a company that created white label applications, you probably really need GraphQL, because all these white label applications might need a slightly different version of an API. So for this, GraphQL is great, as it will give you one way to access all this data from all these different clients. And as I told you, you can use GraphQL in any way you want, and you can tell GraphQL what you want. So if one of those clients have different needs of data, and this data is present in the GraphQL API, they can use the same API without being constrained with what the other applications are doing. And this is a very good reason to use GraphQL, because REST APIs, they're static, they have a fixed data structure. If you add a new field to a REST API response, all these different clients will get the same field. And usually I like to give this background, like GraphQL was created by Facebook, and they open sourced it in 2015, but they came up with the idea already in 2012. And the main reason to do it was actually this reason. They were scaling across all of the different countries in the world. They were scaling across countries where they have different needs in terms of bandwidth. So I guess today we don't really care anymore about loading data on your phone, because data is kind of free. You have your mobile phone plan and you get usually as much data as you want, or quite close. I guess I have like a pretty small bundle of like 20 gigabytes, but still I don't really use it up because I'm on Wi-Fi half of the time. So we don't really care much about data anymore. When GraphQL was created, we cared a lot about our data usage, which was mainly because of cost, because you had limited bandwidth on your phone, but also your phone wasn't able to process if all this data you sent to your phone if you would send too much data. Today we don't really care anymore, which I guess it's also a bad thing. I did a talk once at a conference around how your bundle size is sort of bad for the climate. I like to say REST APIs could be bad for the climate as well. If you're not thinking about the data you're sending all this data to a phone or a computer. Every time it needs to be processed, it needs to be transferred from data center to data center. It's something people don't really think about anymore, but it could be a nice topic for maybe a next slide. So another good reason to use GraphQL is you have data in multiple places. And I guess this is mostly a topic for maybe a bit more for backend developers. Are there any backend developers here? A few. Are there any full stack developers? Okay, that's a bit more, that's good. So let's suppose we have some developers working with backends, and you might imagine that sometimes all these backends have their different API, or they have their different way to interact with them. With GraphQL, you can have one unified way of interacting with all these different backends. So this one GraphQL API doesn't care if you have data coming from an API developed internally, externally, a database maybe running MySQL versus a database maybe running Postgres, or even one of those newer database formats, maybe like a NoSQL database that already comes with GraphQL support. I guess there's lots of different opportunities here. I also like to say it's not only about having data in multiple places, it's also around having data that is exposed in different programming languages. So maybe a part of your company is building in JavaScript, a different part is building in Python or Go, or maybe even PHP or Java. If you have all these different programming languages, you probably need one unified way to access all this data, because otherwise, well, you sort of get stuck in having to interact with all these different frameworks. So for 1 and 2, I'd like to say GraphQL can be used as a data layer. So I remember GraphQL can be your BFF, whether that's best friend forever. I guess GraphQL and I are best friends forever since I started working with it somewhere around 2016, so pretty early on. But most of all, you use it as your backend for frontend. And I also like to say it's backend for front ends, as we saw it's really good for having multiple clients. So data access layer is a pretty normal term in computer science. I like to say it's a layer or a computer program that provides simplified access to data stored somewhere. So it's data stored somewhere, so it could be a database, could be an API, it could even be a JSON file you might be exposing from your computer. I guess most projects starts with a JSON file that you load instead of interacting with a REST API, because you need to find a way to mock this data. So you might also think a data access layer, it's a simplified way to access data from persistent storage. It's pretty much like an API, right? Because APIs are doing the same thing. They give you simplified access to data stored usually in a database. I like to say it's a bit like like this movie. It's a great movie. I guess the right person is now also an Oppenheimer, which I still need to see. But the thing I like here in this movie, they're going in a dream, inside a dream, inside a dream, inside a dream. I guess if you work with GraphQL, you're sometimes also stacking APIs, because you're building an API on top of your already existing APIs. So it could get dangerous there. It's one thing to know. But as most of your front-end developers, you probably don't really care about that part anymore. You just cared about having a good API that works for all your different data needs and different clients. So this data layer for GraphQL would pretty much look like this. You're stacking APIs, right? So you have this API that's already developed by someone in your company or maybe by yourself, and you start to create a GraphQL layer on top of it. It could also be inside your front-end app. That's perfectly fine. I see this happening all the time, especially with all these great front-end frameworks offering you ways to create like API routes inside the framework directly. So this could be a good way to create your GraphQL API there. One caveat, which we'll handle in a bit, but a data layer will look like this. And let's say it also scales across different clients. It doesn't scale if you create it inside your Next.js or Remix app, but if you create it as a separate entity, it scales across all these clients. And this is a bit like the backend for front ends part, right? So we have one API that we use across all the different clients, and if this is GraphQL, it doesn't really matter what's underneath. So it works with decoupled backends as well. As most of you are in backend developers, let's be quick about this part. But I like to say it's also great for this setup where you would have all these different programming languages inside your company. Like I said, developers building with Python, JavaScript, Go, Java. If you need a unified way to access all these different APIs and you sort of get in trouble with your other developers, like which programming language do we use to create this gateway or access layer for a company, then GraphQL can be great because there are many ways to create GraphQL APIs based on your existing data without having to create all this custom code every time. So each API service will have their own graph, and this is something we call GraphQL federation. I won't bore you with all the details, but if you are a backend developer and you're interested in GraphQL, make sure to have a look at whatever you can do there. And something else that sort of comes for free, and I like to say it comes for free when using GraphQL because it might not be the main reason to use it. With TypeScript, you can create type safety for your API. We have this schema. TypeScript has its own type system. If you're a bit of a type nerd, like myself, I can be a bit of a type nerd. Maybe I shouldn't be using TypeScript because there are better type programming languages, but TypeScript is doing a great job for me as a former JavaScript developer. It will help you to create type safety, meaning that if you have this data layer and you're using it from your clients, you can generate types based on whatever is in this data layer. So this can give you end-to-end type safety. even though your ends might not be type safe, especially the far, let's say, right end, depending how you would create your diagrams. I like to say, even if your your API giving you access to your database data isn't type safe, if you create a data access layer that's type safe, you can still get quite near to end-to-end type safety, which I'd say is like the holy grail of full stack development. So if you're a full stack developer, type safety will really help you, especially end-to-end type safety, because there's nothing worse than having an API that's being changed without you knowing it on the front end, or front end needs changing without, or data needs changing without you knowing as a backend developer. Brings me to the third point, why developers love GraphQL, and when you should use it. It might also be when you need a type system. And I guess this one we should really cross out, because if you're looking at GraphQL to get a type system, or at least type safety for your front ends, I guess most of the times you're looking at the wrong place. And this is also where all the discussions on Twitter or X are going on. People have been using GraphQL for a long time because they had this problem where they didn't get type safety in their front-end apps from REST, so they started looking at other things like GraphQL, which is good because it has a type system, it has a schema, you can generate types, so nothing wrong with that, but there are still things you might be missing or things you might be sort of over-engineering when using GraphQL. So let's look at a typical setup. I'm not really sure how I'm doing in terms of time, so maybe if someone could help me with that. So let's look at a typical setup today. We have a front-end application, could be mobile, could be web, could be both. Maybe it's like a hybrid one. You have a database. And this database exposed through an API. If you have this setup, I'd like to call this a one-to-one relationship with your backend or with your data. You have one end user and you have one sort of provider of your data. So if you want to change code to this project, it's pretty easy. You change the backend part, you change the front-end part, and you're pretty much settled. If you want to have type safety between the two, you need to make changes in both, because you're changing the backend part, you need to change the front-end part, update types, and whatnot. If you're using GraphQL for this, it's still the same. You change your GraphQL schema when you have new data, and you might need to update things on the front-end side to sort of iterate on this new data. The sort of annoying part is when you use GraphQL, GraphQL doesn't have TypeScript support out of the box. It means you need to use a library. So GraphQL Code Generator is great for this, for example, to generate TypeScript types based on your backend. So every time you change your backend, you need to change it in multiple places. You change your backend, you regenerate the types, you then start consuming it from your front end. If you have multiple clients, you need to regenerate all these clients in order to get the latest set of types. So this is sort of, well, it's okay if you have a large company, if you have CI/CD pipelines, if you have testers, it's okay and you get all the advantages of GraphQL. If you're a single developer, or maybe a small team of developers in a startup working on this one-to-one entity, it's not the most ideal situation. You need to generate types, you need to make changes in multiple systems. So is it really the best solution? And this is where all the discussion is going on, is going about. So it really depends, I'd say. If you're a GraphQL lover like myself, I probably will keep using GraphQL even until I die. So it really depends. But tRPC might be a better option for you if you have this solution where you have one backend, you have one client using it. With tRPC, you get a framework to build TypeScript APIs. They are sort of type safe by nature. So if you make changes to your data or your data layer, those will be reflected in your client as well. So when you're accessing the data, you don't even have to type types because it's all sort of implicit, as types are defined only once, which is sort of at the data level. So if you have this one-to-one entity, I'd say use tRPC if you want to use TypeScript. And there's one caveat though, if you are hoping to scale in the future, you should think about any opportunity cost you might have when needing to refactor all this to GraphQL if you have multiple clients, if you start to have multiple programming languages, if you decide to, I don't know, maybe white label your application. As a startup, things are moving fast. tRPC helps you to move fast and break things, but I don't think it scales that good if you are getting multiple programming language in the future. I have a video on YouTube around this. It will probably help you to find out if tRPC is better for you than GraphQL. I can give probably an entire talk around this topic. Maybe I will do next time. So it's great for one-to-one setups, which maybe most of you are working on, maybe some of you are working on in your side projects, and especially when they need to be type safe. So back to GraphQL. So GraphQL is best for if you have like a one-to-many, so where you have one backend that serves multiple clients, or when you have multiple backends serving multiple clients. Because there you would really benefit from having this one solution for all your data, no matter where it resides or how you're using it. It's something else I really like, and this will be the end of this talk. It's a declarative language. And I told you in the beginning, it's a bit like SQL for APIs. So it's a declarative language like SQL. And SQL was actually my first sort of introduction to programming, because I was working with some open source software to build an e-commerce platform. And I needed to sort of change the data I got in my application. And the best way to do this was by changing a SQL query, because it sort of automatically changed my APIs. So SQL is what you see on the right. Probably most of you are familiar with SQL. And in SQL, you sort of define the fields you want to receive. So you can say select name and email from this database where this condition is equal to whatever. This is what you see on the right. So I like to say this is declarative because you're not telling SQL how to do it. You're only telling SQL what to do. GraphQL schema definition language, or this GraphQL query language, to define you want to have a customer that matches with this parameter that says email is equal to johndoe@example.com and return these fields for me. So it's also very declarative. You're not telling GraphQL how to do slightly a little bit on how to interact with the API and how to get data out of it. I guess for SQL, most people don't really know how SQL works, or don't really get past this sort of select statement with a join. Does anyone know the difference between a left join, inner join, right join, these kind of things? I don't, honestly, but I sort of try them all, see which performs better, but I'm not a database expert. And I guess most developers are in database experts, so that's where a declarative language comes in handy. So it's easy to work for developers, but it's also easy to work with for other systems. And for this, I like to say it's also easy to work with for AI or generative AI. They don't need to know how GraphQL works in detail. They only need to know how to interact with it on sort of a global level. So one of the projects we're working on internally, and I tweeted this a couple of days ago, I hope all of you are working on projects internally for your company or in a side project around something with AI or generative AI. I hope you're exploring what it can do for you as a developer, what it can do for you as a company, because in my opinion, it will be the real next big thing for all of us. So I hope you're exploring and trying it out on your own as well. So GraphQL, as it has a declarative language, it can also be easy to interface to this language from other tools, such as AI. So let's say you would have a prompt asking to some system, when will my package arrive? If you ask this prompt to OpenAI or maybe any sort of ChatGPT thing, they don't really know what to do. If you ask this to a GraphQL client that doesn't really know what to do as well, it's still the same question. So when will my package arrive? If a generative AI or LLM system doesn't have real knowledge of a GraphQL API, they would still be able to generate queries based on the schema. So the GraphQL schema will always be exposed on every API. So the only thing the generative AI needs to know is how to write a query and how to sort of read the schema. So if you have an agent, which could be using GraphQL, that knows how to get data out of databases, how to get data out of APIs, it would be able to translate your prompt into a GraphQL query. And you don't really need rocket science for this. It's a declarative language. So in my feeling, it really gives us opportunities to build new cool things. So based on whatever data GraphQL can get out of you, the agent would be able to retrieve this information from the GraphQL API and then give you back the information. And I know there's more talks around AI today, so if you aren't using any of this today, make sure to read into it and make sure you, well, at least explore it. I like to say it's not a threat, it's an opportunity. It's only a threat if you don't know what's going on. So this is a more complicated setup. I will share this maybe on Twitter just because I'm running out of time and I want to be respectful to next speakers as well. So to recap, the reason I think you should use GraphQL, it's great because it's a query language for APIs, a bit like SQL. It's declarative, which gives great opportunities for the future. It offers you a single endpoint for all these different resources. So if you're working with different databases, different services, different APIs, and you want one way to play with all of them and get data from it, GraphQL is really your go-to thing. It has great tooling and it's based on a type system. But as I mentioned, it might not be the best solution if you're only looking for a type system, especially if you're working with one-to-one relationships where you have one client and one API. So GraphQL is great for multiple APIs, multiple clients, these kind of setup. Otherwise, you might be best looking at something like gRPC. And the declarative language is not only easy to work with for developers, but also for other systems and potentially even AI. So this gives great opportunities to keep using GraphQL for all your data while building on top some great generative AI solutions. So that's it. Thank you all, and I hope we can stay in touch either on Twitter or in this conference because we have a full day ahead of us. So thank you, and I hope you learned some new things.
Thank you very much, Roy. Funny that you mentioned about AI, because we have Tamas coming up now to speak to us about using AI for user experiences. Just while Thomas is setting up, does anybody use PHP? Some of you. That's good that we're at a Java conference today. And we all know that Java is the same as JavaScript.
I'm going to use that first and then that one.
Okay. So we have a break after this as well. And so let's enjoy Thomas's talk and then get some coffee and a nice snack as well. Thank you, Thomas.
All right. Good morning. Nope. Good morning. Guess who's from the US? All right, so good morning, everyone. How's everyone doing? Okay, that's fine. So, who's excited about AI? Okay. We can do this. So, so Roy did, he said some amazing things about AI. So I'm just going to reiterate pretty much everything that he said, and I'm also here to fulfill your largest generative AI dreams. Okay, hopefully that's the plan. Now, before we get started, so you notice I'm walking around quite a lot. Who has seen me deliver a talk before? One. You definitely know what's coming, right? Okay, so what I'm going to start with, as you think, yes. Who has heard about this paradigm? Fresh body, fit mind. A few of you. Okay, so for those of you who haven't, what this means is that in order for your brain to function correctly, get those brain juices flowing, you're supposed to do some exercise, right? Now, because, this is the third talk, we are going to exercise, so let's all stand up. So I always find it hilarious because I always just see all of your faces, right? You don't see other people behind you, and there are some people like, yes. Others are like, oh, So, what we're going to do, the exercise is going to be really simple, okay? So I'm going to show you my back, so apologies for that. So all you need to do is raise up your arms so that your elbow is in line with your eyes. Yeah, elbow is in line with your eyes, yeah. Open up your palms. Okay? And then put them together repeatedly, very loudly. Yep, 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 yep. All right. Just for some people that still are not aware of what's going on, okay? So I'm going to change to is this working? I did press the button and it's green. Okay, can you hear me fine? Do I switch this off? I'll give this to you. So thank you for the standing ovation. I usually say this, but I'm going to say this again. So what happens with these pictures, right? I collect them, send it to my boss, and hope for a pay rise, right? But I've been doing this for years now. He doesn't understand what is the thing that I'm saying that gets people to stand up and clap, right? So there you go. Okay, so what I'm going to talk to you about is pretty much generative AI in the context of media on the web. Okay, so obviously, you know, a lot of websites, let's just get rid of James here, because he's very annoying now. So essentially, you know, most of the websites that you use and you visit have some media assets on it, right? Whether that's images and videos, that's not, you know, it's given, right? So visual experiences are key when it comes to delivering a website that is engaging to your audiences, okay? So just a quick question, who here has ever created a website that has 0 images? Okay, 2. You did, why are you didn't, you did, I know you did. Cool, which is good. So essentially, visual media it can be a competitive advantage, right? How you present your images, how fast your images load are all going to be driving forces if people are going to buy your products, you know, whether they're going to come back to your website. And you know, all the effort that Google is doing in terms of the core web vitals and, you know, largest contentful paint is also reinforcing this. Now, the other aspect of this is, you know, looking at the performance of your visual media assets, it's not only about how well or you know, how optimized your images is, whether you use AVIF, some WebP and other formats, but also how fast you can launch new products, how fast you can go to market with whatever it is that you're doing, right? And also the speed of that does matter, okay? Now, I don't know, this is completely irrelevant, but I don't know how many of you have noticed that if you go to YouTube, all these videos by these influencers are just faster, right? It almost feels like they just talk really fast. So everything is faster, right? So the faster you can get things done, the better. Now, at Cloudinary, so I work for Cloudinary, I didn't say that, but I think that's obvious because of the logo on the slide. But essentially, you know, we have the, who uses Cloudinary? Oh my God. Has work to be done in Singapore. Okay, so so Cloudinary, what do we do? I will tell that to you in just a moment. So we take your images and videos, you can upload it to our platform, which is a cloud-based platform. You get an access URL, and then you can now optimize, transform, and deliver those media assets, images and videos, okay? And because of this, we also have access to, you know, all this image data and all our customers, you know, who are delivering these images. We started to put together some reports. Now, in one of the reports, we found that between 2019 and 2022, the image bandwidth, and these are, you know, Cloudinary resources, and we're talking, you know, nearly 200 billion requests per month, grew by 25%, and for video, the traffic, especially for retail and e-commerce, grew by about 37%, right? So there's a lot of people delivering engaging visual assets via Cloudinary. E-commerce also changed from, you know, being like, hey, you know, let's just create a website, let's put some products there, to become an epic scale machine, right? There's so many things that Shopify is doing. Maybe I shouldn't mention that company now. But there's, you know, there's a lot of work that Shopify is doing. A lot of people join Shopify. You know, it's all about, you know, how do you scale e-commerce solutions? And of course, there's this new thing, which I'm not going to get into because there's should be a separate talk, but hopefully some of you have heard about this term composable architecture, Mac Alliance. So if you look up Netlify, which is a company that I'm sure you're all aware, they're all about composable everything these days. Okay, so just check that. But essentially the point is, and this is, kind of piggybacking on what Roy was saying about AI, is thinking about, can AI help? Can AI help you be more productive? The answer is, of course, it can if you know what you're doing, but then how does it apply to a setting where you work with visual media assets? How does that work with videos? How does it work with images? And that is what we're going to talk about. Because essentially, what I'm trying to prove to you now is that AI-based things, AI-based transformations, and there's a couple of features that I'm going to show you here, are going to make your life easier, okay? So the question is, what can you do to help as a developer in a world where everyone wants to go to market really fast, but there's also the demand where everything has to be performant, has to be, done at an epic scale. So we're going to start with image transformations. And the very first thing I'm going to talk to you about is the generative background fill, okay? So generative background fill is one of the very latest features that Cloudinary has launched, and we're going to use this wonderful lady as our example. So let's say that this is your product image, okay? So this is, you're selling the shirt or the shorts, and hopefully not the lady, but you never know. But essentially, this is your image. And now you will ask, okay, make this a hero image. Make this image to be 1,500 pixels wide. So what do you do? Well, the best you can do is to actually generate an image that's, that size, and you maybe fill the background with the predominant color from the picture, okay? And this is, it's okay, it's not great, but now you have created a hero image. Now, what if you could do this, right? This is a lot better, and this is exactly what the Cloudinary generative background fill does, okay? So it basically allows you to scale any image into any dimension by replicating whatever is there in the background, right? So you can basically resize images without having to add either a white or just a single colored padding around it. Okay, so this is the source code for that, or the syntax for that. This is using the JavaScript SDK, and then there's all the resizing and everything else, but the key is in the background method where you specify gen fill. So gen_fill is going to do the generative background fill. Pretty cool, if you ask me. So, generative background, check. Generative replace. So, what is generative replace? So, in the world of Cloudinary, and again, we're focusing on images mostly here, generative replace really means two things. You can either replace a color, or you can replace an object or something within the picture itself. Okay, so this is going to be our baseline image again. The guy looks a little bit grumpy. I'm not sure why that is, but regardless, let's say you're selling this, right? You're selling the suit. Or you want to use this image on a different page where, the colors don't necessarily match the suit. And you want to say, okay, wouldn't it be nice if the guy would be wearing like a dark brown suit? So you just use color replace to achieve this result. Or if you say, well, actually, you know what, that's not good enough, let's make the guy look a little bit happy, let's just change the tie to pink, right? So, he's now looking a little bit more jolly. So you can basically change the picture, and this is using color replace, to kind of match the look and feel of what you're trying to do. And also, technically, this should allow you to not to have multiple product shots, right? Because what if you sell a t-shirt that is white, red, blue, you have multiple colors of that, you can just use this to take one picture and then keep on replacing the color. Okay, so this is how it looks like. So for this one, you have to do this with what we call a row transformation by adding the add transformation method, which basically says, do the generative recoloring, find the jacket, and then toColor is going to be the color that you want to use. Okay, so you're recoloring the jacket to be brown. So this is the color replace, but then there's also another type of replace, which is you have one picture, and then you say, okay, that's not healthy enough. Let's get rid of the cookies and use an avocado, because we're all about health and fitness, as I kind of showed you why it's important, right? So then, you can do this. Or you could go, completely different and say, you know what, this is not fitting the design that I'm doing, so let's just have a coffee mug, right? So this is using generative replace. Again, you can see syntax is on another slide. So this is how the syntax looks like, where you say, replace the cookies to, and then whatever else you want to use. Okay, so in this case, the example shows a coffee mug. Now, why is this useful? Well, imagine that you have a picture of this wonderfully handsome speaker of yours, and now, oh, that's me, hang on. Whew. So now what you want to do is, maybe you want to use this in a marketing material, which I hope they will not, and then obviously there's the Apple logo. You don't necessarily want to do that, so what you do, well, you just tell AI to, hey, remove that, okay? And now you end up with this same image, but you can now confidently put this on any of your marketing material without having Apple breathe down your neck, probably. Okay, so this is again using generative remove, where you say, what is the thing that you want to remove? And the prompt was just find the Apple logo and remove that. Now, for a bit of fun, a handsome speaker can become even better, okay? I know I don't dress well, but I can make myself look very professional. And then let's all forget that everyone here, audience and speakers, we are all, okay? Just saying, okay? This is AI. I didn't Photoshop that, I promise, okay? Right, so image capturing, right? So here's a question for you. How many of you genuinely add meaningful alt text to your images? Yeah, about like 10. So what if you could now automate that, right? What if you could now have all these images and just have AI describe what's on the image and then use that text to put it as an alt text, right? Again, completely automating this for the sake of accessibility. And here are, again, two examples. One you saw with the cookies, and here's another one where the text basically comes back from a captioning algorithm. Okay, so the way that works is slightly different. So this is now showing not the JavaScript SDK, but the Node.js SDK, just to simplify the upload. So when you do an upload programmatically to Cloudinary, you can now pass an option that says detection captioning, and when you get the response from the uploader, which is basically all the information about the image, metadata and whatnot, you are now getting a detection object as well, which says, in this case, the sun is setting over the water, yada, 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 which now you can use as alt text for your images. Okay, so upscaling. This is, again, very cool, right? So upscaling to super resolution. So what does that mean? So let's imagine you have this original image. This is the size of the image. And for whatever reason, you want to put this image into a container, which is about 4 times larger, or you want to scale this image up, okay? And natively, you can do that. You can do it in CSS. You can do it whatever way you want to. You can do this with Cloudinary as well. So you say, resize scale width is 4x, essentially. And then you're going to end up having this, and hopefully you see that this is ugly, right? This is now pixelated, lots of visual artifacts and defects, really not good. So now, this was launched, I think, last week. You can do a transformation, which is called an upscale effect, which is basically going to use AI again to repaint the image at a super resolution. Okay, so this is now the very small image scaled up to a 4-time resolution and corrected and upscaled using AI. Now, I did mention that Cloudinary not only does images, but we also do videos. So I have a couple of examples, and I just call them the honorable mention video. So we're not going to play this, but imagine you have a video, and you can check the URL later. This is a video that I've done, okay? This is about 1 minute and 49 seconds, if I'm not mistaken, where I'm just like, diving, and there's going to be a couple of sharks and other things that come along. Now, what if, you have lots of such videos, and, your goal is to maybe show a preview, or show a shorter version of the video that captures the essence of the video itself. So let's wait for the first shark. Did it appear already? Okay, so fish. Where's my shark? Shark. Come on, shark. Sharky, sharky. Baby shark, mommy shark. You can tell I have a son, right? There it is. Okay, so there's a shark, and there's, later on around like the 1 minute 30-second mark, there's going to be another one. So what if I tell you that you can now ask Cloudinary to say, look at the video and give me a preview, which is 15 seconds, and you decide, based on, again, various AI features, what is, in essence, the most important part of the video. Okay? Now we are going to play this because it's only 15 seconds. So this is what AI came up with. Okay, so some fish. Then we get shark number 1. And I think some more fish. And then, ooh, shark number 2. Okay, and I didn't edit this. I just let Cloudinary to do this on its own. And then the last thing I'll show you, and then break time. So imagine you have this video again where, you know, a couple of ladies are playing football. Okay, so they're passing the ball around, and, you know, this is all great and jolly good. But now you want to crop this video. You want to create, say, a much smaller version of it, say 305 pixels height. Now, if you crop it, an automatic crop, or you know, any crop, would essentially focus on the center of the picture, or in this case, the video. That's not what you want, because what you will end up having is just the grass, right? There's nothing happening in there. So what you can do, you can actually tell Cloudinary to, hey, look at the video, focus on the ball, and create the crop by following the object that I'm specifying here, okay? So the end result of the video is going to look like this, okay? So the crop is at all times going to just follow the ball in action, okay? So, a lot of examples, right? But essentially think about the use cases and the things that all of these features enable you to do, right? So there's, of course, you know, productivity to start things off, right? There's the whole developer experience, user experience, customer experience. There's the accessibility angle whereby, you know, you can just get all these old images. So essentially, and again, loving Roy's kind of intro to this, but using these AI features should allow you to have much better workflows, much easier workflows, and allow you to focus on the application creation as opposed to, you know, going into Photoshop or asking your designer to do something. And, you know, essentially it's going to give you less complication in life or in your development journey. At least, fingers crossed, and that's what we're hoping for. And of course, what I'm not saying here, so for those of you who know Cloudinary, you know, with all the optimization and all the basic transformations features that we have, everything that I showed you now is just a layer on top of that, right? So now, if you want to recolor someone's jacket or I don't know, replace a cookie with an avocado, you can do that. Plus, you can ask Cloudinary to deliver that image in the most optimal way. So you could say, hey, deliver this as an AVIF, as a WebP, you know, crop it down from, you know, the original size to say 400 by 400. And then all the other features are there, but then now we complement everything with these various generative AI and other AI features. So, it will take a second, but you will see it. So, this is Mothership, right? Singapore's most beloved news portal. For those of you not from here, it's not, okay? So they started to use generative AI to sort of, you know, add images to their posts. So the very first thing that you will notice is, hey, the guy's thumb looks funny, and then you realize he has 6 fingers. Okay? How many did you notice that? It's tricky, right? So yeah, the guy has 6 fingers. So this is a proper screenshot from the website. So I'm going to say, do use AI, because it will help you, but be mindful of some of its limitations. Now, one of the limitations of generative AI is the fact that it has a lot of trouble generating hands. Okay, you can actually Google this. There's been some research done on why this is, but any time when there are hands involved, generative AI is failing epically, okay? Mothership did not, anyone works for Mothership here, by the way, just before I say what I want to say, okay. 6 what? But you don't work for Mothership, so I don't get it. But anyway, so just be mindful about, you know, just double check what you're doing, okay? That's what I'm trying to say. Okay, so a couple of references, you know, you can take a look at all these, you know, release notes and blog posts from Cloudinary. We also have a booth out there where I have my wonderful colleagues. We have lots of stickers and unicorns and a lot of stuff for you to have. So do come and chat with us as well. And with that, thank you very much for listening.
Thank you, Thomas. So let's give a round of applause for all 3 of the speakers this morning. And so we're going to be doing a 15-minute break, so please go to the room over there, and there's some sponsors. You can get some prizes, so don't be scared to speak to any of the sponsors. And there's also food and coffee as well, so see you in 15 minutes, everybody.
We did it! We made the app. That's only half the story. Soon, with a little luck, we'll have a ton of people using and loving our product. That means user accounts, authentication, security. You know the drill. But this part right here can be just as important as the app itself, because behind this login box is a lot of your users' information. And they're trusting you to keep it safe. It's important, but it doesn't have to be hard. That's why we use Auth0. It's an identity platform for developers that makes it easy to connect any app, like ours, to the authenticators and integrations we need. But wait, I bet you're like, we could do that ourselves. It's not that hard. We know what we're doing. First, I hear you. Second, are you sure? Users want security and flexibility. You want to give them all the newest sign-in options as soon as they're available, because they want to use your app on their terms, not yours. With Auth0, I can easily customize my login with the features my users want. I can create a custom two-factor authenticator for added security, and easily enable the multi-factor authentication methods I want. It even has breached password detection, so if someone else has a security breach, I can keep my users safe. Our security is always up to date and regulation compliant. You made an app, and Auth0 makes a better, safer experience for your users.
Are you still testing your web applications by hand? Really? Come on. Don't tell me you're too busy to automate testing. With UILicious, testing is a piece of cake. UILicious is a low-code platform for cross-browser testing. Our philosophy is test user journeys, not HTML. Let me show you. Here's how I write a test for github.com. First, I go to github.com. Then, I click Sign In, and I fill in the email and the password. Finally, I click Sign In, and I should see the error message, incorrect username or password. Let's select a browser, and press the Run button. Ta-da! The test is complete. I can also use UILicious's test authoring AI assistant to generate tests. Let's generate a test to log into Netflix and change password. Sweet! Once I've set up the test, I can schedule it to run anytime, any day, even when I'm asleep or on vacation. I can also set up notifications to alert my team when the test has failed. Now, with automated tests, I can know for sure if my new changes are good to go into the hands of my users. Try UILicious for free today.
miles per hour. 300 sensors. 1.1 million data points a second. Sent instantly to the AWS cloud. So machine learning can react in real time to keep millions of fans on the edge of their seats. If AWS can do this for F1's data, imagine what it can do for your business.
We did it! We made the app. That's only half the story. Soon, with a little luck, we'll have a ton of people using and loving our product. That means user accounts, authentication, security. You know the drill. But this part right here can be just as important as the app itself. Because behind this login box is a lot of your users' information. And they're trusting you to keep it safe. It's important, but it doesn't have to be hard. That's why we use Auth0. It's an identity platform for developers that makes it easy to connect any app, like ours, to the authenticators and integrations we need. But wait, I bet you're like, we could do that ourselves. It's not that hard. We know what we're doing. First, I hear you. Second, are you sure? Users want security and flexibility. You want to give them all the newest sign-in options as soon as they're available, because they want to use your app on their terms, not yours. With Auth0, I can easily customize my login with the features my users want. I can create a custom two-factor authenticator for added security, and easily enable the multi-factor authentication methods I want. It even has breached password detection, so if someone else has a security breach, I can keep my users safe. Our security is always up to date and regulation compliant. You made an app, and Auth0 makes a better, safer experience for your users.
Are you still testing your web applications by hand? Really? Come on. Don't tell me you're too busy to automate testing. With UILicious, testing is a piece of cake. UILicious is a low-code platform for cross-browser testing. Our philosophy is test user journeys, not HTML. Let me show you. Here's how I write a test for github.com. First, I go to github.com. Then, I click Sign In, and I fill in the email and the password. Finally, I click Sign In, and I should see the error message, incorrect username or password. Let's select a browser, and press the Run button. Ta-da! The test is complete. I can also use UILicious's test authoring AI assistant to generate tests. Let's generate a test to log into Netflix and change password. Sweet! Once I've set up the test, I can schedule it to run anytime, any day, even when I'm asleep or on vacation. I can also set up notifications to alert my team when the test has failed. Now, with automated tests, I can know for sure if my new changes are good to go into the hands of my users. Try UILicious for free today.
miles per hour. 300 sensors. 1.1 million data points a second. Sent instantly to the AWS cloud. So machine learning can react in real time to keep millions of fans on the edge of their seats. If AWS can do this for F1's data, imagine what it can do for your business.
We did it! We made the app. That's only half the story. Soon, with a little luck, we'll have a ton of people using and loving our product. That means user accounts, authentication, security. You know the drill. But this part right here can be just as important as the app itself. Because behind this login box is a lot of your users' information. And they're trusting you to keep it safe. It's important, but it doesn't have to be hard. That's why we use Auth0. It's an identity platform for developers that makes it easy to connect any app, like ours, to the authenticators and integrations we need. But wait, I bet you're like, we could do that ourselves. It's not that hard. We know what we're doing. First, I hear you. Second, are you sure? Users want security and flexibility. You want to give them all the newest sign-in options as soon as they're available, because they want to use your app on their terms, not yours. With Auth0, I can easily customize my login with the features my users want. I can create a custom two-factor authenticator for added security, and easily enable the multi-factor authentication methods I want. It even has breached password detection, so if someone else has a security breach, I can keep my users safe. Our security is always up to date and regulation compliant. You made an app, and Auth0 makes a better, safer experience for your users.
Are you still testing your web applications by hand? Really? Come on. Don't tell me you're too busy to automate testing. With UILicious, testing is a piece of cake. UILicious is a low-code platform for cross-browser testing. Our philosophy is test user journeys, not HTML. Let me show you. Here's how I write a test for github.com. First, I go to github.com. Then, I click Sign In, and I fill in the email and the password. Finally, I click Sign In, and I should see the error message, incorrect username or password. Let's select a browser, and press the Run button. Ta-da! The test is complete. I can also use UILicious's test authoring AI assistant to generate tests. Let's generate a test to log into Netflix and change password. Sweet! Once I've set up the test, I can schedule it to run anytime, any day, even when I'm asleep or on vacation. I can also set up notifications to alert my team when the test has failed. Now, with automated tests, I can know for sure if my new changes are good to go into the hands of my users. Try UILicious for free today.
miles per hour. 300 sensors. 1.1 million data points a second. Sent instantly to the AWS cloud. So machine learning can react in real time to keep millions of fans on the edge of their seats. If AWS can do this for F1's data, imagine what it can do for your business.
We did it! We made the app. That's only half the story. Soon, with a little luck, we'll have a ton of people using and loving our product. That means user accounts, authentication, security. You know the drill. But this part right here can be just as important as the app itself. Because behind this login box is a lot of your users' information. And they're trusting you to keep it safe. It's important, but it doesn't have to be hard. That's why we use Auth0. It's an identity platform for developers that makes it easy to connect any app, like ours, to the authenticators and integrations we need. But wait, I bet you're like, we could do that ourselves. It's not that hard. We know what we're doing. First, I hear you. Second, are you sure? Users want security and flexibility. You want to give them all the newest sign-in options as soon as they're available, because they want to use your app on their terms, not yours. With Auth0, I can easily customize my login with the features my users want. I can create a custom two-factor authenticator for added security, and easily enable the multi-factor authentication methods I want. It even has breached password detection, so if someone else has a security breach, I can keep my users safe. Our security is always up to date and regulation compliant. You made an app, and Auth0 makes a better, safer experience for your users.
Are you still testing your web applications by hand? Really? Come on. Don't tell me you're too busy to automate testing. With UILicious, testing is a piece of cake. UILicious is a low-code platform for cross-browser testing. Our philosophy is test user journeys, not HTML. Let me show you. Here's how I write a test for github.com. First, I go to github.com. Then, I click Sign In, and I fill in the email and the password. Finally, I click Sign In, and I should see the error message, incorrect username or password. Let's select a browser, and press the Run button. Ta-da! The test is complete. I can also use UILicious's test authoring AI assistant to generate tests. Let's generate a test to log into Netflix and change password. Sweet! Once I've set up the test, I can schedule it to run anytime, any day, even when I'm asleep or on vacation. I can also set up notifications to alert my team when the test has failed. Now, with automated tests, I can know for sure if my new changes are good to go into the hands of my users. Try UILicious for free today.
miles per hour. 300 sensors. 1.1 million data points a second. Sent instantly to the AWS cloud. So machine learning can react in real time to keep millions of fans on the edge of their seats. If AWS can do this for F1's data, imagine what it can do for your business.
Learning using JavaScript. And this is a little thing about me. Right now, I'm a partner and a head of engineering at 01 Group. It's a software my master's degree in machine learning in local university in Indonesia. And actually, I'm contributed a lot in Python communities. I'm also the organizer of PyCon Indonesia, and we will held this year in 2023. And that something fun about me, I hated JavaScript before. Is anyone here hated JavaScript before? Please raise your hand. I still hate it. Okay. So I'm equally right now because I have understand about software engineering. So I love every language, and also a GDG cloud expert in cloud. And just little bit advertising with my company. This is our work with the Bloomberg. So we created a dashboard to track coal plant around the world. So if you have your country about the progress of renewable energy, you can check this website out. It's called Bloomberg Global Coal Countdown. Okay, to explain, we have three parts. The first one is to understand what is the numerical computation and machine learning library in JavaScript. The second one is how we learn machine learning in JavaScript. And the third one, what's the future hold for JavaScript and machine learning. So for today, I just want once again ask you about the question, how many of you in here already learned about machine learning? Please raise your hand. Have any background on computer science, mathematics? It's not, okay. It's not really that much. So I'll try to explain more easy for this one. So what is numerical computation? So basically the numerical computation is how you manipulate multi-dimensional arrays. So for essentially it is a calculus and linear algebra for computers. So for example, if you have image, it's a tensor, 3x3 matrices, then you need to calculate. So for the previous talk, like in Cloudinary, you need to calculate some kind of this stuff in the background of the server of Cloudinary. And why using JavaScript? The first one, yes, because web is open platform, you don't need some kind of app store to distribute your application. The second one is explorable explanation, because you can storytell with a single page interactive web page. For example, it's from Josh Camo. He explained how waveform is. The third one is the obviously largest developer community in the world. And the last one is privacy and security. Why? Because you can deploy your machine learning model inside your browser, user browser. So you don't need like gigantic server that user need to send their data to the server and give the prediction back to their device. And why not using JavaScript? If you are using vanilla JavaScript, directly in JavaScript engines is all about performance. It's not really that good. And the second one is the community is not focusing on numerical computation yet. There are not a lot library with numerical computation and lack of native multi-dimensional arrays. So my background is from Python. There are a lot of computational numeric such as NumPy, Pandas, or Polars that written in Rust. So I will give you 3 influential machine learning libraries in JavaScript. The first one is a Brain.js. It's using the GPU, using GPU.js for computation. And if there is no GPU, it will fall back to CPU. The second one is ML5.js. Is anyone in here familiar with Daniel Schiffman? Please follow him, because if you want to learn animation, physics, simulation, he really good at it and have a lot of courses on YouTube, and it's free. So please follow him. And the third one, I think is the most popular and the most have a good documentation for machine learning. It is TensorFlow. And today, I will explore some kind of features in TensorFlow.js. So if you're familiar with TensorFlow, please raise your hand. Yeah, not really that much, but TensorFlow is usually you can use Python to interact with TensorFlow core written in C++. But right now you can directly use TensorFlow core using JavaScript. So there are multiple parts of TensorFlow JS. So the layers API, you can create the machine learning model, and the core API is written in C++, and you can connect it, you can deploy it to multiple platforms like browser using WebGL, or you can use server-side deployment in Node.js. Okay, how we learn machine learning in JavaScript? There are two ways to learn machine learning in JavaScript. The first one is the hard part. You must understand the mathematics behind machine learning. You must take calculus and linear algebra to understand what's the mathematical computation behind. The second one, I think will much easier for the rest of us as a web developers. You can try to build things and really to understand how it built. But we will explore both of these. And the first one, introducing to building machine learning model in JavaScript. There are several steps from 1 to 6. We will explore each of them. So if you have simple index HTML, you just put the script tag, import the TensorFlow JS. It's just very easy. And if you are familiar with machine learning, this is the dataset that you will run as a beginner. This is Iris dataset. It has 150 data, and it contains 4 variables: sepal length, sepal width, petal length, petal width. So it's the measurement of the flower, three species: Iris versicolor, Iris setosa, and Iris virginica. And the task of machine learning is to how to classify, if you get the new data, which class it belong to for the data. And this is the data looks like in CSV. So it's sepal length, sepal width, petal length. And the target, the classification on the last column is the setosa, virginica, and versicolor. And you can use TensorFlow directly in the index HTML, just script on JavaScript. You can use TensorFlow to load CSV, and then you need to do some one-hot encoding. So if you don't familiar, don't worry, I will explain it later. Basically, to represent the species of the classification to numerical. And when we are building the model, so TensorFlow you can build machine learning neural network in TensorFlow. It's basically like a brain. So it's connected neuron, and it will compute it. So you can classify what is setosa, what is virginica, and what is versicolor. And this is what is meant to one-hot encoding. So setosa have their own numeric 1, virginica 010, and versicolor 001. So this is the representation of computation in our machine. And for building and training the model, we can create the neural network with 2 layers. So this is the input layers with the 4 features, and the output, the outcome. And you can use model.fit to training your machine learning model. And it will run 100 times or 100 iterations, or we call it epoch. And finally, we can test the model with 3 separated data. So for this example, I will use one data that will expected to come as a setosa. And this is how we deploy it to the browser. So this run in localhost. Just run the training on your browser, and then it will run 100 times epoch. And the loss is like the metrics that we can use how well your machine learning model does. And yeah, it will come alert. It says setosa. So it correctly predict to the data that expect to become setosa. Now, I think the second one is more interesting. As a web developer, we tend to understand what we build. So the second part is how we build or explore something machine learning in web. The first one, you can explore your machine learning model. There are a lot of it. Maybe simple face detection, body segmentation, hand pose detection. But for this exploration, we will use pose detection to understand the human pose or human movement that we can track on the computer vision. And also in the TensorFlow documentation, there are a lot of examples. So you don't need to understand from scratch how we can build machine learning model in the browser. And this is me. So I went to National Library of Singapore. I run some machine learning model. This is run in browser and can detect some workout. So for example, squat, then yeah, I just doing some workout in the library. And after you build something for it, you must understand how it works. So basically, the machine learning model will come out the 70 key points on the human side, and the data itself is just look like the right side of the slide. So you have the coordinate of x and y, and you need to compute what the squat movement looks like. So this, and basically, if when you building something machine learning model in a web, you also need to understand a little bit mathematical computation, because if the model want to know how good your squat is, you need to compute the angle of the angle of your body. Then it's this simple mathematics about how we compute an angle of two factors. So basically, if you want to build some machine learning, you still need to understand some kind of mathematics itself. Okay. So which better? Which the way number one or way number two? So I will say it's complementary. So if you have background on mathematics, computer science, I think I'll recommend to you need to understand the math behind of it. But most of the time, if you are developers, you can try to build by yourself and try to understand later. So I think it's no which better, but it's complementary. You can build it or you can understand it. You need both of those. And finally, what's the future holds? The interesting part is TensorFlow can run in the multiple backend. So you can run on your CPU, WebGL, you can use WebAssembly, and the new initiative, WebGPU, you can run on your Node.js, and even you can run in React Native. So if you want to build machine learning model directly run on your mobile device, you can use TensorFlow.js. So you don't need to understand, because in TensorFlow there are another library called TensorFlow Lite, but it run in native mobile application like Android or iOS. But if you don't want to learn Kotlin or Swift, you can just use JavaScript and run your model on mobile device using React Native. And the future improvement of runtime, it will depend how our device will going much faster and how the abstraction for the running inference model can be much faster too. And also, there is a new initiative, and it also built by W3C that called WebGPU. WebGPU is a successor for WebGL that can run efficiently than WebGL, because WebGL is focusing on high performance graphical computation, but when you are using WebGPU, you can also focusing on performance faster machine learning inference. And it's designed for JavaScript. So I think the future is really good for JavaScript and doing some machine learning on the browser. It's a new GPU API native, and WebGPU is the web equivalent. So this is the tool that you can explore to create modern machine learning application in the browser. And for the example, its performance is really significant, 300 performance in diffuse-based model using TensorFlow.js. So I think and it's just only previewed on May 2023, so it's really new. And maybe I want to explore it more deeply, and maybe it's a topic in another talk about web GPU. And also, in the future, a lot of machine learning powered application you can for using AI workout assistant, you can use for maybe doing some filter, anything you can imagine. Maybe you can collaborate with your application in user interface or user experience. So once again, understanding machine learning, mathematics, and AI, it's inevitable. For us in here, most of you is web developer. So I think it's really nice skill on your toolbox to face the future in technology. I think that's it for me. Thank you for listening, and thank you.
Thank you, Donny.
I still have, how many minutes?
We are over, but
Oh,
we could squeeze in some questions if anybody's got any questions. If not, you can come and reach out to Donny. Oh, there's one over here. Go on. Let me just shout. Yeah, you can.
So would you recommend, like in your website, just in the background, running some training on your models? And anyone who visits your website is doing work for you for free?
I think for right now, for browser, it's not really recommended training directly in browser because most of the time they have their own server, multiple running GPUs. So when we build something in model, usually data scientists will build the model in their own server and will pass to web developer to run the model. So basically you can train the model, but it's not really that efficient. So I think it's different pipeline. Yeah. Maybe it's mining some crypto, I don't know. I think so, yeah.
Cool.
Thank you.
Another round of applause for Donny, please. Thank you very much. So the next speaker is going to be talking to us about headless front ends. So I'm not sure what's going on with the headless part there. But this is Shakit. So please give a round of applause for Shakit. And just on the topic of AI, I mean, we've came a long way since Microsoft Clippy, and now we've got ChatGPT and things like this. Who pays for ChatGPT, by the way? Does anybody actually use this on a... You pay for it, okay, and do you use it on a day-to-day basis, would you say? Okay, some nods. Awesome, okay. I'll pass over to Shakit now. Thank you very much. Are you ready? Do you want this one, or...?
I'll take this one, yeah.
Cool.
All right. Hello, everyone. I hope you all are enjoying the conference so far. Amazing speakers, amazing atmosphere. Everything is going super great. Welcome to my talk. Today we are going to be talking about JavaScript magic, supercharging web applications with headless and modern front-end frameworks. In this, firstly, we are going to be talking about a bit of JavaScript. I mean, I know that we all know the advantages of JavaScript and what it is doing, but just to set the mood, we'll talk a bit about JavaScript. Then we'll talk about front-end frameworks, the benefits of front-end frameworks we have. Then we'll explore what headless is. We'll see the difference in the architecture of monolithic and headless. We'll see the differences in both of the architectures. Then we'll see a bit of code. We'll see how to set it up quickly, super quick. With one of the frameworks, I'll be using React, just to show you how quick the integration is. And then the most important thing that I want to talk about is building experiences. So I want to talk about how powerful this combination of modern front-end frameworks and headless becomes, and how it can provide experiences for everyone who is involved in the process. So yeah, let's move on to the talk. And before going on to the talk, a little about me. My name is Shakit Arora, and I'm a full-stack developer. I stay in India. I work as a developer relations engineer at Storyblock. This is my website and this is my Twitter, so you can find me over there. And I really like to be involved in the communities, and that's why probably you see me today here. I write about tech, I speak about tech, and yeah, that's about me. All right, let's talk JavaScript. I'll quickly go through this one. I mean, I know there are like many benefits of JavaScript and why would you use it and stuff like that. But I just wanted to talk about these points, the four I have mentioned. So the first one is ecosystem. JavaScript has created an amazing ecosystem around us, right? I mean, there are JavaScript conferences, there are conferences for specific frameworks. A lot of things are happening around. You can build for cross-platform, you can build, I mean, nowadays it's not just about building on cross-platform, it's about building anything and everything. Even my friend Donnie mentioned about, you know, like machine learning and stuff like that. I'm sure that, you know, like JavaScript is going to be, I mean, it is one of the most interesting languages, and I'm sure that, you know, like it's going to grow and grow and grow and grow. Then talking about communities, as I was mentioning, you know, like we have conferences, events, meetups, many people using JavaScript, and there is a lot happening around JavaScript. One of the things that I really like, since you know, like since we are talking about web, one of the things I really like is the way JavaScript has changed the way web works. So moving on to that, the best thing I think for us as web developers is frameworks, like being on front end or being on back end. JavaScript has given us a lot of frameworks, be it React, be it Next, be it Express, or any other thing, right? I mean, I cannot even imagine the time. I mean, I cannot even imagine building a web application right now without using a framework. And these are some of the benefits of front-end frameworks mostly. For example, they are time-saving, right? I mean, if you tell me to build something without using a framework, I'm not sure, firstly, if I'll be able to do that, but you know, like it's going to take a lot of time. Then these frameworks are flexible. They take less effort for you to do a certain amount of task or certain thing. And just for the examples I've mentioned, two features. For example, I mean, you know, like you implement these things super easily. For example, a router or a store and so on. Let's now move on to the main part, one of the main part, that is what is a CMS and what is a headless CMS. Has any one of you ever tried a headless CMS or maybe a CMS before? Wow, that's great, that's great. All right, so I'll just be talking about the architecture of a headless CMS and the architecture of a monolithic CMS. The one that you see on the left-hand side is the architecture of a monolithic CMS. Probably, you know, like, I mean, you can relate it to the things that, I mean, I'm sure that you have made websites, or you have seen tools where you drag and drop and, you know, like you build websites or yeah, I mean, mostly websites using drag and drop, and they have their own templates, they have their own components and stuff like that. So those, I mean, those pieces of softwares are mostly monolithic CMSs. The way it works is, I mean, the architecture of a monolithic CMS would be, you have an admin interface, you have a place to store the content, and then you have a tightly coupled presentation layer inside that. So whatever you do, you see it then and there, but it's not mostly that you are able to you know, like extend it or put in your code a lot. So that's about monolithic CMS, and this gives, I mean, this has a couple of limitations with it. So let's say you want to use a specific framework, it's not easily possible. Let's say you want to build for another platform, just not website, then it's going to be a problem. And yeah, I mean, we can cover the benefits of headless just after this. So probably it will be more clear like what headless can do and what, I mean, what are the limitations to monolithic. Talking about the other diagram, that's about headless. Headless, you know, like as the name says, headless, so it doesn't contain the presentation layer. The way it works is, it also has the admin interface, it also stores your data, but the presentation layer, as I mentioned, it's not there with it. So you fetch the data through the APIs, and then you can fetch it to any of the platforms. It's not that you can only build for websites, it's that you can build for any platform. Be it websites, mobile, IoT, voice assistant, maybe you want to build an Alexa skill or something like that, then that is possible too. I mean, the front end is decoupled. The front end or the presentation layer is something that you control by yourself. These are the benefits of headless. So as I mentioned, decoupled front end is something very good for you know, like developers like us, because you can choose whatever you want to, right? It's not that you need to adapt to a specific technology, or you don't need to adapt for a specific framework. If you're using Next.js, if you're using React, if you're using any other framework, it's fine. I mean, you can integrate it with any framework. Omnichannel support. Omnichannel support is something very much useful in the marketing environment. But as developers, we are the ones building it for the marketers, or we are the ones building it for the brands, right? So when we talk about omnichannel experience, it's something that you give your users or customers or whoever is using your platform the same experience on on all of those platforms. So headless gives you that opportunity as well, because you're retrieving the data through the APIs. You can retrieve it anywhere. Code maintainability and also scalability and flexibility. Headless also uses component-based architecture. So you create components inside your headless CMS, then you create components inside your front end. You map those up, and you can just scale the way you would scale a modern front-end framework. You can just scale it. You can scale the complete architecture the way you would. You can integrate a bunch of other things. Maybe you want to integrate it with any e-commerce platform or any other thing. Then it's easy for you to connect it with those. API first. Headless CMSs are API first, so that is something which gives you the option to get the data with the APIs and use that anywhere. Let's see the code now. So what I'll do is, before seeing the code, let's see the CMS that we are going to be using. So we're going to be using Storyblock. I'll just give you a quick, I'll show you how. I'll show you quickly how it looks. So this is the way. This is how it kind of looks like. On the right-hand side, these are the components. So you define these components, or you define these schemas inside the CMS, and then you code these components on your front end. So you can define your own fields. Then you retrieve that data, and you render that data inside your components. So that's how it works, and it has this visual editor. So wherever you click, you can just do the live editings, and it can be very much very much granular. You can control a lot of fields. You can play around with a lot of fields, and so on. I'll now move to this space or this project that I have. So we are inside the home story. I'm not going very much into the specifics of the CMS, but we are inside a story or a page that is called home. So it has the slug home. And yeah, now let's see the code and how it looks. So this is a very simple React project. Can you see it, or do you want me to increase the font? Okay. Is it good? Awesome. Thank you. All right, so yeah, this is the index.js file. This is this is the first file that we are editing over here, or that we are seeing. The first thing that you need to do is you need to install the package. So I've already installed it. It's called Storyblock React in this case. We are initializing the package with the help of the access token from that particular project or space. Then we have passed all of the dynamic components. So these are the components that you see over here. So for example, this is a page component, then this is a teaser component. Inside grid, you have these different feature components. So this is something that we have, we have made these components over here. We have imported those, and then we have defined it over here so that it, it renders dynamically, because you can change this structure, and your front end doesn't know which component comes first, so it's going to be rendered dynamically. And yeah, let's move on to the app.js file. This is a file in which, the thing we are doing is we are getting the slug first. So we are fetching from the window itself. So if I go onto localhost, whatever slug you provide, it's going to just take that slug. Just a very basic and easy code. Then we have this useStoryblock hook over here. So what it does is it allows you to fetch the data for that particular slug. So in this case, it's the home slug. So it's fetching the data for home slug. And then I'm just passing a couple of parameters that fetch the draft version and so on. Then what we are doing is, once we get this data from the CMS, the way data would look like is this. So it's going to be a JSON. So this is how you're going to get the data. This is how you're going to know that there is a component that is named teaser. It has a field that is called headline field. Then you see that there is another component called grid. It has a field called columns. Inside columns, then there are different components and so on. So that's how it works. After this, we are rendering. We are using Storyblock component. This is a component that allows you to render the components which you have defined over here dynamically. So that's about it. And then these components, the ones which we have defined over here, or the way they look. For example, the page component. What it does is it fetches, or I mean, it loops through the body because this page component contains multiple nested components. So it fetches those, I mean, it loops through those, and it again uses the story block component to render those dynamically. And then, yeah, I mean, whichever component comes in over there, whichever component you make, that is going to be rendered dynamically. So, you know, like this is how it looks. So for the teaser, let's say, you know, like teaser just has the headline thing, headline field. So we are just rendering block.headline. I mean, the data is being passed inside a prop. That's how it works. So let's just try it. I mean, I'll just add another field, but this is what I wanted to show you, that, you know, like over here, after adding this story block editable function, you can have these dotted lines coming in, and these are going to be your components, right? I mean, you define the schema and everything, and then again, you can just click on anywhere, you can edit the way you want to. So if I go over here and if I say, hello Cityjs, it's going to be happening in real time. I mean, you can see your content changing in real time. Similarly for other things, maybe if I want to drag and drop or do anything, it's going to be happening in real time. That's how, I mean, that's how a bit of it works. What I'll do is I'll just, you know, like just to show you that how you can configure the fields by yourself and how it can go to a granular level. What I'll do is I'll just define another field for teaser, and I'll go here and I'll say color, and the color field, I'll select a different field type for this. It's going to be a single option field, so you'll be able to choose from a drop down. Let's say this one is blue color, the value goes blue, and then another option that is red color, and the value goes red. So whichever you select, you know, like whichever you select is going to be in the response for you in the API, right? So if I select blue, then it's going to be, I mean, the blue is going to be sent inside the JSON response. Right now, nothing changes, but, you know, like we can make it work. The way it would work is we'll get the field, we'll say color, and then we'll say block.color. Let's hit save and let's hope it works. And it doesn't. So, oh, it does. Oh, sorry. Yeah. So, you know, like this is how easily you can, you know, like play around with the different fields. You can, I mean, this is just an example to show you that this can go very granular. I mean, you can have different fields, different, you know, like different types, different things, and so on. Maybe you want to play with styling, or, you know, like maybe your components are more complex, somewhat like this. Then you can build these things around. So yeah, I mean, that was about the code. Let's go back on the presentation. Now, since we have seen the benefits of modern front-end frameworks, I think which we are mostly aware about, and we have seen the benefits of headless, you know, like this is what makes it a very powerful combination to use. This is what gives better user experiences or better experiences for anyone who is involved. Let's quickly take let's quickly take a look at the experiences, and I mean, this is something that I really want to, you know, like, I mean, this is like one of the conclusion, or this is the main thing that we want to come at. So let's talk experiences. We'll talk about developers. I mean, developers are important. So I've just, I mean, I'm a developer, so yeah. So what I'll do is I'll just cover the developer thing in the end. But yeah, let's talk about the experiences for content editors. You can create once, publish anywhere, right? I mean, that's the flexibility you can give to the content editors. There is no developer dependency. Once the components are created, you can reuse them over and over again. I mean, if I create a hero section, if I create a hero component, it can be used over and over again, and you can build pages all around. You get a collaboration, you get, you know, like, I mean, you get collaboration with these sort of tools. Then you can create content in minutes. It's good for SEO as well, because your content editors can put in what do they exactly want to put inside those fields. You can create an SEO section or something like that. Talking about marketers, I mean, it gives you an option for omni-channel, as we already discussed. It gives you an option for personalization. We'll see personalization as well if we get, like, I mean, according to the time. They can create new campaigns in minutes. They can schedule the content. So, you know, like, it's something that reduces the dependency, as well as gives them a better experience to work with this architecture. Then talking about developers, this is like one of the best things. So for example, you know, like, you can really focus on your code. You can really focus on what you want to build or what you want to use. You can choose any of your stacks. You can choose any of the front-end frameworks, or maybe any other thing as well. Then we have internationalization. You know, like, if you want to even internationalize the content, it's easily possible inside the CMS, right? You just add a language, switch it up. you set up the code once, and then your content editors, they can be using that, using that structure similar to the way they would use any other component. Less content requests, so you won't be getting requests saying, hey, can you please fix this article for me, or hey, it doesn't look good on mobile, can you change it right now? Because you would already know how it looks, and you have already given a structure to your content editors or marketers, and they can play around with that. Clean code, it's not, again, if there is some sort of content, you can have that functionality defined dynamically. It doesn't have to be inside the code. So the code is cleaner. It's, again, component-based approach. So, it's cleaner and scalable. Let's talk about personalization a bit. In this similar manner, you can even provide personalization. So just a second, I'll open up. Yeah. So for example, if you want to personalize the content, let's say you want to, you want to give a user an experience, a personalized experience. The way it would work is you analyze or you understand the type of user on the front end. We have you can, just giving an easy example would be to know if the user is logged in or logged out, right? You can identify that on the front end. You can see if the user is logged in or not. And then probably you want to show them different content depending upon this state. Then you can do this as well. You can, inside one story or inside one page, you can put in 2 different type of things. And once you fetch this data, you can render this data again conditionally. That's how, that's how it would work. And for your content editors, you can even, set this sort of preview. So they can see that, the preview right now is set up as new visitor, but you can even set up as a returning visitor. So they can see how the content is going to look like for the returning visitor. They can see how the content is going to be looking like for a new visitor and so on. So that's how you can even provide the personalized experience. And yeah, all of this creates a better experience for user. And we already spoke about the experiences for content editors, developers, and marketers. And after all of this is how we feel as developers, super energetic and super powerful, just like Pikachu over here. And yeah, once the developers are happy, or once we are happy, it feels good to be happy, right? So yeah, that's how that was most about it. That's how you can provide good experiences to everyone involved. And yeah, that was most about it. Thank you so much, everyone.
Thank you, Shakit. Does anybody have any questions? No questions. All right, you can ask Shakit at break. Thank you very much. So next up we have Zaim, and he's going to be talking to us about navigating front end of constraints. We've got 2 more talks before lunch, and so it looks like the energy is quite low in the room. So I'm not going to get you to do another Mexican wave, but let's all stand up again. And so most of us are developers in this room, and stereotypically we're not too good at making friends. And so you all have very common interests here. So what I'd like you all to do is turn to the person next to you, behind you, if you don't know them, shake their hand, give them a high five, a fist bump, and make some friends.
Yeah, to mirror, to exactly mirror this one.
Mm-hmm. You good?
Check. Check.
Okay. Thank you, everybody. And please give a round of applause for Zain.
All right. Thanks, everyone. Check. Okay. Okay. Hi, everyone. Good afternoon. I'm Zain. I'm a senior software engineer at NinjaVan. Today, I'm going to talk about navigating the web in a world full of constraints. So this talk is about my journey of building websites. For each of those websites, I will explain the constraints that I encountered, as well as how I navigated around them. And by the end of the talk, I will talk about how I balance between quality, cost, and speed to understand the ceiling of the tech stacks. I'm going to skip the introduction of myself because the whole talk is basically the introduction of myself. So yeah, please bear in mind. So in the past 5+ years of my journey in the front end, I have been building a bunch of websites. Some of them are on my workplace and some others are in an open source projects. And yeah, so in 2019, I built ninjavan.co, obviously the website of my company. And the next year, unfortunately, the pandemic strikes. So I led a team to build another website for, yeah, it's a one-stop information portal for COVID-19 in Indonesia. Then the next year, unfortunately, the pandemic strikes harder. So we needed another website to build a more sophisticated website for the pandemic in Indonesia. And the next year, in 2022, fortunately, the pandemic slows down, so I have some more time for my own side projects, and I just built a simple catalog for learning resources. And last but not least, this year I built a web app that unfortunately I cannot disclose, but there are still things that we can learn from there. Yeah, okay, so in 2019, I built this company's website. Basically, it's a revamped version of the existing company website. As you can see in the screenshot, Ninjavan is a delivery company. So we deliver stuff, basically. And because our services span across 7 countries, we have to serve in 11 locales. So which means it's very related to what Hui Jing has explained earlier in the talk. And yeah, I have to deal with I-18N, or internationalization. We decided to do it with static pages. We used Gatsby at the time because in 2019 it was the most mature static site generator framework in 2019. And I think now we have a lot more options, but at the time that was the best option. And for the I-18N, I had another talk, which is also hosted by engineers.sg. Thanks for hosting and recording the video. You can find the video in that link. And initially we built this website by simply hard-coding the HTML pages because we just need to deliver it, right? We just need to have the new face of the company built quickly. So we did it along the way and we just published it. But then, yeah, as Shaki just mentioned just now, the content team, the marketing team wants more, right? So they want more flexibility of modifying the page, and then we slowly migrate the pages into headless CMS. Yeah, and we picked this content.ai for the headless CMS solution. And yeah, the next year, in 2020, the pandemic hits. It's called COVID-19, just in case someone forgot about it. Yeah, unfortunately, the Indonesian government didn't handle the misinformation problem properly, like in Singapore. So a bunch of Indonesians living in Singapore and also in Indonesia, including Herdi, one of our staff here that helped us here. He also helped us to build this web. So basically, it is an open source website. And what we did here was we generate static pages back with the headless CMS again and script data. So we move on towards Next.js because around that time they just released an SSG feature. It was still in beta back then, but we just go with it. And I think a few weeks later they just released it as a stable one. And fortunately, yeah, it ended up work for us. We hosted it in Netlify. Fortunately, we also get some COVID-19 support to host it. But we also have some WordPress instance, and we cannot host WordPress in Netlify, right? At least last time I checked, we cannot. So yeah, we also have some WordPress instance where Herdi helped us to set up. And it's basically, we use WordPress because it's more friendly, more familiar for our content editors. And we use a headless plugin to be able to serve the content for the Next.js static site generation. And for data itself, we don't want to deviate from the government, so we simply script their website, the official source, and we hosted the JSON files ourselves as static files. Yeah, the next year, the pandemic hit harder. there was a Delta wave everywhere. People were scrambling around to grab some oxygen, ambulance. There are bed capacity shortages in hospitals. So a bunch of COVID-19 NGOs and companies initiate, they assemble to build something urgent and something new for helping the situations get better. Because we needed to launch it very quickly, right? So within 3 days, we had to launch it in a TV show broadcast. So this is what we came up with. Yeah, so as you can see, this website is not so good. And the reason is because we simply use Google Docs. So we fetch the Google Docs page, we get the HTML, we get the CSS, we discard the JavaScript because we don't want the JavaScript part of it. We just want the HTML part, and there it is. So it's a very scrambled website because, all of these organizations, they want to put something there, and we want to get it done quickly. So that's what we just get with. And yeah, we know that's not the best solution, right? Because we don't have control over the markups. And that's also something that Sakit said about headless CMS. So we started migrating it over to, before migrating the homepage, there's also a worse situation about the database. So this is the information, and if they want to find some oxygen or some empty hospital, or at least they want to contact some ambulance to get down to their place, they have to open these Google Sheets. And imagine opening this in a mobile device. You have to scroll horizontally. I think it loads very, the load time is also very bad on mobile devices because of the size of the data that you have to serve. So we improved the database by fetching the Google Sheets and present it in a more user-friendly way, and it is also accessible on the browser side. So if the user wants to access some oxygen in Jakarta, they can simply get the contact easily. And by the end of July, we also improved the homepage. So from the Google Docs version that you saw, now it's a bit better, still a bit rough, but at least now we have control over the markup, so it's better on SEO. So whenever people try to find contact about this system of the Ministry of Health, they can, because this website has a good SEO, so people can get redirected to it. Yeah, and a month later, by the end of August, we ended up having the current state of the website. So initially, it was a Markdown file. Like this one Markdown file is serving the whole homepage. So we grab the markups from the Markdown, and we serve it into our own HTML structure. But now we have broken down the Markdown file into more granular JSON files and Markdown files. Yeah, and yeah, that's how we ended up with this kind of website. Yeah. Yeah. And for the image also, we also use Cloudinary here. So yeah, just to make Mr. Thomas happy about it. Okay, and yeah, the year after, the pandemic slows down, and I have some more free time to work on something else. So we have, I and some of the initiators of the previous COVID websites, we started building a content curation for learning resources for parents. And because during the pandemic, people try to educate their children at home, right? So we want to help those parents who are missing those resources. But still, we only had them in Google Sheets for, I think, for a year, because we were still busy with the COVID stuff, right? And yeah, I simply decided to build a proper catalog UI to represent these Google Sheets in a better UI. And yeah, for the name, it's called Senarai. Senarai is an Indonesian word of list or array. It doesn't mean that, yeah, and fortunately it rhymes with AI, with all the hypes we have in the past few years. And, but no, we don't have any AI system implemented yet. Hopefully soon in the future, after listening to all your talks. I think I get more ideas about how to implement some AIs in my website. And yeah, the one thing that I'm proud of this website is because this was my fastest MVP so far. So I get it done within only 2 days. So just basically a weekend and 30 commits. Yeah, that's because I started small with everything I have learned from my previous projects. And you know the Google Sheets fetcher, I simply copy it and paste it here and adjust it to match my new Google Sheets format. So I treat this website as a venue for myself to experiment with bleeding edge tech stacks. And yeah, because I use Remix, so I can easily deploy it to some more bleeding edge tech stacks, including the new deploy, because I just wanted to live on the edge. And using GitHub Actions, I can fetch the data from the Google Sheets daily and deploys to the new deploy. And for the UI, yeah, I just simply use ready-to-use UI components from Tailwind UI to build all of those UI. Yeah, but again, as I mentioned, it is an experiment, right? So I wanted to have another version of this app living on a different instance. I'll call it beta.scenario.ai. The difference is in the original website, when you submit the form, because it is based on Google Sheets, right? So when you want to contribute, you will be presented by a Google form. But in the beta version, it will be a proper form. So this is what I was experimenting with. Yeah, you will have a proper form here. So I use this as a venue of experimenting with remix streaming feature, which is basically a version of React streaming and suspense feature in Remix. Last but not least, this year I built an internal app. So because it is undisclosed, I can only show you the login page. And yeah, but nevertheless, so what's interesting about this app is, about this web app is, due to the company's absence of Node.js SSR support, I had to pivot to a single page app solution. So unfortunately, the company doesn't support Node.js server, and I mean, the company has already focusing on serving the actual servers, right, for all the API stuff. But when I wanted to have BFF, best friends forever, like backend for front end, basically, I cannot have it because simply there's no Node.js support. So we have to, so our front end should be a simple HTML file. And yeah, over the years, and for this particular project, we also expect that over the years, more teams will add more features to the product. So having an awesome developer experience is crucial. That's why we started building this with Monorepo. We used Turborepo as our solution for clearing, for having a clear separation of concerns and code ownership across teams. We also use Vite and Vitess to have an awesome developer experience, both on the development environment and the unit test framework. And we also use React Router. So what's interesting from this is, I mean, we all know React Router, right? Who have ever used React Router before? React Router. Yeah, I believe it should be. I think at some point in our career we should be using it already. We may not notice about it unless you're using Next.js. But even then, before the Next.js time, there are already frameworks using React Routers behind the scene. So what's interesting about this is React Routers recently brought some of its powerful functionalities from Remix, which is its data router. And it means that the routers are aware of data fetching logic. So there is a talk by the React Router founder. It's called When to Fetch, and it's talking about how React Router utilizes this data router. And also with the nested routing mechanism, I get to build micro front-end with build time integration. What I mean by build time integration is when, basically we assemble all of this micro front-end during the build time. Because micro front-end is very wide in terms of interpretation. There are so many types of implementation that can fit into micro front end. Yeah, so this is how the code looks like, and this is the only code that you will see in this presentation. So basically, this is our main config routes for the whole project, and currently we only have one team that is contributing to this project, so we have this route. Yeah. But then maybe later this year there will be more teams contributing to it, and what we need to do is simply add another line here for their pages, and serve their page and serve whatever they put in their package within the monorepo. Yeah. So what I learned about it is, so all of those websites helped me to learn about making trade-offs. At some point in time, we have to make trade-offs, especially about quality, cost, and speed. And the popular thought around the trade-off is that we can only pick 2 out of these 3 aspects. So if you want to pick all of them, usually people just, they will end up have to picking 2 out of those. But why not all? I think, at least recently, I think it is still possible to pick all 3 based on my previous experience, given the right size of the scope. So it's a matter of downsizing the scope of the product that we are building. So yeah, I believe it is possible to deliver a project that is fast, cheap, and good by applying the concepts of the lean process, which is basically around scoping your project into a smaller subset of possible, but still deliver it fast, cheap, and good. Okay, a few days ago, I think last week we had a conversation on Twitter about front-end ceiling with Sean. Basically, it's talking about career ceiling for front-end developers. So at some point, front-end developers are being quietly graded into a lower tier of software engineer that will never be on track of VP engineering or CTO. Well, there may be some truth of it, but it's for, what I'm learning about this is there may be also the tech stack ceiling, which means every tech stack will always have limitations. So we just need to understand the limitations of the tech stack that we pick and optimize our project for change towards moving out of this tech stack. We should be mindful of the fact that we don't really know what requirements will be placed upon our code in the future. And this is also another quote about career development. Just pick one thing to do, and if that doesn't work, then pick another. Making a choice and trying it is an important career skill. I used to be a back-end developer back then, a few years ago, and then 5 years ago I moved towards front-end, and I think this is a good thing for me. So I think it also applies for picking tech stack. So my key takeaway for all of this experience is just pick any tech stack that enables you to do the job. But once you hit the ceiling, you have to get ready to pivot to another stack when the time comes. I think that's all from me. Thank you very much.
Thank you, Zain. We're going to get started straight away with Tai Shi Ling. Whereabouts are you? Hey, hello, welcome. We're running a little bit late, so we're going to start straight away. I noticed that down the front here you have some teddy bears, or what are their names, or if you wouldn't mind just coming up and talking to us about what you've got.
I think you can use these.
All right. All right, so yeah, I just went to like a store in Orchard yesterday, and there are these really nice teddy bears. Yeah, so this one is Lumos. Yeah, my girlfriend just named them. Yeah, and this one is Minty, and this is Milkshake.
Nice, awesome names. Thank you very much. So this is the last talk before lunch. Aris, is there beers? I think he's already gone and got them. But lunch is just after this, and so without further ado, I'll hand over to you.
Yeah, I'll try not to get in the way of you and your lunch, and I'll code as fast as possible without making any mistakes, fingers crossed. Okay, so let's get started. My talk today is untestable. It's just pressing a button, right? How hard can it be? Well, so my talk is, I am representing a QA developer, and I hope the takeaway at the end of this talk is that you have more appreciation for your QA developer, and then if you tell your boss to pay your QAs more. Okay, so who am I? I am Shiling, and I started out as a web developer more than a decade ago, very old already. But I started out as back-end first, then after that I started moving to front-end, And it was during the period where all the front end was still being written in jQuery. We were slowly moving into more sophisticated front ends because back-end engineers decided to write front end and then it made it more complicated. So we had Angular, now we have React, now we have Vue. And then in between, we started refactoring code one by one. So, and then I got the keys to development. So with great power comes great responsibility. Yes, ship code to production without testing. Okay, no lah. You shouldn't do that because I went on vacation once and things broke in production. So lesson learned. Please write your test. So, and because over time I managed more responsibility, right? I managed bigger and bigger code bases, and over time your code gets old. Sometimes you refactor the business logic is not relevant anymore. You clean it up, and that's where TDD is very important, lah. So so that's my journey, and then this is. I lost a lot of sleep because we didn't write enough tests. And then over time, I realized, oh, actually I got a statistic side. It's quite fun to tell developers they are wrong. Yeah, so over time, and then after that, it became an obsession. I want to build dev tools to make testing more easy. So I created my own dev tool called UIlicious. We help make testing a piece of cake so that it can ship delicious UI, not shit UI. Okay? Okay, so my talk, testing untestable things. Why this topic is because UIlicious, it being a low-code testing tool, a lot of our testers, a lot of our users on the platform, they are not, half of them are engineers, so half of them are able to code, do workarounds and all. The other half, they are new to programming or maybe don't have programming experience at all, so they come in to learn how to write tests. And we intentionally made the testing language as simple as possible. Our philosophy is test user journey is not HTML because if you don't know coding, trying to figure out how to inspect HTML is a bit difficult. So if you look at UIlicious, our syntax is very semantic. We want it to be readable, meaningful, easy to understand, very low maintenance. So this is what it looks like. Very simple. I go to github.com. I fill in email, I fill in password, I click on login, I see my teams. Very easy, right? Should be very easy, should work 100% all the time. Except the click button, sometimes it doesn't work. And we don't know why. You just get a lot of requests from people who are trying to test their things and say, hey, how come it doesn't work? It doesn't work on this page, doesn't work on that component. Why got this error, got that error, a lot of errors. And then we need to make sure that it works 100%. Like, very easy, right? You're just pressing a button only. And then every time we test it, right, they tell us, hey, it works on there. I know it works perfectly because if you manually test it, it works. And then it's true, we go test it manually and it does work. So why doesn't it work on the browser automation? It's just some UI are designed in such a way that it works for humans but doesn't work for a robot. Okay? So I'm going to show you a few common examples of untestable buttons. There's actually a lot, but I'm going to show you the top ones. Okay, so there's a lot of workarounds, but then it's not very practical to ask all of our users, all of our QAs to write a workaround. So then you can, the alternative solution is you can ask the developer, hey developers, can you don't ship such funny, naughty buttons or not? And then developers say, but it works for humans, I put it on my backlog, I was very busy building features. So it never get done, so this button will forever be like that. So we must test it. Must make it testable, even if as untestable as it is. So I'm going to show you a few untestable buttons, and I have a whole website for untestable things, and I'm adding more to the collection. If you have more examples, you can tell me. I'm going to be at the booth later, and you can tell me, I'll just add more to the collection. Okay, so this is the untestable website. Let me make. So we got 4 examples, actually 5 examples, but I'll cover 4 examples, and then the last one, I'll leave it to you. If you all want to test, I'll give you a prize if you can help me test the last one. So the first untestable button, I call it the glass door. Why is it called the glass door? It's a very common one. You want to add this very beautiful frosted effect on your image button. And then, so you add another layer, and then actually when you click on it, a human can click on. Maybe you do some JavaScript magic. And then what happens when you're testing it? Let me show you. I write a test code for you. So this is my test code. Okay, let me show you the button. This is the button. So when you press the button, right, if you can press the button, it will give you confetti, then you win. So if you press the other button, you don't. So I will show you. Well, this is the button that we are going to click on, and this ID is, let me inspect the ID of this button. The ID is visit Chicago -BTN. So I already selected the button using Selenium. We are just going to use Selenium vanilla, no Cypress, nothing fancy, just vanilla Selenium. So we're going to find our button, then click on it. I'll show you what is the problem. Oh, zoom in. Can see? Oh, more. Okay, can see? Great. Very easy, right? Just find button and click on it. Okay, so we're going to run a test. UI test takes a while to run. There's no confetti. Oh, why it doesn't work? Okay, so why it doesn't work? You can see the error that came out over here. It's called element click intercepted. And why it says element click intercepted, you always see this error whenever there's something on top of the thing that you want to click on. So what's on top of the thing that we want to click on? Yeah, let me zoom in. We all can see the inspector. So what's on top of our button? The label. The label to put Visit Chicago on top of our button. So this one didn't require any JavaScript. It's just as long as you put a label and then you say for the ID of that button, right? As long as you click on a label, it will trigger the button underneath. So this entirely works without any JavaScript magic. So much confetti, it works. So how do we solve this as a QA engineer? So as a QA engineer to solve this, right, we need to do some extra workarounds. So let me show you how to solve this. So let me introduce my awesome workaround. I call it the finger. It's very magnificent. It'll work for all kinds of like funny, naughty buttons. You just give it the finger. Okay. Yep. So I initialize my finger and I pass it the driver, the Selenium driver, and then it's very similar to the previous, like Selenium is just dot click lah. Then you pass in the button that you want to click on. So how do we implement our finger click method? So what we want to do, right, is we want to get the element reference. Same thing here. We want to do element to click equals to driver dot find element. But we don't want to click with Selenium. We want to get the position of the element first, and then click on the thing that is on top of the click on the element that is on top of the element that we want to click on. So how do we do that? We're going to run some JavaScript. So driver dot execute. We execute some JavaScript. We'll pass in our element that we want to click on. And then over here, right, we want to find out what is the rectangle of that element. Element to click on, and then we'll use get bounding client rectangle, and that will give us the top position, the position of the top left corner, and the width and the height of the box of the element itself. And then from there, we can calculate what is the center point, and that's where we want to click on. Okay, so x is equals to, and we want to get an integer, so we'll do a math.floor. So our center point is the rectangle, the left side plus half of the width. Rectangle slash width, width divide by 2, and then y would be the top left corner position, and then the height. So this is the x and y. Now how do we know what is the thing that is on top of the thing that we want to click on at that point? So to get that, the web API has a very useful method called element from point. You can use this method to get the element on top of xy coordinate. So what we're going to do is we're going to say top element equals to document.element from point x, y. Okay, then we're going to return our x and our y. Okay, and we want to return the element on top Okay, so and then finally, let's see, then we want to put this result into something. I also want to await. Okay, so now finally we actually want to click on the top element and not the element that we want to click on. So, await driver, okay, no need to driver anymore. Just response, the top element, dot click. Okay, there we go. So we're going to run our test. Yay! Yay! Wow! Thank you, thank you, thank you. Thank you for all the applause. Okay, okay. So now the second issue that we have. This issue is called the clone. And it actually happens quite often. I've seen this across every single front-end framework where the thing keeps re-rendering. So it has happened on Angular. I've seen this before. It has happened on React, and it also happened on Vue. And where it most frequently is when you are rendering a list. And for some reason, almost all of the frameworks has done this once before, where the list will keep re-rendering. And let me show you the actual thing lah. Hi. Next level. So same website, looks exactly the same. Can click one. Can click. Okay, let's inspect the code. So you know that a thing is re-rendering repeatedly when you cannot inspect the bloody thing. See, try to click on it, I cannot inspect. But I can click, developers are happy, you can ship to production already. Yeah, okay, so let's go and test our, so there's two, so this one, right, where actually, when you try to test it, it give you, the test will be unstable. Sometimes you'll pass, sometimes you'll fail, depending on whether you're lucky or not. So sometimes, yeah, so sometimes you pass, then developers are happy, let's ship it. Okay, so let's run the test and then see whether it pass. So this one is using the current implementation of the finger to click on it, and the current implementation of the finger cannot handle it. Or maybe can see how, it didn't work. Yeah, so it failed. So how do we solve this? So what you need to do is you need to do a retry loop, and then instead of trying to click on the element on top, you just want to move the mouse to the position and then go and click on it. It sounds very complicated, but I'll show you how to do that. Okay, let's go. So we're gonna update our implementation of the finger, and then we are going to, so we're not going to use this anymore to get the element of the reference to our element to click on, because what's going to happen, right, is, let me show you whether you can see the issue. So the error that we get is called still element not found. And this means that the thing that you wanted to click on, it disappears. So you get still element, it got removed, and because it got re-rendered, so it disappear. So how do we do this? So we don't rely on trying to click on the element using its element reference. We try to use the position of the element to and move the mouse there and then click on it. Okay, so how do we do this? We don't need this anymore. And then now we're going to do, what are you going to do? We are going to execute JavaScript again. Okay, so we're going to pass in the locator, and then we're going to get the element. This one is a bit more long-winded, so I'm just going to grab the solution. There you go. So locator is either a CSS selector or XPath lah. Depending on what you get, depending on which type of selector, we'll use different method for grabbing the element reference itself. At this point of time, because you are executing JavaScript, the element by right should be there lah. Okay, so now what we want to do is we want to again calculate the position of the thing. Rectangle equals to element dot get bounding client rectangle. Okay. I'm going to do the same and try to get the center point again. Okay, you want to return this. Because the element will re-render sometimes, right? We want to wrap this whole thing in a retry loop. So that if we are unlucky and then it disappears, we will try to get the element again and try to recompute its position. So we're going to put this in a retry loop. My own retry logic is very simple one. The first function is the function that you want to retry. I'm going to put this whole thing here. And then this is the condition for stopping the retry lah. It will stop retrying when we get there's some value for x. And then now, what we want to do, right? We don't want to use the .click method to click anymore. We're going to use actions to move the mouse. Then we move the mouse to the position where we want the mouse to be, and then fire the mouse down and mouse up button. So to do this, what we'll use is called drivers or action. This will allow you to form any kind of action chains with keyboard actions and keyboard input and mouse input. So driver.actions, .move, then we'll move to X and Y position, and the origin will be viewport because this is this rectangle. When you do element.getBounding client rectangle, the top and the left is relative to the position of the viewport. Viewport means the area of your whole page that is visible to the end user. So it depends on how much you have scrolled to the page what the viewport would be. So origin here will be viewport. And then we want to sort of move the mouse in a humanely fast way, 200 milliseconds. And then we'll press the button, and we will let go of the button. And then we'll perform this. Okay, let's go. Let's go. Okay. Let me press the, let's wait for this to work. Ta-da! Confetti! Yay, works! Okay, so what's the third unclickable thing that I've seen quite often? The third unclickable thing, I call it the dodgeball. When the thing you want to click on, it moves. And when you see this most often is you have content that is injected by a third party, such as an advertisement. So you want to see a blog, for example, and then after a while, the advertisement loads and everything ships down. So a very, 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 very common thing. I always encounter this when I'm asked to test an e-commerce website. There's always like some banner, promo, this flash sale, then everything moves down. Okay, so let me show you our very cute dodgeball button. Let's move to the next level. So ta-da, I'm going to click on this login button, but every time you click the advertisement, okay, this one is a cute cat hand pops up. So I mean, as a human, you're just, so annoying, I just move my mouse. Very easy, but then with a robot, will just click on it like it's very simple. It's very simple minded, you just click on wherever you told it to click on, which is there. It was there, but then it moved. Okay, so how do we solve this? So let's go to our workaround, and then we'll implement our workaround here. So we'll update our finger. And then to solve this, what we'll do, right, whatever I implemented just now, I'm going to move it to a find element function. Okay, so this one does what we did just now, which is to find the element and then figure out where is the X and the Y position, and return it to me. Okay, so first thing what we want to do is we want to get the position, await this dot find element, and then our locator. And then now we want to do the same thing, drivers dot action, and then move. I'm gonna move to the X, it will be here, Y will be here. And then we're going to perform our action. But we're not going to click on it yet because when we move there, right, it's hover over the button, the cat is going to come and push the button away. So we let the animation complete first. So we're going to do a wait. sleep. 200. And then now we are going to recompute the position after the animation is complete. And then finally, we are going to run it again. So, but this time, the second time, we are going to press a button and then release the mouse button. Okay, let's run our workaround. Yay, confetti, woo! Okay, the last one is the problem that we have with the current implementation, and this is not a problem that Selenium has, but it's a problem with the current implementation of the finger. It's not complete yet. The reason why it's not complete yet is that if we have something that you need to scroll to get into, it's not able to figure out how to scroll there. Okay, so for example, here we want to click on Singapore. Let me find Singapore. And we click on Singapore, you get confetti. Okay, so let's solve this. To solve this is actually a very simple one. So let me show you. So here what we want to do, right? Let me go into our implementation. So before we, after we find our element, but before we return where the position is, the X and the Y position, what we want to do is we want to tell the browser to scroll our element into the viewport so that we can move our mouse to it so that it's visible. So what you want to do is you want to call the scroll into view function. So we found the element already. You just call scroll into view. And so after the element is found, the browser we'll get the browser to scroll the element that we want to click on into view first. And then now we compute where that thing is after you scroll. So you cannot do the computation before you scroll, you must do it after you scroll. And now we know where the position of the object is after you scroll. We can go and run our test again. Ta-da! Yay, it works. Okay, so to validate that our finger works, and not just work for like individual tests, must work for all the tests. We're going to run it all together. I will run one by one. So this is the first level. So it runs too fast. I've got to add weights for this one, so you cannot see confetti. Okay, never mind. But it all works out. We'll come back to this and see whether everything is green. But I'll show you what's the last level, the bonus level. So this is the bonus level. If you want to go and try and, help me extend the finger so that it works for Nyan Cat, you get a prize from me at the booth if you manage to solve this one. Yeah, so that's all for our my presentation today. Please show some appreciation to your QA. It's not easy to test all your very naughty button. And then if you have a QA in your team, you can introduce to them the finger project. Let me show you where the GitHub repo is. Yeah. And then I can tell them that if they find a naughty button, they can give it the finger. Yeah. Okay, thank you everyone. Thanks for listening.
Thank you very much, Tai. So it's lunchtime now, so please make your way out there, and there'll be some food, possibly beer. I'm not sure if Aris got that. After lunch, we've got some cool talks about AI, Web3, accessibility, and more JavaScript bits and bobs. So we'll see you back here in about 40 minutes.
We did it! We made the app. That's only half the story. Soon, with a little luck, we'll have a ton of people using and loving our product. That means user accounts, authentication, security. You know the drill. But this part right here can be just as important as the app itself, because behind this login box is a lot of your users' information. And they're trusting you to keep it safe. It's important, but it doesn't have to be hard. That's why we use Auth0. It's an identity platform for developers that makes it easy to connect any app, like ours, to the authenticators and integrations we need. But wait, I bet you're like, we could do that ourselves. It's not that hard. We know what we're doing. First, I hear you. Second, are you sure? Users want security and flexibility. You want to give them all the newest sign-in options as soon as they're available, because they want to use your app on their terms, not yours. With Auth0, I can easily customize my login with the features my users want. I can create a custom two-factor authenticator for added security, and easily enable the multi-factor authentication methods I want. It even has breached password detection, so if someone else has a security breach, I can keep my users safe. Our security is always up to date and regulation compliant. You made an app, and Auth0 makes a better, safer experience for your users.
Are you still testing your web applications by hand? Really? Come on. Don't tell me you're too busy to automate testing. With UILicious, testing is a piece of cake. UILicious is a low-code platform for cross-browser testing. Our philosophy is test user journeys, not HTML. Let me show you. Here's how I write a test for github.com. First, I go to github.com. Then, I click Sign In, and I fill in the email and the password. Finally, I click Sign In, and I should see the error message, incorrect username or password. Let's select a browser, and press the Run button. Ta-da! The test is complete. I can also use UILicious's test authoring AI assistant to generate tests. Let's generate a test to log into Netflix and change password. Sweet! Once I've set up the test, I can schedule it to run anytime, any day, even when I'm asleep or on vacation. I can also set up notifications to alert my team when the test has failed. Now, with automated tests, I can know for sure if my new changes are good to go into the hands of my users. Try UILicious for free today.
miles per hour. 300 sensors. 1.1 million data points a second. Sent instantly to the AWS cloud. So machine learning can react in real time to keep millions of fans on the edge of their seats. If AWS can do this for F1's data, imagine what it can do for your business.
We did it! We made the app. That's only half the story. Soon, with a little luck, we'll have a ton of people using and loving our product. That means user accounts, authentication, security. You know the drill. But this part right here can be just as important as the app itself, because behind this login box is a lot of your users' information. And they're trusting you to keep it safe. It's important, but it doesn't have to be hard. That's why we use Auth0. It's an identity platform for developers that makes it easy to connect any app, like ours, to the authenticators and integrations we need. But wait, I bet you're like, we could do that ourselves. It's not that hard. We know what we're doing. First, I hear you. Second, are you sure? Users want security and flexibility. You want to give them all the newest sign-in options as soon as they're available, because they want to use your app on their terms, not yours. With Auth0, I can easily customize my login with the features my users want. I can create a custom two-factor authenticator for added security, and easily enable the multi-factor authentication methods I want. It even has breached password detection, so if someone else has a security breach, I can keep my users safe. Our security is always up to date and regulation compliant. You made an app, and Auth0 makes a better, safer experience for your users.
Are you still testing your web applications by hand? Really? Come on. Don't tell me you're too busy to automate testing. With UILicious, testing is a piece of cake. UILicious is a low-code platform for cross-browser testing. Our philosophy is test user journeys, not HTML. Let me show you. Here's how I write a test for github.com. First, I go to github.com. Then, I click Sign In, and I fill in the email and the password. Finally, I click Sign In, and I should see the error message, incorrect username or password. Let's select a browser, and press the Run button. Ta-da! The test is complete. I can also use UILicious's test authoring AI assistant to generate tests. Let's generate a test to log into Netflix and change password. Sweet! Once I've set up the test, I can schedule it to run anytime, any day, even when I'm asleep or on vacation. I can also set up notifications to alert my team when the test has failed. Now, with automated tests, I can know for sure if my new changes are good to go into the hands of my users. Try UILicious for free today.
miles per hour. 300 sensors, 1.1 million data points a second, sent instantly to the AWS cloud, so machine learning can react in real time to keep millions of fans on the edge of their seats. If AWS can do this for F1's data, imagine what it can do for your business.
We did it! We made the app. That's only half the story. Soon, with a little luck, we'll have a ton of people using and loving our product. That means user accounts, authentication, security. You know the drill. But this part right here can be just as important as the app itself, because behind this login box is a lot of your users' information. And they're trusting you to keep it safe. It's important, but it doesn't have to be hard. That's why we use Auth0. It's an identity platform for developers that makes it easy to connect any app, like ours, to the authenticators and integrations we need. But wait, I bet you're like, we could do that ourselves. It's not that hard. We know what we're doing. First, I hear you. Second, are you sure? Users want security and flexibility. You want to give them all the newest sign-in options as soon as they're available, because they want to use your app on their terms, not yours. With Auth0, I can easily customize my login with the features my users want. I can create a custom two-factor authenticator for added security, and easily enable the multi-factor authentication methods I want. It even has breached password detection, so if someone else has a security breach, I can keep my users safe. Our security is always up to date and regulation compliant. You made an app, and Auth0 makes a better, safer experience for your users.
Are you still testing your web applications by hand? Really? Come on. Don't tell me you're too busy to automate testing. With UILicious, testing is a piece of cake. UILicious is a low-code platform for cross-browser testing. Our philosophy is test user journeys, not HTML. Let me show you. Here's how I write a test for github.com. First, I go to github.com. Then, I click Sign In, and I fill in the email and the password. Finally, I click Sign In, and I should see the error message, incorrect username or password. Let's select a browser, and press the Run button. Ta-da! The test is complete. I can also use UILicious's test authoring AI assistant to generate tests. Let's generate a test to log into Netflix and change password. Sweet! Once I've set up the test, I can schedule it to run anytime, any day, even when I'm asleep or on vacation. I can also set up notifications to alert my team when the test has failed. Now, with automated tests, I can know for sure if my new changes are good to go into the hands of my users. Try UILicious for free today.
miles per hour. 300 sensors, 1.1 million data points a second, sent instantly to the AWS cloud, so machine learning can react in real time to keep millions of fans on the edge of their seats. If AWS can do this for F1's data, imagine what it can do for your business.
We did it! We made the app. That's only half the story. Soon, with a little luck, we'll have a ton of people using and loving our product. That means user accounts, authentication, security. You know the drill. But this part right here can be just as important as the app itself, because behind this login box is a lot of your users' information. And they're trusting you to keep it safe. It's important, but it doesn't have to be hard. That's why we use Auth0. It's an identity platform for developers that makes it easy to connect any app, like ours, to the authenticators and integrations we need. But wait, I bet you're like, we could do that ourselves. It's not that hard. We know what we're doing. First, I hear you. Second, are you sure? Users want security and flexibility. You want to give them all the newest sign-in options as soon as they're available, because they want to use your app on their terms, not yours. With Auth0, I can easily customize my login with the features my users want. I can create a custom two-factor authenticator for added security, and easily enable the multi-factor authentication methods I want. It even has breached password detection, so if someone else has a security breach, I can keep my users safe. Our security is always up to date and regulation compliant. You made an app, and Auth0 makes a better, safer experience for your users.
Are you still testing your web applications by hand? Really? Come on. Don't tell me you're too busy to automate testing. With UILicious, testing is a piece of cake. UILicious is a low-code platform for cross-browser testing. Our philosophy is test user journeys, not HTML. Let me show you. Here's how I write a test for github.com. First, I go to github.com. Then, I click Sign In, and I fill in the email and the password. Finally, I click Sign In, and I should see the error message, incorrect username or password. Let's select a browser, and press the Run button. Ta-da! The test is complete. I can also use UILicious's test authoring AI assistant to generate tests. Let's generate a test to log into Netflix and change password. Sweet! Once I've set up the test, I can schedule it to run anytime, any day, even when I'm asleep or on vacation. I can also set up notifications to alert my team when the test has failed. Now, with automated tests, I can know for sure if my new changes are good to go into the hands of my users. Try UILicious for free today.
miles per hour. 300 sensors, 1.1 million data points a second, sent instantly to the AWS cloud, so machine learning can react in real time to keep millions of fans on the edge of their seats. If AWS can do this for F1's data, imagine what it can do for your business.
We did it! We made the app. That's only half the story. Soon, with a little luck, we'll have a ton of people using and loving our product. That means user accounts, authentication, security. You know the drill. But this part right here can be just as important as the app itself, because behind this login box is a lot of your users' information. And they're trusting you to keep it safe. It's important, but it doesn't have to be hard. That's why we use Auth0. It's an identity platform for developers that makes it easy to connect any app, like ours, to the authenticators and integrations we need. But wait, I bet you're like, we could do that ourselves. It's not that hard. We know what we're doing. First, I hear you. Second, are you sure? Users want security and flexibility. You want to give them all the newest sign-in options as soon as they're available, because they want to use your app on their terms, not yours. With Auth0, I can easily customize my login with the features my users want. I can create a custom two-factor authenticator for added security, and easily enable the multi-factor authentication methods I want. It even has breached password detection, so if someone else has a security breach, I can keep my users safe. Our security is always up to date and regulation compliant. You made an app, and Auth0 makes a better, safer experience for your users.
Are you still testing your web applications by hand? Really? Come on. Don't tell me you're too busy to automate testing. With UILicious, testing is a piece of cake. UILicious is a low-code platform for cross-browser testing. Our philosophy is test user journeys, not HTML. Let me show you. Here's how I write a test for github.com. First, I go to github.com. Then, I click Sign In, and I fill in the email and the password. Finally, I click Sign In, and I should see the error message, incorrect username or password. Let's select a browser, and press the Run button. Ta-da! The test is complete. I can also use UILicious's test authoring AI assistant to generate tests. Let's generate a test to log into Netflix and change password. Sweet! Once I've set up the test, I can schedule it to run anytime, any day, even when I'm asleep or on vacation. I can also set up notifications to alert my team when the test has failed. Now, with automated tests, I can know for sure if my new changes are good to go into the hands of my users. Try UILicious for free today.
miles per hour. 300 sensors. 1.1 million data points a second. Sent instantly to the AWS cloud. So machine learning can react in real time to keep millions of fans on the edge of their seats. If AWS can do this for F1's data, imagine what it can do for your business.
We did it. We made the app. That's only half the story. Soon, with a little luck, we'll have a ton of people using and loving our product. That means user accounts, authentication, security. You know the drill. But this part right here can be just as important as the app itself. Because behind this login box is a lot of your users' information. And they're trusting you to keep it safe. It's important, but it doesn't have to be hard. That's why we use Auth0. It's an identity platform for developers that makes it easy to connect any app, like ours, to the authenticators and integrations we need. But wait, I bet you're like, we could do that ourselves. It's not that hard. We know what we're doing. First, I hear you. Second, are you sure? Users want security and flexibility. You want to give them all the newest sign-in options as soon as they're available, because they want to use your app on their terms, not yours. With Auth0, I can easily customize my login with the features my users want. I can create a custom two-factor authenticator for added security, and easily enable the multi-factor authentication methods I want. It even has breached password detection, so if someone else has a security breach, I can keep my users safe. Our security is always up to date and regulation compliant. You made an app, and Auth0 makes a better, safer experience for your users.
Are you still testing your web applications by hand? Really? Come on. Don't tell me you're too busy to automate testing. With UILicious, testing is a piece of cake. UILicious is a low-code platform for cross-browser testing. Our philosophy is test user journeys, not HTML. Let me show you. Here's how I write a test for github.com. First, I go to github.com. Then, I click Sign In, and I fill in the email and the password. Finally, I click Sign In, and I should see the error message, Incorrect Username or Password. Let's select a browser, and press the Run button. Ta-da! The test is complete. I can also use UILicious's test authoring AI assistant to generate tests. Let's generate a test to log into Netflix and change password. Sweet! Once I've set up the test, I can schedule it to run anytime, any day, even when I'm asleep or on vacation. I can also set up notifications to alert my team when the test has failed. Now, with automated tests, I can know for sure if my new changes are good to go into the hands of my users. Try UILicious for free today.
miles per hour. 300 sensors. 1.1 million data points a second. Sent instantly to the AWS cloud. So machine learning can react in real time to keep millions of fans on the edge of their seats. If AWS can do this for F1's data, imagine what it can do for your business.
We did it! We made the app. That's only half the story. Soon, with a little luck, we'll have a ton of people using and loving our product. That means user accounts, authentication, security. You know the drill. But this part right here can be just as important as the app itself, because behind this login box is a lot of your users' information. And they're trusting you to keep it safe. It's important, but it doesn't have to be hard. That's why we use Auth0. It's an identity platform for developers that makes it easy to connect any app, like ours, to the authenticators and integrations we need. But wait, I bet you're like, we could do that ourselves. It's not that hard. We know what we're doing. First, I hear you. Second, are you sure? Users want security and flexibility. You want to give them all the newest sign-in options as soon as they're available, because they want to use your app on their terms, not yours. With Auth0, I can easily customize my login with the features my users want. I can create a custom two-factor authenticator for added security, and easily enable the multi-factor authentication methods I want. It even has breached password detection, so if someone else has a security breach, I can keep my users safe. Our security is always up to date and regulation compliant. You made an app, and Auth0 makes a better, safer experience for your users.
Are you still testing your web applications by hand? Really? Come on. Don't tell me you're too busy to automate testing. With UILicious, testing is a piece of cake. UILicious is a low-code platform for cross-browser testing. Our philosophy is test user journeys, not HTML. Let me show you. Here's how I write a test for github.com. First, I go to github.com. Then, I click Sign In, and I fill in the email and the password. Finally, I click Sign In, and I should see the error message, incorrect username or password. Let's select a browser, and press the Run button. Ta-da! The test is complete. I can also use UILicious's test authoring AI assistant to generate tests. Let's generate a test to log into Netflix and change password. Sweet! Once I've set up the test, I can schedule it to run anytime, any day, even when I'm asleep or on vacation. I can also set up notifications to alert my team when the test has failed. Now, with automated tests, I can know for sure if my new changes are good to go into the hands of my users. Try UILicious for free today.
miles per hour. 300 sensors. 1.1 million data points a second. Sent instantly to the AWS cloud. So machine learning can react in real time to keep millions of fans on the edge of their seats. If AWS can do this for F1's data, imagine what it can do for your business.
We did it! We made the app. That's only half the story. Soon, with a little luck, we'll have a ton of people using and loving our product. That means user accounts, authentication, security. You know the drill. But this part right here can be just as important as the app itself. Because behind this login box is a lot of your users' information. And they're trusting you to keep it safe. It's important, but it doesn't have to be hard. That's why we use Auth0. It's an identity platform for developers that makes it easy to connect any app, like ours, to the authenticators and integrations we need. But wait, I bet you're like, we could do that ourselves. It's not that hard. We know what we're doing. First, I hear you. Second, are you sure? Users want security and flexibility. You want to give them all the newest sign-in options as soon as they're available, because they want to use your app on their terms, not yours. With Auth0, I can easily customize my login with the features my users want. I can create a custom two-factor authenticator for added security, and easily enable the multi-factor authentication methods I want. It even has breached password detection, so if someone else has a security breach, I can keep my users safe. Our security is always up to date and regulation compliant. You made an app, and Auth0 makes a better, safer experience for your users.
Are you still testing your web applications by hand? Really? Come on. Don't tell me you're too busy to automate testing. With UILicious, testing is a piece of cake. UILicious is a low-code platform for cross-browser testing. Our philosophy is test user journeys, not HTML. Let me show you. Here's how I write a test for github.com. First, I go to github.com. Then, I click Sign In, and I fill in the email and the password. Finally, I click Sign In, and I should see the error message, incorrect username or password. Let's select a browser, and press the Run button. Ta-da! The test is complete. I can also use UILicious's test authoring AI assistant to generate tests. Let's generate a test to log into Netflix and change password. Sweet! Once I've set up the test, I can schedule it to run anytime, any day, even when I'm asleep or on vacation. I can also set up notifications to alert my team when the test has failed. Now, with automated tests, I can know for sure if my new changes are good to go into the hands of my users. Try UILicious for free today.
miles per hour. 300 sensors. 1.1 million data points a second. Sent instantly to the AWS cloud. So machine learning can react in real time to keep millions of fans on the edge of their seats. If AWS can do this for F1's data, imagine what it can do for your business.
We did it. We made the app. That's only half the story. Soon, with a little luck, we'll have a ton of people using and loving our product. That means user accounts, authentication, security. You know the drill. But this part right here can be just as important as the app itself, because behind this login box is a lot of your users' information. And they're trusting you to keep it safe. It's important, but it doesn't have to be hard. That's why we use Auth0. It's an identity platform for developers that makes it easy to connect any app, like ours, to the authenticators and integrations we need. But wait, I bet you're like, we could do that ourselves. It's not that hard. We know what we're doing. First, I hear you. Second, are you sure? Users want security and flexibility. You want to give them all the newest sign-in options as soon as they're available, because they want to use your app on their terms, not yours. With Auth0, I can easily customize my login with the features my users want. I can create a custom two-factor authenticator for added security, and easily enable the multi-factor authentication methods I want. It even has breached password detection, so if someone else has a security breach, I can keep my users safe. Our security is always up to date and regulation compliant. You made an app, and Auth0 makes a better, safer experience for your users.
Are you still testing your web applications by hand? Really? Come on. Don't tell me you're too busy to automate testing. With UILicious, testing is a piece of cake. UILicious is a low-code platform for cross-browser testing. Our philosophy is test user journeys, not HTML. Let me show you. Here's how I write a test for github.com. First, I go to github.com. Then, I click Sign In, and I fill in the email and the password. Finally, I click Sign In, and I should see the error message, incorrect username or password. Let's select a browser, and press the Run button. Ta-da! The test is complete. I can also use UILicious's test authoring AI assistant to generate tests. Let's generate a test to log into Netflix and change password. Sweet! Once I've set up the test, I can schedule it to run anytime, any day, even when I'm asleep or on vacation. I can also set up notifications to alert my team when the test has failed. Now, with automated tests, I can know for sure if my new changes are good to go into the hands of my users. Try UILicious for free today.
miles per hour. 300 sensors. 1.1 million data points a second. Sent instantly to the AWS cloud. So machine learning can react in real time to keep millions of fans on the edge of their seats. If AWS can do this for
Ah, very little. Okay, Neil, it looks like you've got some educating to do. So I'll pass over to you, Neil. Thank you very much, and please give a round of applause.
Thank you so much for Dan giving me a survey of the audience to understand what you guys do. I know you guys are not involved into a Web3 development, but can you show of your hand how many of you use like wallet before in the Web3 space? Buying something in the assets? Okay, seems I have a lot of work to do today. Anyway, I only have 15 minutes time. I'm trying to really explain to you why I have this topic for you guys. I know some of you already stared at this topic for a while. Hopefully you already have some answer or no answer at all. Right? So I'm Neil. I'm a founder of Radio. So a little introduction of myself has been in Singapore for the past 17 years, doing my own startup as a full stack engineer back in 2008. Was doing first ever high fidelity audio streaming services, basically spin off from A-Star in Singapore. And we launched the first ever Asia Pacific short video sharing apps back in 2010, which is 4 years before TikTok is coming out. Right, then I moved on to a company like Twilio, who used to be the sponsor here, but I don't see the logo this year, unfortunately. Was the third hire for Twilio APAC, and grew the team from 3 of us to 1,000 people in APAC before I left Twilio. Then I joined a company doing distributed database, which is TIDB, where a company like Shopee has been using that database to handling billions of users and also transactions, right? How I involved into Web3. I know even back in 2018, right? When I was at Twilio, the customer like Binance and all those crypto exchange has been my customer at the time. I also started to do a little bit of advisor work for some of the crypto companies at the time. But after working with them for a month, I feel the project is a little bit shady just because it's all white paper. The concept is really good. If I can do it, I'm gonna do it at that time. But the technology was not mature at all, right? And it's about 2 years ago, I started to really want to understand what's going on, why the company start to rename from crypto to Web3. Seems something bigger is happening, right? That's where I start to really dig into the technology stack as a guy born as a developer, right? As you all know, right, these are very typical Web2 structures, and company like AWS make it very complicated nowadays, but it's still, essentially, that's it. But the bigger issue is all the data is stored in a central database, which is not transparent to anyone except the big players, right? Web3 has been changing that concept a little bit because the data is public, available to all the node, right? I try not to use any specific terms for you to understand the Web3 space, where they run all the programming languages on all the data stored on the different public available nodes. Everyone can access, right? In order to write the logic on top, you have these new programming languages where people call it smart contract, but at the end of the day, it's another different programming languages where you have to run the programming language on top of a VM, right? That's where there's a different blockchain, have their different VMs to run the code. So that you can write the code, write the data into the public available node. Most popular one is Solidity. So as front-end developers, in the past 2 years, I have been talking to about 200 plus front-end developers in the Web3 space. The first task for them is to learn Solidity, which is a little bit painful because the concept is different. And once you deploy a smart contract on the node, you can't modify anymore. And there's even time where people lock the money because it's digital assets, right? In the smart contract, you can't withdraw anymore. People is very careful to deploy that, which is a very big pain point for Web3 development, right? It's evolving because when you started to build some like small programming languages or small applications on top of Web3, right? You need to scale. Right, you just deploy on one node, it just doesn't help. You have to deploy multiple nodes and scale it, right? That's where a company like Infura providing the node services, even AWS provide that nowadays, to scale for your applications so that you don't need to really worry about the ops, right? And it's not enough because in the Web3, as I mentioned, there's no central entity managing the authentication. You are the one owning the data. By seeing that, I'm not seeing the concept, I'm seeing the architecture, where all the signing are from your own wallet, not from the centralized authentication of the central services, right? And you literally own the key, right? That's the architecture has been evolving based on this concept. But how about the storage? Because you need to store other data, right? The blockchain, some of you may know, is costly to store a lot of data on some of the blockchains, like Ethereum, right? That's where companies coming up with some of the distributed, decentralized file services protocols for you to store the data on their protocol. They have different nodes running the protocols on top. Some company make a stream. They even deploy the front end to these kind of file systems to really make it fully decentralized. There's one issue for that because once you deploy a smart contract, if you forgot to write some function in the smart contract, you have to redeploy again. A lot of times, smart contract developers spend time to adding a function and redeploy again, which is still costing money because that's how the blockchain works. So at the same time, right, the company is coming up with indexing solutions like the Graph. It's one of the popular ones, where you don't need to deploy again. You just query like whatever you query, like a query GraphQL, right? It's a similar kind of syntax. You run that. You solve the issues for you redeploy multiple times in order to adding functions in a smart contract. And that's how it looked like when I started to work on Web3, right? You want to buy some NFT, you have to have a wallet. The NFT itself is about maybe $30+ US. Look at the gas fee there. It's like almost $40+. And when I started to buy NFTs, it actually cost $200 US to just buy because that's a transaction fee on the blockchain. And once you buy that, right, they have to give you the NFT. All the transactions take about 5 or 10 seconds to get it done. As a Web2 developers or just common users, it's ridiculous, right? That's what I thought when I started the whole thing, right? Yeah, that's the very typical experience when I started to work on radio about 2 years ago. And the good thing is a lot of companies already started to solve the issues on the transaction fee, which is sometimes going up $200 US, and the performance, right, it can't be taking that long time to get a transaction done. Just in the Web 2, right, just like 100 milliseconds, right? And that's where the companies like scaling solutions are started to really solve these issues. The essential logic is to aggregate all the transactions in one block, and this block will be verified and put on chain into the blockchain to make it cheaper and faster, right? So we were very fortunate to actually know this technology back in 2021, where it's very similar concept. We bundle all the transactions together, like 5 transactions in one batch, right? So that you don't need to every transaction going on blockchain. Then we aggregate and doing all the mathematical verifications. There's no human interaction for these authentications, so that we can reduce the gas fee to 0 and increase the transaction to like almost 1,000 transactions per second. Very similar to nowadays how Visa and the MasterCard can handle in terms of the transactions, right? So after that, we abstract all the things to developers so that the Web2 developers, you just need to just grab our JavaScript SDK to run some of the logics, and you don't need to learn anything about smart contract. So that's another issue we were trying to resolve. Due to limited time, I have a ready available demo just to show you how the whole thing works. Where is my mouse? Yeah, let me change the screen sharing to something I can see. Okay. So we publish our reference source code because a lot of times developer come in trying to build a marketplace or build some logic into their own Web3 applications, right? It's all open source, and it's all written in JavaScript. We use some little bit React in this JavaScript protocol. So after the whole story, right? This is how the experience looks like. We support the traditional Web3 wallet to log in. And this is the authentication piece. So when you're trying to buy the NFT, right, it's just about 200 milliseconds to get it done, much faster than the video I show you on OpenSea. And as I just showed you just now, right, we also support the Web2 experience because that's very important for mass adoptions. And you just log in by some like traditional social logins, right? And yeah, that's it. So you log in and you have your own wallet address. And I want to highlight this wallet address because that's a core piece of Web3, a little bit different concept compared to Web2. Then we have a lot of other functions for you guys to explore. A little bit quickly show you how the whole thing works. Just now you see we list all the orders, right, which is selling the NFTs. It's just calling through our JavaScript SDK to show the orders. There's no backend logic at all. It's just all front end. We abstract all the complexities for developers. You don't need to learn anything about smart contract. That's a quick demo. For how it works. I definitely want to show you in the real world how people are changing based on the Web3 logic, because I know in this space a lot of noise, but we have been working with a very good quality bunch of companies, startups, for kind of revolutionizing the space. This is one of the companies based in the Valley, where they put some of the indie artists, like this is a music, this is one of the very popular musicians in the US. The music itself is tokenized as an NFT. And for example, the top right, it has 1.5% of the ownership of the song. So whenever they upload the music is actually the music I own personally, they actually upload to Spotify. And you know Spotify has a streaming royalty the musicians can collect back. The musician itself actually distribute back to me about quarterly on their revenue with 1.5% to me as an owner of that assets. So the whole thing has been really changing the music industries in the US right now. We see a lot of musicians, as you can see. This guy, when they launched the first LP, he raised $40,000 $400,000 US just for one song, which totally changed the whole the way of earning the money. That's Radio has been really working on, as you just understand. We changed the whole stack a little bit. With this whole stack, we solve a little bit issues in the industry, so that as you Java developers just need to just focus on the business logic other than the backend and all the other stuff, because that's how the whole thing works. I just want to show you guys a little bit what's gonna happen next, because everyone talk about Web3, seems a junky word nowadays with so many people grabbing the money away, but people like us has been joining this industry for a reason, right? Why? As you can see, the wallet address is the central for everything for Web3. It's not Facebook login anymore, not Google login anymore, it's a wallet. And based on that wallet, the connection for all of us kind of changed. You and me have a different wallet, but I will never know you in Web3 space, right? That's actually what's happening for when Facebook launched it in Southeast Asia. It's actually, they have, sorry for the noise. they had a literally zero. They had literally zero people in the ground. But when they open up Facebook Connect, all the social games, they actually buying advertisement on Google for Facebook, because that relationship in the new world is a lot of there are a lot of opportunities there. And I was very fortunate initially when I worked with a company like a Happy Farm. I'm not sure how many of you guys work with, play the game like back in like 2008, which every morning you wake up to steal the vegetables from the game. The whole thing actually rebuild the relationship on top of Facebook and their games. And we and all these kind of founders has been seeing this opportunity has been coming up for Web3. And that's where, as you can see on the top left, there's a company already start to build this social relationship based on the wallet. And once you have that relationships, there's something else will happen. For example, how are you going to connect to each other? That's where the decentralized messenger protocol has been popular for this space. And that's not all. There's some other elements, because that's it, right? You basically build another Facebook and you make it work. It's still gonna work for Web 2, right? But because the central service, like you have to advertise on the Facebook, on the Google in order to attract those users, they already blocked that possibility for Web 2. That's why TikTok has been so suffering to have their new social media coming up, right? And for Web 3, it's very different right now, as we can see from a technical founder perspective. And when I see Web 2, it's popular, there's one big element, which is the game. And we see the AR and Vision Pro has been another new opportunity for Web 3, where I just show you the game. They are trying to build an AR-based Roblox. Everyone build their own domain or their own world, and it become a kind of NFT in the virtual world. People can buy and collect on different assets. It become a Pokemon Go in AR and in Web3. There are just many, many more coming up. So to me, I think you guys are fortunate or unfortunate to in this space and today, because there are just so many opportunities. Some of you may believe it. Some of you may just think I'm another guy in trying to sell something to you. But I think, to myself, it's a big opportunity. To some of you believe this, I can't really wait to see what you build in the Web3 space. Just come back a little bit to the topic. As you all see on the logic I introduced you on how the industry has been evolved, all the logic come back to the front end. And you guys are the ones really build the future. Thank you so much.
Thank you very much, Neil. It's a shame that we've got this great blockchain technologies and it's spoiled by meme coins. But just out of curiosity, who's Team Dodge and who's Team Shib? Team Dodge? Dodge, Shib. Okay. So we have Trung now, who's going to be talking to us about web accessibility. And so we are about 20 minutes behind. So let's get started straight away. Thank you very much.
Check. Right. Hi everyone, thanks for coming to Cityjs today. To all of the people who are traveling from outside of Singapore, thank you so much for coming. That's really special for us. For someone who take the Friday off and come to the conference, that's the spirit. Thanks so much. So today I'll talk about accessibility. Is actually the first time I talk about it, so take it easy on me. And yeah, we'll see what we go through. So we go back to the history of the web a little bit. It's like when the web was started in 1989, 91. It's just a proposal from Tim Berners-Lee. You heard about the Tim Berners-Lee name before? You heard, yeah, the guy who invented the web. But we might see this kind of, concept of client running on a different platform in that early day. So it's just the idea in his mind, and then he was, putting it into the paper. And now we have Chrome, we have Safari, everything. But then fast forward to a few years, you have, first kind of mainstream browser, Internet Explorer 1.0, because It's not the first browser, but it's kind of, set the direction because it's cheap with Windows. So that's why a lot of people start to know the web and they use the web more. Actually, I start the timer. So that Windows. And the point is, it's early in 1997. Already there's an initiative about accessibility. We call it WAI, which is Web Accessibility Initiative. And when you zoom in a little bit, it's telling you that there is 700 million people around the world has accessibility. And what we wanted to do is really to remove the barrier for people with deaf, blindness, and cognitive, basically disability. So I updated the slide last night with the arrow, so hope it's focused. And so today we talk about what is accessibility in general, and how do you want to test it, how you want to build it, and yeah, basically basic stuff. And so before we get started, we need this slide. So that's myself. I built some project, not as famous as Anthony Fu and Evan you today, but Angular stuff. So people know me in Angular stuff. And I do Angular Singapore, Angular Vietnam, and Viettek. And I also work for a company called Ascenda. There's some of the folks from Ascenda probably at the back, no? Okay, at the back, very back. And we do, we simplify loyalty for bank global merchant around the world. And so we look into the definition in English, accessibility, what is the fact of being able to, too fast, to be reached or obtained easily. And when you look into web accessibility, it is really something need to do with disability. So it's, try to aim to target for more people. But especially, it doesn't exist without people with disability. And so, what is next? Okay, so sometimes you heard about the term A11Y. And I spent a lot of effort to make this slide. So it's going to be, it's smooth. And then there's 11 letters between. So that's why it's called A11Y. It's easy. It's like internationalization. It is short when you tweet, because tweet is 160, unless you have the blue check. But yeah, I don't have the blue check. And so, accessibility at the end, when you design it for, aim for accessibility, it's been benefit people with and also people without disability, which means technically everyone. Yeah, I hope you see the slide. That's a PowerPoint effect. And so maybe some of the example in real life, there's a curb cut for wheelchair accessible people. And then when you are pushing a luggage or you are carry a heavy luggage, it's help a lot. Or when you are riding the bike or you are pushing the trolley, all of that help in real life. So for the web, how is it going to help? Actually, we need to see how people with disability use the web to really understand. There's no sound?
Keyboard compatibility.
Sorry.
Not being able to use your computer. Many people use only the keyboard. Need to be operable by keyboard. Web accessibility, essential for some, useful for all.
Right. They has the end quote, which is really nice, right? Essential for some. It's like, before I see this video, I never thought there's someone who is using just the neck to navigate the keyboard. Really, never thought in my life, really. And so, when you have supporting keyboard, it's like one of the, criteria. It's help people, having a fancy mouse that doesn't have battery. This happen. Or, maybe you just get the repetitive strain on your wrist. I got it sometimes, really. I just need to use the keyboard. And then if the website doesn't have keyboard accessible, it's kind of weird. You don't like it, right? For some reason. And so, what else will be essential for some, useful for all? I know it's a bit dry initially, but so that the next part I think is still a bit dry for the next few minutes, but we get into the code quickly. So let's say you feel like you wanted to make the web accessible. And you go into your blog and say, okay, I want to make it accessible. What do you do? Where do you even start it? So there has this called WCAG, which is the Web Accessible Content Guideline. Yeah, okay, accessibility guideline. So it just basically say, in this kind of guideline, we are trying to aim for 4 principles. That is going to break down into 13 kind of guideline, and then it's going to be break down one more time into kind of, a ticket for you to fix. It's like in criteria, success criteria, and into 3 levels, A, AAA, and A double A, triple A. So I know it's dry, sorry. Go ahead. A is like the basic. The basic is like, you have an image, you need to have an alternative text to it in case it couldn't load, or in case someone couldn't see the screen at all. Like you close your eye, you don't see the image. So what is this about? So the keyboard the same, kind of just now we saw. Double A is a bit more. So it's like, let's say you have a contrast, you select the text, and the text need to match with a certain requirement, like 4.5 hour 1. So there's a tool for testing it. But by using the tool, you can select the text which is good for your audience. But this one is not passing AAA. So it's like, you wanted to pass AAA, for example, for the contrast, it needs to be a bit more vibrant, right? You see it, the one just now maybe in the really bright environment, it might not be, it might be difficult to see, for example. So this one is like, it's like blue in the white color. So it's kind of clear, really. For me, it's clear. The one which is not very clear is like when you select a bit of gracious in the white background, so it's not passing anything. Basically, that's it, easy. Okay, so, you wanted to reference all of it, right? You go through this link, and it's long. That's anything, any spec in this kind of programming is long. You will not go through all of it. So then, how do you, do it, really? And so we have the next topic is like for testing. You just take the website, you run the tool, and then see how it goes. That's it. And then we fix whatever needs to be fixed. So I think the first one, this one doesn't work. Okay, doesn't work. Okay, so because Anthony Fu is in the audience, I just use Vite to create a project. Select React and TypeScript, easy. And then I just put the heading and the button. That is really coming from Vite template. And so that's the code, right? The code looks simple. It just, there's a state and then the button. And then the button is inside the div. I hope it's clear enough. At the back, clear? Okay. And so, okay, we wanted to focus into this button and cow. Why? Why so important? So let's say I wanted to change the button a little bit. I wanted to use a plus icon, which might look nice. I don't know. I think it looks nice, maybe. And then I move the text outside of the button. So now it's like in the div, which is fine. No issue. And so now, that's the button, the new button. The image look nice, huh? Does it look nice? And then, you still have all of it keyboard interaction. Normal. But then, some people might say, okay, the button now has a border. And it has this kind of background thing, and then it has a focus. I don't like it. And then the easiest solution to use it is, to fix it is kind of, you know where I'm going. That's the button. See it again? That's the button. That's where we are going. Awesome. Anyone write code like that before? Okay, that's some. Okay. I do it before. That's why I can tell, right? I do div on click many times in my career. But I think it's fine. It's like I just don't know about accessibility until I work for a company called Ascenda, and then we work with a bank, and then bank say, oh, actually it doesn't work. We are a financial institution. And doesn't matter where you are, like who you are, where you live, you need a bank account. So you need to provide the website with accessibility. But then the div here is not that bad. Actually, it still works. That's the thing. When we test it, it still works. And then when I run it through Lighthouse, you never use it. This is a built-in Chrome tool. You can also npm install Lighthouse. Audit it with accessibility. See, that's the arrow, yeah? And then you press the button. What it do is like, it's just running some stuff, and then accept the generated output, HTML, and then tell you what can go wrong. And then in this use case, there's only one can go wrong. There's an image element doesn't have the alternative, the L attribute. Right, you have 90%, that's awesome. And then, okay, what I'm gonna do is like, I'm gonna go and fix it. It's easy. I'll just fix it. I'll add it in. I run again. I got 100%. 100. Really? Have you seen it in the production website? I never seen it. Really, I never seen it. Maybe you've seen it, not me, yeah? And so, you know, like how we mentioned, it just runs through the output HTML. So it might not be able to yelling at you when you are doing something maybe wrong. So the next step we wanted to do is like, okay, we do something else. We just add in ESLint, right? We do lints all the time. It is a tool helping you when you're writing code. So we just use ESLint JSX A11Y. So it's, when you add it in, okay, that's the ESLint config. You add in one line called plugin ESLint, whatever. You see it, recommended. And so now I come back to the code. Now I can see something else. It says, okay, first of all, visible non-interactive element with click handler with must needs at least one keyboard listener. Fine. I'll add it in for sure. Thank you. I'll add it in for sure. And then, okay, now it's saying, maybe it's the one on top is avoid non-interactive element. And then it doesn't really possible. You need to add a row. What do? I add a row? Why not? Add a row button. Now the div is a button. And then it's still gelling, and I say, okay, something with the row needs to be tappable. How do we do it? How do we do it, guys? Tab index, awesome. So, I'll do tab index, just to make it happy. But you know, all of that, you go back to the code, it's kind of work, right? But then the key up just now was just the one really quickly. So key up, anything on the keyboard is key up. So now you say, okay, I need to differentiate between, you know, space and enter, and then when it's happened, and then I trigger it, otherwise I will not. So look back into the code. Yeah, there's a lot more code to write. Maybe I just stick to the one I had before. Yeah, why not? And then, okay, for not just this, right? I need to do a bit of CSS patching to remove all this border and background, but it's easy, right? But then you don't have to do it heavy lifting on JS. So there's a lot of common accessibility error that you can see. Like I think it's 98% of the website had this kind of issue. The first one, low contrast, we see it. The second one, missing L attribute for the image. Next is empty link, which is like a link just with an icon, without anything else, just an icon. Missing input form labels, like you put a div, then the text, and then the input. When you click into the text, it doesn't focus into the input. Because the code is long, so I will not put it here. Empty button, and then the last one, just mentioned in the morning. Missing the document language. Right? When it is in the different language, you should put the lang into it. Otherwise, it doesn't work. It works only because we can see it. Right? When you cannot see the website, you rely on the machine, on the computer to understand it. And if you don't, give a hint, they don't understand. If we just use the div without a row button, it just understands it as a generic item. There's nothing you can click on until you put a row button, technically. So, that's a sick common thing. Easy to fix, for sure. If you're interested to read, then just do A11Y coffee. Okay, 14 minutes. Oh yeah, that's that chant in the morning. Is it still here? No, maybe no. No. So like I mentioned, okay, we have the first step is like, okay, we run the audit on the browser. Second step is like we start to bring the link closer to our code by using ESLint, for example. And the third one, in our center, we start to kind of cannot trust developer. They can keep pushing code, no commit, no verify. So it doesn't really work. And then we start to say, now we have the accessibility criteria. That's awesome. So there's QA is gonna catch the bug. They will test it and will tell you, guy, you need to fix it. Yeah, I think that's the issue that we are doing. We don't really do a lot of end-to-end tests that catch accessibility issue for now. But during the year, we realized that the important, and that is what we are trying to apply in a new product. When we build it, we know accessibility will come eventually, so we just add it in, easy. So there's few more tools other than Lighthouse, so like Jazz, Cypress, Ice. The AXE is like one of the famous tools for accessibility testing. So I just put it in case you wanted to read more about it. Ooh, awesome. Yeah, I like PowerPoint for that fact, this text just nice. So what about complicated custom component? You talk about button, so easy to build. What about dead picker? Are you gonna build a dead picker again? I don't think so. I don't think so. Because like, if you wanted to do it properly, there is a pattern for you. That's the guy, like WAI area pattern. So they tell you, when you build a combo box, which is the text input and rendering the result, you need to put an area when it is loading and all. It is really detailed, but then once again, it's long. And I think, there's a lot of library, a lot of people outside, they do it for us. So I think in our company, we've been learning from it. We initially use Angular and Material. Anyone still use Angular here? Okay. No. And now we do Next.js and React Area component and Radix. So yeah, all of this component is happy because in this use case, for example, right? Let's say I close my eye and then I use a tool called Screen Reader. And then it's going to read through the screen as I'm moving on the picker itself. Like you use keyboard to navigate, which is good. But then when you are using a screen reader, it's going to tell you what layer you are selecting, which is really cool. Yeah, you are not going to want to build it again from the scratch. Trust me. So yeah, we are starting to use all of these components. So when we need to build custom complicated component, we just look for accessibility kind of focus UI library, and there's a few I just show. Yeah, I set a slide later, so don't worry about it. And then I think anything else? Kind of almost done, but this one is like people who cannot see.
It's technology that many people who are blind have been relying on for years. But it's also important for many people with dyslexia and very useful for people with difficulty reading text, as well as some people who just like to multitask. But for this to work, websites and apps have to be properly coded, which has the added benefit of helping search engines index websites' content better. Web accessibility, essential for some, useful for all. Visit w3.org.
Visit w3.com.org. Right, so when I try to use Cityjs, let's say I was just trying to use it as I cannot see it. What I can do is I say, okay, you close your eye, you say, give me all of the heading for this website. And then you go through it, or you just say, okay, give me the next heading, give me the next heading, until you found the one that you wanted to view. Not view, like you wanted to hear. And then you say, okay, now, read me the content, right? Because you don't see it, so how do you use it? You just go through this kind of thing, and this thing need to be made accessible with semantic HTML. It's look kind of, we overlook it, but it's important when you have a piece of content and you want people that couldn't see, try to access it. That is super important, right? H1, H2. You can make a div that look like H2 for sure, but it's not the same, right? It looks the same, but it's not the same in many ways. So, okay, so now I think it's ending slide, right? So we start with the web, and then we have the WAI, we have WACG, Accessibility Content Guideline 1.0, then we have HTML5. Fast forward, we have 2.1, and then now we are here, right? I think during that many times, right, there's, the HTML5 that's come out. But then the idea is still the same after so many years, which is web accessibility, essential for some, useful for all. So I think, with some of the keyword, what I wanted to try to say is like, you are interested in this kind of topic, of course, it's tough, it's difficult, but then eventually you need to support it anyway. There's a law in European Union until what year you need to support it to level A as minimum. So that's really important. So I think that's it. Thanks, guys. My name is Chung. That's the slide.
Thank you, Chung. Does anybody have any questions?
Just a second, I take a photo with the audience.
You go for it.
Awesome.
Do you want me to get one here? So that was the second talk about accessibility today. Who feels more motivated now to make their sites more accessible? Okay, a few hands, that's good. That's great. So next up, we've got 2 more talks before another break. We're going to learn a bit more about AI and machine learning. And so I'm going to hand over to Sean, who's going to be teaching us about some AI.
I just need to make sure that I can plug it in. I haven't actually tested this.
No worries. I think Trung has the clicker. Trung, do you have the clicker? Do you have a clicker? Is that yours, is it? Or? Okay, no worries. Yeah, can Sean borrow it? Yeah, please.
Podium is fine. Okay.
Sean,
there's a podium mic apparently. There's a podium mic apparently. I could just do this. Okay. I just need to make sure that this thing shows up.
Or yours?
How do I do this? Sorry, we didn't test the mirroring. Mirror for built-in display. Okay, I think we're set. Thank you. Hello, hi. Hi everyone. We only have 20 minutes, so I'm going to go relatively fast, but it's very good to see a lot of you. And the talk title that is listed on the schedule is something I had as a placeholder, and then I forgot to update it. But this is really the talk that I've been working with for a lot of my US conferences, and then I wanted to do something special just for the Singapore Southeast Asia crew. And basically, the first half of it really starts about defining this term of the AI engineer and how it's relevant for potentially a JavaScript audience. I strongly identify with it. I come from the JavaScript community. And you have a role to play, and I think it's a very strong, I can make a very strong case for it. This whole talk, or this whole thesis comes out of an essay that I wrote actually on the 1st of July that got quite a lot of attention, and I think that that resonates with people, and people have this innate desire to want to define a place for themselves because they don't feel like they have a place for them in the AI field because they don't have a PhD, because they don't have years of machine learning experience. And so, I think that the main case that I'll give to people is that AI is shifting right. This XKCD is literally from 2013 that actually describes the state of art in computer vision. Like when you want to identify a bird, you actually need a research team in 5 years. Now you can just take it off the shelf. In 2023, all we're doing now is prompt engineering. And it's shifting right in the sense of who does AI in an organization. And I think that while the tech has advanced, the attitudes to the tech have not advanced. So 35 days ago, there was this question on Hacker News: how do I break into AI engineering? And the top 2 responses I captured, one was do all the machine learning courses. The other one was do all the data engineering courses. I will submit to you that both are wrong. You can actually be very good. You can be a very good AI engineer without doing any of that. It helps, right? It's not like it's not actually additive. And so this is where kind of the primary visual for what I want to communicate, right? That traditionally the job of AI in any organization is located with the ML team, or ML researcher, ML engineer, ML ops. And then the full stack engineers, the people that work in product like us, are typically like, kind of siloed away. Now that there is an API layer, now that there's a lot of outsourcing of the sort of fundamental research thanks to foundation models, there is an emerging stack that you can specialize in that is a job that is emerging that I think JavaScript developers have a role to play. And so that's the main thesis. It's actually, it's not only a tech argument. It's not talking about like fundamentals of tech. It's actually about economics. There's probably about 3 to 4 orders of magnitude more AI engineers than are available ML engineers. And just the sheer scarcity of ML research talent means that there will be a less research-oriented, more product-oriented subdiscipline that emerges for software engineering. And I think that is probably some people in this audience right now. I also think it's not just about people, it's also about GPUs. Just fundamentally, there's billions of dollars being poured into buying up GPUs, and not every company on earth will be able to get the allocation to the hardware that they want to have to run a traditional ML organization. So in other words, instead of buying your own hardware and hosting it, you're going to consume it through APIs. And that is no longer the domain of ML researchers, it's actually the domain of software engineers, which is something we're very well capable of doing. This chart shows, this chart is from the Stability AI demo day where they actually showed a nuclear arms race in terms of numbers of GPUs. All these companies are just hoarding GPUs like nobody's business. It's also about sociology. So it's, again, like this is about people, it's about GPUs. It's also about just like internal culture within a company. Every company that I advise a few companies, and every company that I know of has this informal Slack group, Discord group, whatever, talking about AI. And it's just kind of grown over time. It started as one channel and then more channels, and now I have a whole Discord running around, having conversations daily. And my whole thesis is that these informal teams that form will eventually become formal teams with an actual role in the org chart, job titles to match, career ladders to match, competencies to match, conferences, you name it. It's going to happen. But it is also, so I made all the non-tech reasons, and now I can make also the tech reasons, right? Like the fact that GPT-3 is actually showing few-shot learning, which is a sort of in-context learning that, and to the rest of us, that is prompts. Segment anything model in the vision space can also do zero-shot transfer, meaning that you no longer have to wait to collect a whole bunch of data to do work on that specific domain. You can actually train on a set of foundational data and transfer it to things that it has never seen before. And that is something that's fundamentally new. And I think from a PM products, I'm very interested in startups and products. The traditional workflow is you collect a whole bunch of data, you train a model, and then you ship a product. What foundation models help you do is to flip that completely around. You prototype a product first, and then if that is successful, then you collect the data to make your own model. And this is a much faster time to market than anything else. I kind of compare it kind of to the equivalent of waterfall versus agile. And lastly, and best for this room, there's also a massive shift from the Python community to the JavaScript community. Like AI is traditionally, historically, very, very Python-centric. But now that all you need is to be able to read API docs. JavaScript it's like another 20 million developers that are unlocked that can manipulate these APIs. So I do think that there's a rising class of engineers that will be specializing in this, and they will probably call themselves AI engineers. Companies will probably want to hire AI engineers as well. And finally, I think there's a strong reason for engineers rather than non-technical prompt engineers. And so this is a strong opinion that actually differ from Andrej Karpathy, which is the role of code. I call this kind of the 1 + 2 = 3 thesis, where software 1.0 is handwritten code, software 2.0 is machine learning derived code, and software 3.0 is foundation model based code. And the argument is that you want the foundation models to write code in order to do things that the foundation models inherently cannot. And this is a very, very recent development. In September 2022, we're just discovering that you can embed a REPL inside of GPT-3 and it can kind of do math. You know, the GPT-3's no weakness is it doesn't add things very well. Fine, just ask it to write code to add things, and then it adds the things inside of a REPL environment, and then it goes back into the model. Now, that was where we were 9 months ago. And here we are in June with messing around with code interpreter that can produce all these fancy charts. And I think that's the direction of code is essentially where this is going. Like progressing from GPT-3 to 3.5 to 4, and now being able to write code in the loop is able to fill out a lot of the functionality that it was lacking in previous times. And so that's really good news for you software engineers, because you can ask it to write code, you can evaluate the code that it runs. You have as much, I don't think you understand how much power you have now over the non-technical person. It is scary. And then finally, I think this is a more subtle point I've been pushing that I don't think I have the way to push. A lot of the architectures that people are doing to write their AI apps are basically LLM core apps. It's LLM at the core and a thin wrapper of code around. The fundamental trend that I'm seeing that's shifting is that they're actually splitting apart the role of the LLMs into domain-specific use cases and then stitching it together with code as the core of it. So fundamentally trying to escape the LLM capabilities, because we know how to scale code, we don't know how to scale LLMs. And these are all the problems that I basically identified in my piece, and I organized a conference that is not going to be here, that is in San Francisco. So the second part of my talk is, all right, this sounds great. Everyone's very excited about this. What should I do based here, where the community is definitely very US centric. And I really like this. I really like this conference in particular because Aris has invited me, for 3 straight years running, and I always want to give a message to my fellow Singaporeans, right? Like I'm from here. I will come back here. I always want to give a message that like you have a role to play on the world stage. Surprisingly, the Singapore research team is very strong. Don't be blind to this. The tech lead of Google Palm, UL2, Flan, Google Bard, graduated from NTU. NTU. And within 3 years, he was the tech lead for all these top models at Google Brain, and he's just left Google to work on a startup. I just had a really nice conversation with Eugene. I don't know, are you in the audience? Hey, of UILicious over there. UILicious, great sponsors, by the way. Thank you for sponsoring this event. Who is working on this open source in Singapore. Like, no one actually knows that he's from Singapore. I don't think no one cares. But if you just put in the work, you can actually be a very cutting edge person in open source AI. And I think I just want to encourage you, like, this is possible even though you don't live in San Francisco. And basically, on the internet, nobody knows you're a Singaporean. So if I have a little bit more time, I am actually trying to, like, a lot of people are asking me for, like, what do I do, where do I start, what do I do? I'm actually developing a course on this, and I'm not, like, it's a free course, it's not done yet, but I'll just preview to you. You're the first people in the world to see this. And I think there's basically 7 core competencies. One, the first one, you just, like, learn to manipulate the OpenAI API. Understand the importance of streaming. Streaming is now the standard. Like, you have to know how to stream, because that is how the time to first token, that is how the perceived performance of your apps will feel magical and will feel instantly fast. Learn to read through the OpenAI cookbook. It's a GitHub repo. It's a lot of gold in there, and most people don't even know about it because it's not in the official docs. Learn to manage token limits and read the doc on best practices. So that's day 1 of the course. Day 2 will be about prompt tooling, and this is where you interact with vector databases and start to learn the new tools that have emerged, like LangChain and Llama Index. Day 3, code generation is something I talked about. It's very, very important for you as a software engineer to understand how to manipulate LLMs to write code well and to understand where it falls short. And knowing that difference will make you a lot more effective, because you can effectively have your own little small developer working for you. Day 4 starts to go a little bit more multimodal, right? So we went from the modality of English to modality of code, and now you can think of the modality of images. Image generation, I think, is very well known, but you might want to think about the things that people pay for. And so my ultimate goal is really for, like, once you're an AI engineer, any founder, or if you want to ship a product yourself, you should be able to be familiar with all the basic tooling that everyone else already knows well. And so this is Dream Booth, and this is a dog that someone, like, submitted. You should be able to pose that dog in made-up images. And this is a very, very common skill. You can take a day and learn it. It's very, very, very accessible. Day 5. Going to the audio domain, you should be able to manipulate speech to text, and you can do it in real time as well. And it's very fascinating. I wish I could show you this demo, but I can't. I don't have time. Day 7, well, I think day 6, fine-tuning and running open source models. This is just a Wild West, but most people have not had the time to go through the top models. And so these are the main ones that you want to know. And then understanding on how to host it on GPU infra. You can't just push it to Netlify or Vercel. You have to figure out a new set of model hosts. But again, very well within your capabilities, you can do it in a single day. Day 7 is the most frontier of it, and that's AI agents. I have a blog post about this called The Anatomy of Autonomy if you want to check it out. And that's it, that's 7 days. I'm working on this as a podcast, as a newsletter, and I'm basically trying to help people understand this from the perspective of a software engineer interfacing with this. We just cracked number 10 on the US Tech Podcast, so I'm very proud about that. And thank you.
Thank you, Sean. Does anybody have any questions for Sean?
I don't know. Yeah, are we behind or?
A little bit behind, yeah. We're about 20 minutes. But anybody? No? Okay. Well, I'll invite SD down. And this is the second talk around this topic. This one about machine learning. And so, please, take the stage.
Are you going to use the podium mic or the handout mic?
Yes, please. Thank you. Yes, yes. Can everyone hear? Okay. Yes, I want to use the screen. Maybe can anyone help me with the display? Oh. Do you know how to mirror the display?
Go to the display. Display, sir.
Display.
Orange.
Yes, I don't know.
No, orange.
Option. Press option.
Okay, I'll begin my talk shortly. So, thanks everyone for coming. I'll be presenting on easy translation using DeepL. So, some intro about myself. I'm a software developer and also occasionally blog about stuff that I learn about tech. You probably might know of me through my work in Supabase and also some other open source projects. And I'm a low-profile developer that likes gaming, webtoons, and anime. But otherwise, career-wise, I'm a software engineer at Padlet, working on the web app and mobile app. So before I begin the actual presentation, I'll just talk a bit about Padlet, because every one of you almost asked me what the hell is Padlet. So Padlet is a software company that's based in SF, but most of the team is over there. Yeah, they are sitting there. Yeah. So Padlet is a software where you can upload any type of content. So you can see got the pizza, got the sun. So these are like images, but you can also like upload maybe map locations and also text. So it's a very nice collaboration tool, and a lot of teachers use it to organize lessons. And one of the cool features is what you're seeing now. So this is a slideshow. As long as you have upload content into your Padlet, you can convert it to a slideshow, like Google Slides. So later you'll see the main Padlet, but for now, we'll proceed with the presentation. So what the talk will be about. I'll talk about how translation is generally done, and what is DeepL, who uses DeepL, and actually using the product. So how is translation using done? But before we talk about that, we need to first understand how strings are usually stored. So this is a PDF. Okay, let's start from the beginning. For very basic strings, usually you will store in a constant like this, like a welcome text. And then if you want to add multiple languages, maybe at the start you'll think, oh, well, let's just declare another constant. But then as you add more languages, that is not really sustainable. So then maybe the next line of thought will be, okay, let's create an object to store these strings instead. Maybe I can have the main key as welcome, and then the different languages. So something like hello, welcome, and then konnichiwa, yokoso. So after that, then you think, oh, then what if I have more strings? Do I just add another key for the question? Like what is up for snacks later? So because after my talk is a break time already, but don't think about it. So then the next solution that most people have standardized to, as well as I18 and NICS, is to use multiple local JSON files like this. So there will be an English.json and then a Japanese.json. Sorry. Okay, yes. So how do we get translation? Though this is the fun part. Usually you would think about like, oh, let's just go to Google Translate and copy paste a text that you find. So something like this. And then after that, you would think, but what if I have multiple texts? Am I going to do this for each one and single them? Well, a cool thing that I found out accidentally is that Copilot can do it for you. But let's not do that also. And finally, this is the, one of the more established solutions for getting translations. So you hire actual professional translator to like just translate strings for you. But I'm actually a poor developer. I don't have money. I don't have the resources like my company. So how do I do it? Well, you can use DeepL. So it's currently known as the world's most accurate translator. And so what it does behind the hood is something like this. Or you can ask the ML AI experts in the panel over here. But they just do some machine learning and deep learning to get very accurate translations. And even professional translators have said that they think that DeepL gives better translations than Google Translate and everything else. So this is a very appealing reason why we should use DeepL. So who uses DeepL? Let's start with a very easy use case. Because most of us are gamers or like are familiar with anime, I will just show you this video briefly. I'm sorry about the thumbnail. I don't know why the guy chooses to do it like that. The sound is not playing. HDMI.
Go to the audio settings.
Audio.
This sound,
sorry. Okay.
Is the speakers changed to Matrix 4x4? Matrix? Yeah, this one.
Being my life.
Oh gosh, I'm very sorry.
Being my life.
Okay. Okay, I'll just show you 10 seconds because that's all you need to know how DeepL is being used.
Thank you for saving my life.
Okay, so the first part, right, you see him talking in English like a normal guy, and then like suddenly it becomes the waifu version. So the waifu version is what the gamers online actually hear. They don't hear the guy talking. So it's pretty cool that you can use DeepL to just translate your voice like that. And that's one of the use cases that the layman can do lah. Okay. Then the next use case would be, now that we are doing like the Twitter migration, Mastodon is one of the software that actually incorporates accessibility a lot, and their translation is done using DeepL. And finally, Pellet will also uses DeepL for translating our support knowledge base. Yeah, we support 31 languages over here, which is like what DeepL supports. Okay, so now you know how who uses DeepL. Let's talk about how to translate an actual local JSON. So this is what I briefly showed just now for how the local JSON should look like. So the key will be an English text, and then the value is what you want to be the translation result. But then if you use DeepL directly, this is what happens. Even the key gets translated, and this is not what you want, because then your website won't render that value. So let's try fixing this problem. Since the talk is about easy translation, right? So I'll demonstrate the DeepL on starter projects, something like npm create and something. But then, since we are also lacking time, I'll just show you the preview of it. So here's an example. Vue.18n is a plugin that's used for Vue.js. And if you go to the Nuxt3 framework, which, by the way, I don't know how to use the framework, but I could integrate the DeepL GitHub action over here. Yeah, it's in the official docs. So you can follow it, and you will get an app like this. Yep. So it's a very simple app. You just translate into different languages. And let me know if you can't see the text. Okay. So the workflow is over here. It's a very simple translate YAML. You just use the DeepL translation GitHub action. And every time you want run a pull request, or you can configure to your needs, you'll translate every locale JSON that's within your project. So something like this, hello name, and then language. Then you'll get the other locales. Something like this. Okay, then moving on to the slides. So one tough part about this is that initially you would think that why not you just like take the value in a JSON and translate it rather than the whole object, right? So that's what I did initially. But do you notice a problem in the es.json? Okay. So this is the problem. If you just translate the value, you will end up like missing the parameter. So you then in the web app you have the i18n plugin won't be able to find the particular value to replace. Then your app just crashes. So the next iteration would be to actually keep all these values and leave them untranslated. This provided out of the box with the GitHub action. But one drawback is that if you notice carefully for like the Japanese and the Chinese version, oh, not Chinese, sorry, the Korean version, the sun and the, like the polite term for addressing a person is lost because of keeping that particular parameter. This can be also addressed using like argumental positioning of braces later on, but I haven't implemented it. You can open a pull request for it. Yes. Okay. Then the second project, so we have looked at flat JSON, which is one level depth. The next one will be on refine i18. And so this is an example. It won't be en.json, but it will be like a folder that's like locale/en/comments.json. So again, you can find this in the docs, how to create a translation for other languages in an automated way. So this is the project. This is the deployed version of the app. So you will have like admin dashboard, and you can click on stuff on different languages. You can change from Japan, EN, ND. Then all of this will be translated. So for this, there's also the workflow. And since you saw it already, I won't show it again. Let me find the public. So each language will have their own JSON, and the common JSON, interestingly, has multiple layers. So they have pages, login, and then title. So this is a different way of structuring locales if you have same text across multiple pages. Yeah. So again, you can use the GitHub action to do it. So after we talk about like saying that DeepL addresses the issue for JSON files, what about HTML? So this is an example request and response directly from the documentation. You can see that they actually translated quite well also. Like all the title and paragraphs are translated. But then there's a tiny issue. I'll show you in this project, Superbase. Okay, so here's a side-by-side view of the translated versus the original README. So for Markdown files, it's a bit more difficult because DeepL actually doesn't support it out of the box. But for most of the part, if you use their XML formatting instead, it still works. So this is the result. You can see on the right, most of the things are still translated very well. And Markdown doesn't use like the text. So you might expect some problem if you use DeepL directly. But with the GitHub action, it might be better. Yeah. So one interesting use case that came about is to ignore specific terms. So just now we saw in the JSON that certain parameters are ignored. That is done by interesting trick. Oh, yeah, this by the maintainer. So because in certain languages, they are objects rather than how we interpret them as programming language. Like Rust is supposed to be a thing to be translated. So I looked through the docs and there's an ignore text parameter that you can use. So this is how you use it. You just put something for the ignore text, and then the example response will be will exclude that for translation. So this is the before state where with the English, you don't want to translate any of the languages. So this will be the end result of what is translated. Only the headers will be translated. And this is done by adding a no translate start tag in the document. So then I will pick up this text and let DeepL know that, hey, don't translate all this. So then they will end up as only translating the text that you want. Okay, so what's the benefit of using this GitHub action over like implementing your own DeepL node call also? Well, you can do that, but with a GitHub action, it ensures you get the most up-to-date translation for your project, especially for open source projects. So you see on the left, right, this is the translated file by the community 1 year ago. Because no one touched it and like no one has been actively keeping up with the README, the project maintainers didn't know. But after I added this GitHub action, it's obvious that how many files were left unattended. So if you have an action, you can make sure by yourself that most stuff are up to date for every language. And then if you use the GitHub action, there's less translation effort. So just 2 weeks ago, a guy helped to contribute to the translation by making the phrasing better. So this is something that they can do instead of looking through the whole English document and translating from scratch. Okay, so this is the conclusion. You can use this GitHub action by going to the marketplace and then and I wanted to echo this statement that is found in one of the GitHub articles that I like. So every person deserves equal right to access information. This is the words of Paul Chell, which is also a Dota gamer, whose disability has been a catalyst for creativity. So although we have been talking about accessibility in terms of HTML structure and so on, language is something that you shouldn't be missing out also. Not everyone will have a browser that provides inbuilt translation by default. It will be good that every app provides their own localization in some way or another. Okay, thank you.
Thank you, Esteem.
Okay, so if you want to look at the main palette, please scan the left QR code. You'll see like all the slides at a glance. Then the slideshow will be this presentation slide. For the right one is my website QR code. If you want to create a QR code like this, I will open source my project soon so you can use it. Yes, thank you.
Thank you. We're going to have a break now, about 15 minutes, so we'll see you all back here then for 4 more talks this afternoon. See you then.
Asian people, we need to have good photo. Thank you, thank you. All right, 1, 2, 3. Thank you very much. Thank you. Yep, absolutely. So you don't have Twitter, right? Huh? I don't think you're on Twitter. Oh yeah, you don't have Twitter. So how do we YouTube? LinkedIn. Oh. Yeah, I think LinkedIn. Sorry. Very picky. Right. Look here. 1, 2, 3. Từng người trước hay là cả hai người luôn hả? Rồi, look here. 1, 2, 3. 1, 2. Okay, I think it's good. Anh chụp em kiểu nào? Thank you so much. I'm a big fan of you. Hương ơi, chụp anh kiểu ảnh với bạn. I also Oh yeah, sure, sure, sure. Okay. Hold ha.
We did it! We made the app. That's only half the story. Soon, with a little luck, we'll have a ton of people using and loving our product. That means user accounts, authentication, security. You know the drill. But this part right here can be just as important as the app itself, because behind this login box is a lot of your users' information. And they're trusting you to keep it safe. It's important, but it doesn't have to be hard. That's why we use Auth0. It's an identity platform for developers that makes it easy to connect any app, like ours, to the authenticators and integrations we need. But wait, I bet you're like, we could do that ourselves. It's not that hard. We know what we're doing. First, I hear you. Second, are you sure? Users want security and flexibility. You want to give them all the newest sign-in options as soon as they're available, because they want to use your app on their terms, not yours. With Auth0, I can easily customize my login with the features my users want. I can create a custom two-factor authenticator for added security, and easily enable the multi-factor authentication methods I want. It even has breached password detection, so if someone else has a security breach, I can keep my users safe. Our security is always up to date and regulation compliant. You made an app, and Auth0 makes a better, safer experience for your users.
Are you still testing your web applications by hand? Really? Come on. Don't tell me you're too busy to automate testing. With UILicious, testing is a piece of cake. UILicious is a low-code platform for cross-browser testing. Our philosophy is test user journeys, not HTML. Let me show you. Here's how I write a test for github.com. First, I go to github.com. Then, I click Sign In, and I fill in the email and the password. Finally, I click Sign In, and I should see the error message, incorrect username or password. Let's select a browser, and press the Run button. Ta-da! The test is complete. I can also use UILicious's test authoring AI assistant to generate tests. Let's generate a test to log into Netflix and change password. Sweet! Once I've set up the test, I can schedule it to run anytime, any day, even when I'm asleep or on vacation. I can also set up notifications to alert my team when the test has failed. Now, with automated tests, I can know for sure if my new changes are good to go into the hands of my users. Try UILicious for free today.
miles per hour. 300 sensors. 1.1 million data points a second. Sent instantly to the AWS cloud. so machine learning can react in real time to keep millions of fans on the edge of their seats. If AWS can do this for F1's data, imagine what it can do for your business.
We did it! We made the app. That's only half the story. Soon, with a little luck, we'll have a ton of people using and loving our product. That means user accounts, authentication, security. You know the drill. But this part right here can be just as important as the app itself, because behind this login box is a lot of your users' information. And they're trusting you to keep it safe. It's important, but it doesn't have to be hard. That's why we use Auth0. It's an identity platform for developers that makes it easy to connect any app, like ours, to the authenticators and integrations we need. But wait, I bet you're like, we could do that ourselves. It's not that hard. We know what we're doing. First, I hear you. Second, are you sure? Users want security and flexibility. You want to give them all the newest sign-in options as soon as they're available, because they want to use your app on their terms, not yours. With Auth0, I can easily customize my login with the features my users want. I can create a custom two-factor authenticator for added security, and easily enable the multi-factor authentication methods I want. It even has breached password detection, so if someone else has a security breach, I can keep my users safe. Our security is always up to date and regulation compliant. You made an app, and Auth0 makes a better, safer experience for your users.
Are you still testing your web applications by hand? Really? Come on. Don't tell me you're too busy to automate testing. With UILicious, testing is a piece of cake. UILicious is a low-code platform for cross-browser testing. Our philosophy is test user journeys, not HTML. Let me show you. Here's how I write a test for github.com. First, I go to github.com. Then, I click Sign In, and I fill in the email and the password. Finally, I click Sign In, and I should see the error message, incorrect username or password. Let's select a browser, and press the Run button. Ta-da! The test is complete. I can also use UILicious's test authoring AI assistant to generate tests. Let's generate a test to log into Netflix and change password. Sweet! Once I've set up the test, I can schedule it to run anytime, any day, even when I'm asleep or on vacation. I can also set up notifications to alert my team when the test has failed. Now, with automated tests, I can know for sure if my new changes are good to go into the hands of my users. Try UILicious for free today.
200 miles per hour. 300 sensors. 1.1 million data points a second. Sent instantly to the AWS cloud. So machine learning can react in real time to keep millions of fans on the edge of their seats. If AWS can do this for F1's data, imagine what it can do for your business.
We did it! We made the app. That's only half the story. Soon, with a little luck, we'll have a ton of people using and loving our product. That means user accounts, authentication, security. You know the drill. But this part right here can be just as important as the app itself, because behind this login box is a lot of your users' information. And they're trusting you to keep it safe. It's important, but it doesn't have to be hard. That's why we use Auth0. It's an identity platform for developers that makes it easy to connect any app, like ours, to the authenticators and integrations we need. But wait, I bet you're like, we could do that ourselves. It's not that hard. We know what we're doing. First, I hear you. Second, are you sure? Users want security and flexibility. You want to give them all the newest sign-in options as soon as they're available, because they want to use your app on their terms, not yours. With Auth0, I can easily customize my login with the features my users want. I can create a custom two-factor authenticator for added security, and easily enable the multi-factor authentication methods I want. It even has breached password detection, so if someone else has a security breach, I can keep my users safe. Our security is always up to date and regulation compliant. You made an app, and Auth0 makes a better, safer experience for your users.
Are you still testing your web applications by hand? Really? Come on. Don't tell me you're too busy to automate testing. With UILicious, testing is a piece of cake. UILicious is a low-code platform for cross-browser testing. Our philosophy is test user journeys, not HTML. Let me show you. Here's how I write a test for github.com. First, I go to github.com. Then, I click Sign In, and I fill in the email and the password. Finally, I click Sign In, and I should see the error message, incorrect username or password. Let's select a browser, and press the Run button. Ta-da! The test is complete. I can also use UILicious's test authoring AI assistant to generate tests. Let's generate a test to log into Netflix and change password. Sweet! Once I've set up the test, I can schedule it to run anytime, any day, even when I'm asleep or on vacation. I can also set up notifications to alert my team when the test has failed. Now, with automated tests, I can know for sure if my new changes are good to go into the hands of my users.
Hello, everybody. Has everybody enjoyed the cakes and cookies? We good? So I'm going to ask you to stand up one more time today. So if everybody could just stand up, we need to raise this energy again in this room. So everybody on your feet. So we've done the Mexican wave, and we've done spudding everybody. So what I want everybody to do is just shake it out. Shake it out. We've been sitting here all day. Shake your legs, shake your hands, and let's get started with this evening's talks. So before we start with Derek today, I'm going to hand over to Vonage and Benjamin, who's going to be doing a raffle and a giveaway. So it looks like you can win a cool piece of Lego there as well. So let me just hand over to Ben. Would you like to hold it? Do you want me to hold this?
Yeah. Can I plug in real quick?
I'll do that after. I'll do that.
What? Sorry, everyone.
Who's this?
I don't know, it looks like vodka.
Oh, that's mine.
That's
Vodka.
awesome. Is it a water bottle?
Special powered for speaking events.
Yeah. Where's my mirror display? Sorry, everybody. Just 1 second, and we're going to give away the moment everybody's been waiting for, at least if you saw us on the sponsor booth. Yeah, I just need to mirror my display, sorry. Apple updates, I have no idea where it is.
Just search this screen.
Yeah.
This one?
This one, no?
Yeah.
Done.
The range. Put it inside.
They changed this, I don't remember.
Yeah. Put the other one inside the other one.
No, it's not going in.
Oh my god.
It should be this mirror off.
There's a button to do.
You know what? Here, you know what we can do? We can just go like this. Okay.
Yeah.
So, classic conference sales pitch. We're not just going to give away the raffle. We're going to show our Vonage's AI Studio, our low-code platform, really quick to show how quickly you can build something awesome. Here, I built a little WhatsApp agent. So here, like any low-code platform, you just have your blocks. Oh no, you're not supposed to see this. Nobody scanned this yet. So here we just, we can tell in the AI Studio, send messages. These agents, we usually use them for marketing or customer service. And AI Studio really helps you get going fast, where even people who don't know how to code can build these agents out of the box. Now the power here is, what's the AI in AI Studio? We have text classification. So here in this agent that I made literally in, I think, 10, 15 minutes, it just does two things. So you can text in, you can either learn a little bit about Vonage, or you can find out who's the Cityjs winner. And here we're gonna let the users free type, so they can add any text, and then the AI, the NLP model, will sort out those texts to which intents they have and where in the flow they want to go. So here, I'll show you the flow that shows explaining a bit about Vonage, and then I won't show you the winner yet. Hopefully nobody completed already the testing. But right here, built in, we have a sandbox where we can already see how this looks. So I'll just put in Vonage. What's that? And I didn't put in this as an example for the agent. It's I put in a bunch of different like sentences that are kind of similar to this, and it's going to already know what I mean when I say Vonage. What's that? Cool. Conversation ended. And now, before I do the QR code that everybody scans to find out who's the winner, let's have a little bit of a drum roll, please. And now if you scan the QR code and ask the agent who won the raffle, we'll have the winner. And if you're the winner, please stand up and announce yourself. So it should pre-fill a message that says start. That's just because we're in the development environment. You just hit send on that pre-filled message, and then ask it who the winner is. Okay, so come down and claim your prize. There you go. Let's take a picture. Sorry. Cool. Thank you so much. Thank you. Thank you, everybody.
And it's just one more thing. Thank you. So this was Benjamin, our sponsor, Vonage. And I also have some bags here. Derek is going to be speaking about AWS next. And we have some wonderful bags. And so I'm just going to throw these behind my head. One this way, and one this way. And maybe I fling it. I'm going to fling one up top. And so whoever gets it, yeah?
I can throw too.
Aris is going to throw too, so let's go. Thank you, everyone. Are you plugged in? Okay. Hope you enjoy the bags and the Star Wars Lego. And without further ado, I'll hand over to Derek. Thank you very much.
Okay. Hello. Good afternoon, everyone. For my presentation, it will be far less dangerous than the swag, so not worry. So thank you all for having me. My name is Derek Chen. I'm a solutions architect with AWS Singapore. And today I want to share a little bit on how do we actually design and build micro front ends on AWS. So a little bit more about me. I'm currently working as a solutions architect. I'm a developer specialist in the DevX team. And I go around the region helping enterprises build software better, right? So my mission is to empower developers to build faster and better with what we call the adaptive systems design. And previously, I was a software engineer, so I'm really into software development, and this is why I want to do the work that I do today to help more people to build better and build faster. So to just have a very quick introduction of what we mean by adaptive systems design, the core principle is about having a nimble architecture that has least cost of future changes. If you think about your existing code bases, how many people, right, thinks that your current code base needs a refactor? And how many of you actually want to do the refactoring? All right, that's right? So, I mean, we are all, amazing developers. We follow the standards of what we consider as modern at different periods in time, and we create these wonderful applications. But eventually, over time, they become outdated. So my work today primarily revolves around how do we keep modern application modern. And micro frontend is actually a way to do this, right? So let's look into what we're going to talk about today. We're going to talk about what is micro frontend, so we all have a common understanding, and we're going to look at some very high-level benefits and trade-offs, and how we're actually going to design the micro frontend so we got the structure right before we actually delve into the implementation. And finally, I will show you some architecture sample diagrams of how you can deploy your micro frontend services on AWS. Okay, so what is micro frontend? But before that, let's look at something we're all very familiar. All right, who has built an app like this before? Right? right? If you have done like a side project or you have worked in an enterprise context, right? If you are on one team, you build a product internal facing for your internal stakeholders, most likely this is what your app look like. You have a front end that's built and deployed as one unit, and you have a backend service that has, probably a few different APIs to supply the data and to do some manipulation for the presentation layer. So, and if we go into micro front end, what we're really talking about is an architectural style where independent deliverable front end applications are composed into a greater whole. I really like this quote because the very last part, a greater whole, right? So in terms of micro front end, the actual application is more than the sum of its parts. And it's also into a greater whole because at the same time we have these benefits, we also introduce some trade-offs that I will touch on later on. So how will it look like? So this is how a micro front end application would look like, right? So we need some kind of container application still on the front end as sort of a container to house all our micro applications that will be independently deployed. And as you can see, we can use patterns such as a backend for front end, BFF, to manage, to have a dedicated endpoint for all our front end requests for each and every micro child application that we have. Now you might be wondering, why do I need to split my applications into all these different parts? The easiest answer is when the product grows, the natural complexity increases. And what do I mean by that? Have you ever heard of these things being thrown around in project meetings, in sprint planning? Right? These are the signs of what we call the big ball of mud. If you have been building microservices and you've seen monolithic applications, you know exactly what I talk about. If you are hearing these statements in your meeting, that means the application, the project is on fire. Things are burning in production, and you need to put out that fire before you can add any sort of innovation, new feature requests to it. And this is when businesses slow down to a grinding halt because we cannot effectively manage the complexities and technical debt at scale. Right, so how would micro frontend help us with this? The core benefits can really be broken into two categories. So first of all, we have the speed. When we have smaller units of development and deployment, we tend to have shorter product lead time from an idea to an actual feature. This increases the release velocity of teams that are building the individual apps because you no longer have to wait for the dependencies that maybe is being held up by another team's release schedule. And of course, this enables developer collaboration across teams. Many people, you will basically step on each other's toes way less. You don't have to share so much code, and the nuggets of tribal knowledge within each of these subdomains are properly confined in the appropriate boundaries. And the other benefit will obviously be the shorter deployment pipeline. If you have automated testings, code scanning, end-to-end tests, that takes, the longest project I've seen run is 8 hours, all right? This is an actual production system that takes 8 hours for my feature to land into production. So with a micro front end design, you should land your release way faster than that. And the other side of things is the quality that you can improve with your application. I noticed that we still do have some Angular developers here, so micro front end does allow you to be a little bit more technologically agnostic, right? You can use different frameworks to build your mini applications and to house them together with the container application. And of course, this helps us to isolate our failures and have more predictability in our release cycles. But of course, it comes with its own set of trade-offs. The most obvious, I think, right, that you can think of right now is the deployment complexity. Suddenly, originally, we just needed to maintain one deployment pipeline for the monolithic front end, and then now you have 3 different micro front ends. You need to separately build, manage the CI/CD pipelines to do the code scanning, functional tests, and everything. So it's definitely added complexity there. And as the natural next step, the integration of all these smaller micro front ends to make sure that all these apps work together, it's another big problem. And for this, you definitely need very comprehensive test coverage and end-to-end tests for this to work at scale. And the unique challenge when it comes to distributed front-end development is with the UI UX consistency. When you have different people building different parts of the application, some people like to put a button on the left, some people like to put a button on the right, and maybe there's a different way that we phrase certain prompts. And all this need to be addressed to ensure that our users have a unique and coherent experience across the entire user journey. And the last technical trade-off will be the amount of data that will be needed to be transmitted to the client device will be slightly higher as well. So, right, it's all very nicely drawn, 3 big boxes, but in reality, how do you know where to draw these boxes? Right, you have a profile service front end that, okay, maybe I talk about, changing my password, updating my username or whatever. But if I want to say update my billing method, should that be part of the profile service front end, or should that be part of the billing service front end? And these are the kind of questions that we should ask as developers, because these are very integral into how we will implement our features next, so where we will implement our features. So the methodology I like to use is called domain-driven design. Anyone heard of domain-driven design? Awesome, you guys are awesome. So it's nothing new. It's actually popular. It was created maybe about 10 years ago. But to utilize this in a methodology can help you arrive at the right boundaries where you divide your micro front-end applications very clearly based on the business domain. So for those of us who are not too familiar with domain-driven design, it basically is a process that aligns our code with the reality of your problem domain. Basically, it's saying that we should write our code based on the problem that we're solving for our end users. And this makes a lot of sense to me, because after all, whether you write JavaScript, TypeScript, whether you use React or Angular, the technology is only a tool for us to deliver the business value. And if we start our application design from backwards, from what the value we are trying to create for our users, we can make sure that we don't put the cart before the horse. So at a very, very high level, we don't have too much time today, so I'm just going to go at a very high level. Domain-driven design focuses first on the strategic design, and then technical design, and finally translate that into software quality matrix. And how does that actually mean, right, in software engineering? So at a very high level, we want to follow the principles of high cohesion and low coupling. That means snippets of code that perform the same functions or mutates the same kind of objects and concepts should stay together. And at the same time, the separate units of deployment, the different micro front ends, should be loosely coupled. So if one of them fails for whatever reason, might be a botched update or an infra issue, it should not cascade and bring your entire application down. So that translates into our tactical design, which the most important piece will be the independent deployability. We want our micro front-end applications to be independently deployable. That means if my profile service receives a release tomorrow, I should not need to rebuild all the other micro front ends in order for my application to be updated to be displayed to the front end users. And all this will be measured with the DOR matrix. Of course, in your project or in your team, you may use more specific to your business matrix to also measure the effectiveness of your software. And to put this into practice, we use a method called event storming. So basically, we get everybody into the room, right, the business team and the technical team, to figure out what exactly we are building. Because when I was a software engineer, a lot of times I only know the modules that I'm working on myself. For example, if I'm working on the profile services, I have no clue how to integrate with the payment gateways. So we have all these silos and we have these nuggets of tribal knowledge spread around different parts of the team. And the first step is to get everybody into the room to sit down and use this methodology called event storming to try to piece out what exactly is the problem we're solving and how we're solving it. And once we determine that, we can use some heuristics to draw the bounded context in domain-driven design in order to establish a correct boundary for our micro frontends. Now, if we want to talk about how to actually build a micro frontend that can be stitched together in a parent application, including using different JavaScript frameworks, we need module federation. So module federation is a native plugin for Webpack 5. It acts sort of like a container and enables the sharing of JS code between front-end apps at runtime. So the key thing to take note here is that this allows the code sharing at runtime, not at build time. So to continue to use my example previously, we have a container application that will act as, you can think of the house of the micro frontends, and we may have micro frontend A and micro frontend B written in different frameworks. But that's fine, because for module federation to work, all we need to do is to expose the modular application, and then we will link these modular applications in the container, and then finally just simply import the components in the container application. So very simply, right, you can just expose the Angular app that we have right now with the module federation plugin, and then we'll declare the remote of our micro front end in the container application. And the final step is just to import it and load it in React. So now you have your Angular application running inside a React container for your micro front ends. Okay, so now we have built the micro front, but how do we actually deploy it, and what are the best ways to deploy so that teams can collaborate? One way to do this is to have a dedicated infrastructure environment for each of the teams building a micro front end. Now, this architecture is not optimized for cost, but this is optimized for collaboration and productivity, right? So this, you can see clearly that we have this trade-off that we mentioned earlier. Now we suddenly have 4 different AWS accounts that you will need, and inside each of it, we will deploy one of our micro front ends, and we'll have to manage the CI/CD pipeline within each of these applications. There will be some repeated and unnecessary housekeeping that will be required, that could be shared, but this is still required. So we're going to have our CI/CD pipeline to do to get a repository from the source code. And then we're going to trigger the build cycle to build your npm build and do your necessary testings in AWS code deploy. You can run stages such as build test, push to an UAT environment, run your end-to-end tests, do the code scanning, and then finally, once the artifacts are of good quality, you push it to S3, and then you host it on the Amazon CloudFront, which is the content distribution network. So what the greatest benefit here is that each of these teams managing one of these micro front ends no longer have to wait for the release cycle of another team, right? Some companies, they run like monthly release cycles, at the end of every month there's a code freeze, right? Nobody can check in any code. All the testers are super busy. They are running all the manual tests and hoping and waiting for that moment that everything's green and then deploy it. We no longer have to do that. Whenever your code is ready, you can release it to the environment, and you'll go through all the automated tests, and immediately the parent application will be able to pick out the latest version of your application. And that just tremendously decreases the amount of time that it takes to release applications in this manner. So the next question is, how do we actually get people to come together and build something like this? You cannot have how we traditionally have our engineers separated into different departments, all the back-end engineers into one department, all the front-end developers into one team, and all the DBAs, DevOps, whatever. No, that would not work. What we need is stream-aligned teams. So every vertical that you see, all the blue boxes, are a team responsible for one particular micro front-end application. So inside these teams, you will need a myriad of different skill sets, a mix of different kind of personas, so that you have a cohesive people unit that can come together and quickly make decisions and execute and implement these applications. In Amazon, we call this the 2 pizza team. That means if any team cannot be fed by 2 pizzas at a party, it's too big. So usually we recommend the team size between 8 to 12 developers. And sometimes we also have designers, business analysts, product managers, and so on. So a few other technology that would be also interesting include the ones to help with server-side rendering will be AWS Amplify, server-side rendering. This is a managed solution. If you are using AWS Amplify to host your application, this will be available for Next.js 12 or later. And otherwise, you can host your own UI composer with a containerized solution on AWS Fargate. And for service discovery, you can use AWS Cloud Map to sort of act as a register to keep a record of where all your cloud services are, where all the different components are. And then this also helps you to perform constant health checks. And lastly, AWS Systems Manager is also something similar, where you can abstract the actual resource and put them into something that's easily imported in the source code. So once you have this, you do not actually need to change the endpoints inside your application at a source code level if you need to switch your, say, for example, your API in a blue-green deployment. And the result is we want to produce these micro front-end chunks that the parent application can easily consume at runtime to enable frequent, fast, and small releases. And if all of these are of interest to you, our team has released a sample on GitHub. You can take a picture, or you can check it out with the QR code, and some of the snippets of source code I've shared earlier also came from this repository. So that comes to the end of my presentation. I hope that gives you some very high-level ideas about micro front ends. And there is a QR code on the right side, and if you can scan the QR code and give me some feedback on my presentation, you actually stand a chance to win USD $50 AWS vouchers that will not be flown to you. Thank you very much.
Thank you, Derek. So on the topic of micro front ends and module federation, I would like to invite Zach up. He'll be talking to us about module federation. Please give another round of applause for Derek. So there was actually one more box left over from the Amazon sponsor, so I'm just going to chuck this now. Oh. It's actually an empty box. I got you there. It's an empty one. Ready to go? Mm-hmm. All right, over to you.
All right. Is this on? All right? Yeah, cool. Okay, hey, so I am going to speak to you a little bit about what comes after federation. So very quick context, I'm the guy that kind of built it, and it's been a couple years, and as we've seen, it's gotten quite popular and kind of become the standard for the micro distributed deployments. But over time, I've discovered that it might be time for a refresh. So do we have a general understanding of what federation does, especially thanks to AWS? Yes, no? All right. The general motivation behind it was we have a lot of complex pieces of an application. Application is usually made up of several teams. Those teams want to normally work independently, either to speed up the velocity or organizational agility of the business, or because the organization itself, typically in the engineering space, is not mature enough to work cohesively together. So either we use it for scale or we use it for premature organizations and we can break them apart and let them work independently. So there are two kind of useful tactics for it. Pretty much we're looking for orchestration, dependency sharing, minimize the UX drawbacks that we would have gotten from yesteryear's micro front ends, and provide as much autonomy as we can. So, you know, we can have a pretty standard looking site. If we're talking front end, you would have something like that. Many teams, many parts, and they can be split and recombined in various ways. Usually what I'm trying to look for is something that's going to be simple or that more or less just works without a lot of cognitive overhead. There were some problems with the ecosystem and why we actually designed and built Federation. A single build has major build performance issues. DLL plugin and externals is too complicated to manage. It is synchronous, so you have to do render blocking, and it also causes a single point of failure. If you do use DLL plugin, you will get stuck in what's kind of a circular redeploy, because you need to share the modules here, and if you want everybody else to have them correctly, it creates a build loop for the whole application, which kind of defeats the purpose. Native VSM is probably the closest thing to, especially with import maps. It's come quite a long way, but it does have quite a lot of network requests, and we do lose some chunking capabilities, especially when we want to try to share modules. So what we kind of need is a scalable trade-off that gives us as much of a compromise as we can without really impacting anything too specific. So that's really where Module Federation kind of comes into the picture. And that's pretty much what it kind of looks like. I think we've gotten the general idea of it. Federation, I think we're familiar with terms here, but we have the consumer, or we have the host application that usually acts as the root Webpack runtime that starts the process off. It imports a bunch of things. We have remotes, which is anything that we're pulling into it. We have a concept of bidirectional hosts and omnidirectional, and those concepts are really combinations of the first two in various different ways. The goals of the technology were to be able to import code from independent builds and deployments at runtime. We needed a way to be able to dynamically share vendor code asynchronously in a way that does not block the application or force us to load more JavaScript than we need to serve the bare minimum of what the user is trying to do. So similar to kind of code splitting, but in our dependency negotiations itself. Deploy independence was a very big part as well. We also want the ability to have versioned or evergreen modules, similar to a lock file that you would have on NPM. Redundancy was quite important as well, and trying to bring a good developer experience, again, without sacrificing our users' experience. So the big things that I really wanted was it to be simple and it to work anywhere that JavaScript can be executed. And that's pretty much what we have now. How it looks to configure, we've kind of seen. Set it up like that. There's a consumer and a remote entry. And the code more or less looks like that. There are several ways that you can actually configure the Federation plugin, but when you're consuming it and using it, for the most part, you just require import code like you would any other time. So there's not really anything you have to learn, no real framework other than understanding what you should share and how, and configuring the plugin. You can get more advanced with the configuration, so this is probably one of the more sophisticated ways that you could use Federation. It's quite useful if you need to, if you want control over the glue code. So you need more dynamics, you need to implement A/B tests, you want to detect the environment and change what's happening, you want to QA without needing to have more than one Lambda or ephemeral environment. This is where this scenario can come in quite helpful. So that's kind of what we would configure it as, and that's the glue code that sits behind it as an example. It's definitely not the most beautiful or great example, but it gives you an idea of how you can control the interfacing between the two runtimes. So some good places to use it, I think we've covered it. Useful for global components, for feature delivery across teams, horizontal enablement. I've used it a lot for analytics, A/B testing, personalization across various teams and various parts of the organization. And it has been very useful for systems migration, multi-threaded computing, and of course, micro frontends. To keep Federation stable, since we are now going with at-runtime software distribution and self-formation, there are some rules that you would want to follow to ensure loading code that you depend on at runtime remains stable. If it can change anytime in any way without notice, how do you make sure your application stays resilient? So the concept I came up with was component level ownership. The idea is kind of similar to what server components recently came out with, so a lot of shared concepts there. But the idea is we have a smarter component, better co-location, we keep it loosely coupled, and we really enforce ownership boundaries, whatever they might look like. if we took a simple React component that you would see in a monolith, it might look something like that, sending a lot of props to it, a lot of complex data into it, and this introduces fragility into the system because now you are hoping that the shape of your data does not change and that their feature that you're pulling in doesn't crash because the shape of your data changed, especially if you're refactoring something. This can introduce a lot of risk. So what I usually suggest is we go for something more like that. Pass it the minimal context that it needs, and the component does more of this on its own. It fetches its own data, it will render itself either using suspense or some other kind of paradigm. So that's kind of the general of federation and how to use it. A big thing that has come around, and I think AWS also has something they've been working on called the front-end discovery service. And it's essentially we kind of collaborated on this to build out a schema that was inspired somewhat by Medusa. So this was a project that I built that allowed me to visualize the system and control module federation while it's running in any environment without having to touch the plugin again or try to understand how code bases are used or what's being consumed. So this is kind of what we end up getting when you run a build. It fills Medusa out with all the context. Each one of these is an independent repository, independent system, and you can see what's exposed, consumed, and who's interconnected to who. We can also jump in and see like the node views or something like that, so we can really understand how the dependencies work. And every time a build happens, the system will update, so you can see the application in real time what it's doing. We also have the dependency tree views so that you can see what version you're currently pinned at. So typically I pin it on the git commit hash, so I can support multiple versions of federated code in the same context of the application for separate parts of it. So I can see who uses what, exactly where it is, and what version, hash, or build it is attached to, and in both directions. So an example of how Medusa would actually work here is I'm going to show you an application where it's a server-side rendered application, so federation works across universally, server and client side. And what we're going to do is we're going to change out the header component, and we're going to do it without deploying any new lambdas, without starting any new builds. We're going to use the current infrastructure that's there, and we're just going to hot swap the code out, just like you would see in the browser when you refresh the browser. We're going to actually perform that universally. So this is what deploying your code looks like on a federated system. So this just shows some of the things that we kind of have there, some details about it, what's shared, all of that. All the deployments that I've got in the list here are previous builds. I go there, it's currently red. You'll see it's still my production URL. And now it's green. That's my deployment. Completely separate build of the application, but no additional Lambda, no infrastructure really backing it that I need to deal with. So that's kind of what we've got. That's where we've gotten to so far with it. And I think we've taken it as far as we can with how I had designed it a couple years ago, and I didn't really anticipate it to be popular. So it wasn't built for everybody to use. And now that there are a lot using it, it's probably time that we adjust it. So in order to adjust it, we also need to understand we need a test case, something big, something at scale. And the whole point of federation as well was to try to overcome problems of scale. And that is why I joined ByteDance. So ByteDance is one of the largest users of micro front-end and one of the most sophisticated implementations of module federation that I have seen. So it made a lot of sense to go and work there. The level of scale that we have and the problems of scale that we have are, we have 6,500 front-ends that we need to manage seamlessly. They will deploy 10,000 times a week, and we have over 5,000 engineers. There is a lot of code sharing across everything from native to web and mobile web, and now moving into the server space as well. So this is very complicated to manage. And when you do have that kind of scale, how are we not imploding under the weight, especially since this company is a hyperscale company? I don't know if any of you have worked in hyperscale companies, but you move quickly, and the infrastructure usually is hanging on by a thread after a couple of years. And it becomes very complicated to try and fix that because you're moving faster than your systems can really keep up with. So what are we doing to try and prevent hyperscale issues, and also how are we going to continue to push this to 10,000, 15,000, 20,000 front ends that we can manage more or less in the same time that you saw how I could do Medusa. So a big part of that is our software supply chain. I believe to really make a good development experience, we need to have a strong control over our supply chain and design the system to work exactly the way that we need it to for extremely large scale. So some of the pieces we want is development, delivery, and maintenance. We want to ensure we have alignments, and doing that is very helpful when you have control over a lot of your supply chain. We're able to create really tight integrations, make sure the system is efficient, and all the different parts that make up complex modern infrastructure are designed to work together, but not necessarily be coupled strictly to each other. We also have run into problems when you get to the downstream dependencies. What I will usually say is, we've probably seen this even with micro front-end. You can do a ton of things in the browser, but that's no use if you need server-side rendering. So you're stuck with maybe at best page split verticals. You can split them on the root because you can route them to separate lambdas or separate servers to handle the render. But it's very hard to do that with, say, a single component. You would have to involve more infrastructure like the edge networks and things like that to stitch it back together. You might run into hydration issues, or you have to fall out of kind of the way that I like to do them, where you just import it and use it in JSX. But you might have to fall back into like a multi-mount structure. So really the best you can do is depends on the weakest point in your application. So wherever the most rigidity is in your supply chain or your dependency chain, that's the best that you can really do without expensive workarounds. So what does some of our supply chain look like? So we have a couple really interesting technologies here that I'm going to show a few of them to you today. We have Garfish, which is a micro front-end management framework. That's kind of what helps bring everything together. If any of you are familiar with single SPA, it's a very similar kind of concept where we might want to use not the polylithic structure that I prefer, but we want to mount onto specific DOM nodes and we want something a bit more agnostic. Garfish is fantastic for that. We also have RSPack, which is a we've pretty much taken Webpack and we have rewritten it in Rust, and it is interoperable with your existing Webpack configurations for the most part. There's still a few hooks missing here and there, but the idea is if you're on Webpack, you should be able to switch quite easily to RSPack and you will receive 10 to 20 times bundler speed improvements. We also have a meta framework called Modern.js. We have VMock, WebDoctor, and we also recently acquired Oxidation Compiler. So we now own the parser, the compiler, the meta framework, the management layers. VMock you can consider very similar to Medusa, but it's ByteDance's internal version. So that's kind of some of our supply chain on how we can control this stuff. We also have most of the RSPack core team here, so thank you for coming down and great work. But anyway, so getting into a bit about RSPack here. The main concepts were we need something that's fast to start up, good HMR, Webpack compatibility was really needed, mostly because Webpack's API has served very well. And it's been very complicated for really large businesses to work within some of our more modern tools where we might not necessarily have quite as a robust an API. So when the business has very complicated needs, Webpack has generally been what we've had to fall back to, but that comes with a major performance regression, and it's extremely frustrating. Another big challenge that we had found with Webpack was, besides the speed, it was quite complicated. If any of you have configured a Webpack configuration from scratch, it's quite frustrating. You can't start in 5 minutes. You need a bunch of loaders. You need React Refresh. You need things that seem like they should just be built in. So in RSPack, we have tried to bake in most of what you need, so you can just start with it, put an entry point, and if you want to extend it, if you want all the power and configuration that Webpack has, you can add it, but you don't necessarily need it for everything because we have a lot built into it already. And it's framework agnostic, of course. I would say the big one is really the speed here, especially if you come from Webpack. There is a drastic speed improvement, and this, I believe, is a benchmark of 50,000 modules. So that's a 50,000 file application build, and we can do it in about 3 to 4 seconds. To show you an actual demonstration here, this is me compiling 3 sub-applications, and that was it. So for me to build 3 separate meta framework apps, it takes about 400 milliseconds. So that's kind of the speed you're looking at to do end-to-end build and you're done. Moving on to the next kind of piece from RSPAC, we have our Modern.js or EdenX framework. EdenX is the next generation of Modern.js. Modern.js is our open source current stack. The idea behind Modern.js really was we have a meta framework. We also have something to generate documentation and handle things like DocuSource would. We also have module engineering practices, so deploying, publishing NPM packages is quite tricky. And it would be kind of nice if we were able to fold several of these aspects into a more cohesive environment for general web development. The idea between a lot of these things is that they are not coupled. So if you see something useful, you can use just that, and you don't really need to buy into a big ecosystem or any parts of it. Tightly integrated, but as loosely coupled as we can make it work, while offering a good experience is the ultimate goal of especially EdenX, our next generation. We also have the builder aspect of it, so if you don't want any of our framework stuff or any of that, but you really don't want to deal with complicated configurations, we also have the builder part there, and you could just use that as the build system for any custom meta frameworks that you've got. If we move into VMOC, we have something very similar to Medusa, but it's our internal version, and this is what allows us to change and manage the thousands of applications on the fly very quickly and very seamlessly. To get something out and deployed, what it would look like is this. I would go into our source control manager, I would publish a new version, it would pop a version out for me. What it would look like when we're delivering is something kind of like that. You know, sorry for the translation, I can't read it either, but the screenshot really articulated the point well. The idea is there's the building process, how we deliver it, goes through review, goes through our deploy layer, merge request, and out and into storage. And then on the other side, what you can kind of see is the parallel delivery tracks that we've got. Every team can deliver with their own independent pieces, and it can all flow out without blocking anybody else. One of the things that we have seen in Federation that's been quite challenging is it's very hard to debug and understand what is it doing. So something that ByteDance has solved quite nicely is they've added a very robust layer of information that we've been able to build Chrome DevTools off of and other extensions to bring controlling these applications directly into your browser in an intuitive way. You can also just debug it and it'll flush out all the information available. So now you can see who's using what it's pinned to, where it's at, all the information that's usually hidden inside of the Webpack graph that's very hard to get to. It's now easily available. And I believe there's also a plugin system as well, so we have a life cycle in there, when a remote loads, maybe when it fails, so on and so forth, and that's an area we want to continue to extend. This is kind of what our Chrome extension looks like for VMOC. So in here, I can go in and change it, and you can see, I can see who's connected, what the graph looks like, very similar to Medusa, and I can swap out versions anywhere that I want, however I want, and I can debug and inspect it and so on. So this is quite helpful to have built right into your browser. Imagine having this in production, where you have a production bug, and you could go and debug production by rerouting a specific module just to test this out locally, right from your Chrome DevTools, and redeploy it, potentially in the future, directly from your Chrome DevTools as well. So one other big piece of this is WebDoctor. So this is something new that we've been working on, and I found it quite nice. If anybody's worked with builds and bundles, it's very hard to understand where does performance problems come from, where do they occur. Why is the application getting slower? What can I do about it? It's not easy to really understand that. We have Bundle Analyzer, but usually that's not been very helpful. And any of the other tools that are out there either don't work with Webpack anymore, or they are terrible to use. So WebDoctor tries to take a lot of the good ideas that we've had out there and bring it together in a cohesive information, how it was built, sizes of various things, try and give the developer more understanding of what's going on, hence ways to debug application performance and the bundler specifically. You can also see the entire file structure, how much everything is, what's used, what's not used. Inside of there, we have also got tree shaking analysis, so we can actually show you exactly what was not tree shaken and what was tree shaken across your build. So you can see even the code directly in there. You can see exactly how things are working and what's there and what shouldn't be there. Another big challenge we've seen is in the build time space, especially for Webpack. It's very hard to know why things are slow. So including the telemetry to actually know how every plugin is impacting your overall build speeds will help you diagnose why something is slow and try to get some more performance out of it. While a lot of this is showing you Webpack things, it also works for RSPack because the two compilers are interoperable with each other. So whatever works with Webpack should work with RSPack as long as we've got the hooks out. Still a relatively new project, but it's going well. So in here we also get some more information just about resolving time. Again, more speed. A lot of people don't know, but the module resolution process actually is quite expensive. And it's difficult to understand exactly where, why, or what. So this shows you how long every single component, every import took to resolve everywhere. And then the last part of WebDoctor is we actually can profile the build, and we can see how long every loader, every hook takes for every file that you've got. So now you have a full, very comprehensive view into exactly what's going on inside of your application, what's slowing it down, and you can think about how that could be processed differently, so on and so forth. So with some of this stuff here, I kind of want to talk about what would come next. So we already have federation, which allows us to have at runtime self-formation of our software. We have seen that we've got some very cool tools here. We have the ability to understand performance a whole lot better. And if we start to integrate these things together into a single cohesive experience for developers, what could that start to look like? So combining it, first step, if we start creating feedback loops between these things, imagine WebDoctor detects bad tree shaking or a performance issue, and if we pass the feedback loop into VMOC or Medusa, VMOC is our internal one, and Medusa is a software as a service, so you can just go to medusa.codes if you want to check it out. But the idea is we create a tight feedback loop here. So if we see something isn't right, we would be able to instruct the system to change how it operates to try and fix the problem. If there's a performance regression, we could automatically pin this to the previous deployment as long as we know that the deployment still keeps the system stable, offering ways to bring more self-healing into the application. Another big thing I think we could do is when you share software, you would maybe treat it as an external, or in Federation, we'd do something similar. A problem with sharing code is it's a double-edged sword. When I share a module, I turn off all the tree shaking because I don't know how it's used by other applications. But in WebDoctor, we can see how every single export is used across every application that's there. So if WebDoctor's data goes into something like VMOC or Medusa, we can then instruct Federation on exactly what's used where, and we can tree shake across builds and still share code in a reliable manner, or come up with certain strategies to optimize it, and if there's certain exports or weird deviation, we could go and fetch additional exports without breaking the system, but still keeping it very optimized. So a big piece of what we would like to do with the whole direction of everything is try and really meet users where they're at. A lot of ecosystems really try to lock you in quite tightly, and I think that's a big disadvantage to business capabilities and so on. It also creates a very high barrier to entry for anybody who wants to migrate onto newer technologies. If you have to have an all or none solution here, you lose out on a lot of capabilities. So what we would like to do is how much of our tools can we offer in a take it or leave it style. You don't need to use everything, use what you want, don't use what you want, hopefully you like it, no lock-in. No, gotcha. One piece we'd also like to do here with this kind of thing is since we do own our own meta framework, we would like to integrate the server-side federation alongside our client-side federation tightly into it so that we've got a really cohesive system that's designed for distributed systems at a very large scale. I also think it's time to redesign Federation. So either improving its hot reloading or at least introducing live reload natively in there would be great. Built-in support for TypeScript types, kind of offering remote types to help provide a bit more easier validation when working with these things. Adding life cycles like middleware in between the module and the runtime so that you can adjust things on the fly, personalize it, try different experiments, anything that you want. A big area I want to improve on is the resilience of it, because Federation is at runtime, so what happens if something goes wrong? Usually we wrap them in an error boundary or a try-catch or something like that to keep the system running. But if there's, but that still puts it on the developer's responsibility to make sure the system remains stable. So what we would like to do is actually bake in several capabilities, such as when you pull federated modules during the build, we will back them up into your build. Since we don't need to recompile them, it doesn't take up any extra overhead, but we can pull them down, store them in your local graph, and if for some reason the online container is not available, you could switch back to the one that was last pulled inside of your build. Same thing to offer for NPM as well, and then having those capabilities would also let us push this out to edge workers where we can't, certain edge workers like Cloudflare can't support federation right now. But if we have all this built in, we can offer several different ways to go off and get it. A big one as well would be better dev tools just built into it. And I would love to see if there's better interfaces for supporting configuring your actual plugin and what it's all doing, but configuring it not through the build. So if you want to change or expose a module or change how something is shared, imagine being able to do that through something like Medusa, and you hit save, RSPack fires up, takes 200 milliseconds to compile your application, and you're back up and done practically in the time that it takes you to tab between windows. But that could be your production build. So these are some of the ideas that we're kind of looking at. When we get into the meta framework area, I think some of the spaces we would like to improve on is root aggregation. This is always a complicated thing. How do you bring applications rooters together without re-centralizing the root structure? So something to aggregate our roots I think would be really helpful, offering CLIs, things like WebDoctor, profiling, logging, RUM data collection hooks built into the framework itself. So really anything that you kind of would want to do in a large-scale distributed system is available, and you don't need to use it if you don't want to. Keep it simple, but you can tap into more power anytime that you would like. So kind of on this, a thing that I think would be great is this concept of infrastructureless. So if we understand federation kind of, it allows us to pull code in at runtime anywhere. So if we have that in place, we don't really need a ton of backing server infrastructure. As we know, when you get servers involved, it becomes very complicated to manage and network everything everywhere. So if you have something like federation, we've essentially decoupled the file system from the compute primitive. That means every Lambda connected to your network is effectively just a worker, and you can send an instruction set to it on the fly, and the nearest Lambda available will become any code base connected to your system on demand. If we have a policy in there to say it's not allowed to do certain things for compliance, then it won't do that. But if you don't put any rules around it, it'll essentially find the warmest, most available concurrency that it's got, and it will become any service, any piece of your software, any piece of your company's stack on demand with little to no overhead. Companies where I've worked on this before, we actually only had really 2 Lambdas in the entire company, production and non-production. Every pull request, literally everything happened on the non-production, and it was a single Lambda. If you need to test things in parallel, all that would happen was the concurrency would rise. But there was no backing infrastructure beyond 2 Lambdas and I think a little JSON file. And that was pretty much our whole infrastructure. So getting less frequent deploys, offering similar concepts like bundle dropping into your infrastructure could really ease up the burden. It allows us as front-end developers or JavaScript developers to really not have to learn such a broad part of the stack just to get something that I feel is really simple, like scripts out the door. I really miss the jQuery days where it was all simple. So kind of going into this, we have things like fractal architecture. So if we build out federation, it's already fractal. Each piece can kind of sustain itself, and it's all self-forming, and we're not depending on a single orchestrator to bring the system up for us. But since it's fractal, that also allows us to do other scenarios, like create very strong redundancy layers and dynamic load balancing and optimization across the whole system, handing off workloads to somewhere else. A good way I like to think about this is if anybody's aware of Schrodinger's cat, the cat's like alive and dead at the same time until you go and check. But that's how I kind of see federation, where the execution path for your code is defined when the request happens. Until the request happens, your entire infrastructure is in superposition. Every Lambda, every server available is anything and nothing. And only when a request hits your infrastructure will it collapse onto a wave of possibility, perform an execution, and as soon as the reply comes back out, it will break back into the superposition again, ready to become anything, anywhere, at any time. So building on that, we could, if we take fractal and this concept of infrastructureless, we could get into compute resources as shared dependency. So this is kind of a new idea that I'm thinking about doing, but what if we took, similar to how Rust does bindings, where you have JavaScript and you have Rust, and to communicate across them, it creates a binding in between the two layers. What if we did that inside of the module graph for every import, for every function you did? So now the runtime would have the ability to determine, should it execute it on the thread? Should it send the call stack to another worker? Should it send the call stack to the edge? Should it send it to node? And then once you're in node, because it's fractal, the code base can continue to do that. So now you have self-distributing, self-balancing workloads where the runtime itself will decide the fastest and most reliable execution path for the client to receive a good experience. We as developers don't have to think about how we're really going to design it. Import the code, let the runtime understand the best conditions for the environment that it's running in, and it will adjust to give the user the optimal experience. Okay, almost done, sorry. So pretty much that's kind of what we want to do with it. These are some of the ideas we're thinking about. It might look really crazy and very complicated, but it's not as complicated as it sounds, but it's not as easy either. So how do we bring this really back to out of ByteDance? Because this is what we would like to do, but how does that benefit the user base? Why would you care what we're going to do? Well, I believe that would be because I'm actually announcing here that we are going to unify my ecosystem, which is all of the federation stuff, everything that I've ever written in the past 3 years, and whatever ByteDance has been working on, we're going to unify our ecosystems. So whatever we have, the idea is that you will have it. Our node federation that I've released, we're going to rewrite it, implement it with a lot of these tools, a lot of these capabilities, and as our other pieces of technology become available outside of the company, you should be able to get the benefits of that. But immediately, anything that I own, we're going to begin the unification process of, to give you something that is tested at scale, stable, and is infused with the resources of a big tech company. So thank you so much, and here we go.
Testing, testing. Cool. Thank you very much, Zach. So we've got 1 more hour left before we need to vacate this building. And so we've got 2 more speakers, Evan and Carl. And so I'd like to invite Evan up to talk about Vue.js and reinventing Vue.js. I know that the day's coming quite long as well, so bear with us for the last 2 talks, and I hope that you enjoy them. Hey, Evan.
Sorry.
Is this your phone? No. Is this your phone?
No.
Okay.
Why is it? Displays.
They removed the mirror option. You have to go to arrange. You have to click on the thing. Sorry.
Oh. Then.
Sorry. Click on the thing. Then use as.
Oh, what?
Oh.
Okay.
Like that. Yeah. UI update.
Okay. Hello, everyone. So, super happy to be here. I was actually at the Cityjs last year, but I was not speaking. I remember that was probably the first offline JavaScript event since COVID, and happy to see the crowd being much bigger this year. So today the topic, so I'm trying to go fast because we don't have much time left. It's not a long talk anyway. So the theme of the talk is about reinventing Vue. And it's about some of the things we did when we upgraded from Vue 2 to Vue 3, which wasn't really a smooth experience. And there are some things that we learned, some things we want to avoid in the future. And hopefully that can help to help you take a look into the process of maintaining something that's being very widely used and have a lot of historical burden. And if you maintain something with a lot of users, maybe this is something you can learn from and avoid certain mistakes in the future as well. So about me, I've been an independent open source developer since 2016, and I work full-time on Vue.js and Vite. Previously worked at Google and Meteor, and my Twitter handle is at Youyuxi, which is the spelling of my Chinese name. And well, I refuse to refer to the app as X, but you know what it is. And my GitHub handle is that. So if you just go to the Vue.js repo, you'll probably find me. Vue.js, how many of you here have used it? Woo, all right. Not used it, but at least heard of it? Okay. So I assume most of you kind of know what Vue is and what it does, and but here I'm just going to go over a very brief timeline of how it came about. The first release with the name Vue.js in it was in 2013, so technically it's like 10 years old now. Sounds crazy, but it's a pretty old technology at this point. So during this whole 10 years, obviously, it changed a lot. It evolved, and we added more stuff, we changed stuff. We did 2 full rewrites during this period, and the 1.0 was in 2015, 2.0 in 2016, which was the first full rewrite. And we started working on Vue 3 in September 2018. That was when we started announcing the idea about a potential future major version. And that took much longer than we hoped. Right? In 2020, that's like 2 years after we started working on it, we finally did the soft launch, where we released Vue Core 3.0 as stable, but with some caveats I'll talk about later. And we only finally switched Vue 3 to the default version in January 2022. That's last year. So technically, I would consider it's Vue 3 is like officially out with only 1.5 years, probably, because considering the September 2020 launch wasn't really the full launch. So this whole process took a really long time, and before we get into why it took so long and what kind of mistakes we did, well, I want to talk about some of the motivations. Like, why would we do it in the first place? Why do we do a new major version that changed so many things? The first obvious point is in 2018, so the Vue 2 code base is around 2019 is around like 2 to 3 years old, but we realized the code base needed to be modernized with the rise of TypeScript. So when Vue was first created, there were no type systems for JavaScript. Right? We slowly started seeing the rise of type systems in front-end engineering, and when we started working on Vue 2, the only TypeScript was out, but Flow was also an option, and TypeScript wasn't nearly as universal as it is today. So when we did the initial Vue 2 prototype, we didn't use any type system. We started with plain JavaScript and added Flow as a type checking option, but we didn't have full type coverage. So over time, we realized, okay, like this half-baked type integration is not really that much better than no types. And we actually stuck with Flow for a very long time, and the upgrading process was also a pain because every single release pretty much broke something. So eventually we felt like, okay, we want to migrate over to TypeScript, but why don't we just do a rewrite in the process? To address some other things like some messy internal architecture, like how do we more cleanly separate the internal reactivity engine with the rendering layers, with the compiler layers, and how do we have the platform agnostic cores that can target, then we add additional runtime stuff to target the DOM, target Node.js, target edge workers, whatever, right? So the core should be clean and rely on only JavaScript and not any environment-specific APIs. So that the Vue core can run in any environment, right? Vue 2 wasn't really capable of doing that. We did that to some extent, but it was not really a clean abstraction. And then the compiler capability was really limited because Vue 2's compiler, per se, was forked from John Rezik's very simple HTML parser, and it didn't even have so it didn't have a plugin system. We cannot say like modify the rules. AST traversal was not really a thing, and we also didn't have any way to deal with the embedded JavaScript ASTs inside your templates. So a lot of things needs to be rethought and re-engineered. So we thought, okay, it's time for another rewrite. And at the same time, obviously, we want to make things faster, which we did too. And then we want to also rethink the API side of things. How do we address scalability and maintainability issues? One thing with Vue 2, so obviously the APIs themselves need better type support, right? As I said previously, when Vue 1 or 2, the original options API of Vue was created, types weren't nearly as universal. And so, frankly, the original API of Vue wasn't designed with type inference in mind. So it made it very difficult when we decided, okay, we need type inference, and how do we actually do that? If you've used Vue with the options API, you know that it relied a lot on the magical this object. And every option you declare in your component needs to be somehow merged onto the same this object. And for a period of time, it was simply not possible in TypeScript because until it shipped a feature called this type. And in some way, this type was kind of part of the motivation of shipping that feature was to help Vue do better type inference. And we actually had someone from the TypeScript team to help us, teach us like, hey, here's how you can use this type to actually make type inference work with Vue. So, but even with that, the type inference performance and the capabilities with Vue 2 Options API was still subpar, especially when you compare it to, say, React, right? So we decided we want an API that just plays nicer with TypeScript, designed with type in mind. So what's better than just function calls and returned values, right? Those always have the best type support. And we also need an API that addresses logic reuse and component refactoring. One thing we've noticed is that options-based APIs, when you have, tend to grow into really messy God components that are like several hundred lines long and with a bunch of different concerns mixed across a bunch of options, and they are extremely difficult to refactor. Simply because of the way options are organized, it just discourages you from plucking things out of these options groups and then somehow find a way to move them into an external file or group them differently, right? Options just does not encourage refactoring because it forces you to put your stuff in predefined buckets. So when you first use it, it saves you a lot of mental overhead because you don't need to think. You just say, okay, here's a computer property I'm just gonna throw in here. This is where it goes. But it also locks you into that structure. So later on, when you say, oh, actually this data property, this computer property, these methods, they belong to a separate thing. I want to move them all out, but now it's much difficult because they are in different options groups. So a more free-form composition API was introduced, inspired by React hooks, and gave you the ability to more freely refactor, move things in and out of components, or extract them into reusable utilities. And the final thing we wanted to do was to raise browser support baseline. We dropped IE 11 support eventually. That was still a thing that we kind of were weighing around at the initial release of Vue 3, but eventually we said, okay, we're gonna drop it so that we can leverage new language features like proxies and future things that's gonna come out, right? We don't want to be stuck with IE forever. So I'm happy we did that. But we also made some mistakes, and I'm going to be totally frank and talk about all these mistakes we made. It was not a smooth experience for everyone, and many users are, in fact, today still stuck on Vue 2, probably like 60% of them. The migration cost is a major thing to consider, and another major blocker is the dependencies. For example, a lot of users relied on, probably built their app on, say, Nux2 or Vuetify, and they're pretty much blocked because those dependencies were not easy to upgrade. And finally, legacy browser support. Some companies, they do need to support IE 11 or like really old iOS versions, so they're stuck on Vue 2 as well. But
I would cross out the legacy browse support as a mistake on our part. So the first mistake I think we made was too many small breaking changes, right? So the trap here is when you are thinking about breaking changes, when you're shipping a new major version, we tend to evaluate the breaking changes in isolation. So when you look at, if you go to our documentation for Vue 2 to Vue 3 migration and look at a list of maybe like 20 to 30 breaking changes, it's a lot, right? But if you look at every single one of them in isolation, you notice it's actually quite understandable and manageable. Like everything, when you look at it in isolation, you're like, okay, this makes sense. We should probably change it. And it seems straightforward to understand and seems straightforward to migrate. But what we didn't realize is the complexity compounds exponentially when you combine 30 changes all together, because if you don't give the users a chance to pick off everything in isolation, then they're forced to deal with all of them at the same time. And this just results in a much, much worse experience when they are trying to upgrade. So the lesson learned is that don't break everything all at once. You should keep things working by default, ideally, and use the deprecate opt-in remove cycle. So the framework that did the best with this is probably Ember. What they did is when they want to break something or remove something, they would first mark it as deprecated, and then they give you the replacement, the better, newer API directly alongside the old deprecated feature. So you don't need to do anything. Things still work. You only get a deprecation warning. Then you can opt into the new fixed way of doing things. And then in a future release, they eventually remove the deprecated version. And they have a very well-documented process for this. So this is something we wish we did with Vue 2 to 3. We probably should have. I knew about Ember's policy like this when I worked on that, but now looking back, obviously it was a mistake that we didn't choose to do that, right? So another thing is you probably want to stagger and spread out between these changes between releases. Don't put all of them in the same release. Do a feel like, I feel like Angular after Angular 2 is kind of doing that, right? They do frequent major releases, but every release is like just small breaking changes. But over time, it can result in pretty impressive changes. And but the toll on the user is not as great as all these changes in one big release. So the next mistake is underestimating the impact on ecosystem libraries. Breaking changes were mostly discussed in the context of application level code. Again, this is like every breaking change when we discuss them, we had RFCs for these breaking changes. But when we were discussing them, we didn't have enough input from library authors. We mostly got input from application developers. And when they look at these changes in context of application code, they kind of understand this is what we need to do to change our code to make it work. But we underestimated how these changes would affect a library maintainer. And another aspect of it is we had a lot of these internal APIs. For example, the Vue 2 used the virtual DOM where the virtual node format is undocumented and not really considered public. But a lot of library authors actually kind of just inspected what properties are there and then start writing their code based on what's there. Unfortunately, right? And when we changed the internal virtual node structure, like the properties on the virtual nodes changed in Vue 3, we realized, okay, this is in fact blocking a lot of some of these libraries because they just are so tightly coupled with some of these internals. And made them difficult to upgrade, and in turn, blocked the users of those libraries from upgrading as well. So the lessons learned here is ecosystem dependencies of libraries are an absolute critical part of any migration paths. So when you're trying to think about breaking changes, always think about what are the most critical things in your ecosystem that may get affected, and actively reach out and collaborate to see what preemptively prevents this kind of situation from happening. Right? You want to evaluate your breaking changes with libraries, advanced use cases in mind, not just like day-to-day application code. From the framework design perspective, we should probably discourage and even outright prohibit the use of internal APIs by libraries. Understand the cause of, and when that happens, we should understand the cause of why they're trying to do that and try to address their needs with a public documented API so that when you are doing future releases, you don't accidentally break these things. Mistake number 3 is not releasing everything together. So as I mentioned, the September 2020 release of V3 Core was a soft launch because although Core is considered stable, many other things were still work in progress. For example, the documentation. We had sort of like a work in progress documentation that was mostly just kind of like latch on some explanation about composition API onto Vue 2 docs. But we didn't have a documentation that's targeted towards someone who's brand new to Vue and can learn the framework with composition API as a first-class citizen. And then the official libraries like Router and Vuex were kind of like in beta or RC phase. Migration build wasn't there. The dev tools didn't work with Vue 3 yet. Script setup was experimental, not stabilized. And important community projects like Nux 3 and Vuetify 3 were far from ready. So the result of this is, so the reason we did the soft launch was we noticed that many users or library authors were just holding out on upgrading their libraries because they feel like, oh, Core is not stable yet, so we're just gonna wait until Core is stable, then we start working on a new version of our library. So we're like, okay, we're gonna just release Core as stable so we can let them start doing that. But releasing Core alone without a complete ecosystem caused confusion because users were like, oh, like Vue 3 is ready now, I should start trying it, but then they realize, oh, a lot of things are still missing and or not working completely properly yet. So it had caused sour first impressions, and these impressions do spread. Like people will like post on Reddit and say like, I tried Vue 3 and it sucks. And some people will like read about it and they hold on to that impression for years because they never tried it again after they read that, right? So these kind of bad impressions do last. And you kind of have to do a lot of like post like damage prevention later on to sort of convince people, hey, like we've made a lot of improvements since then, things have changed. So the lessons learned is first impression of a major upgrade really matters. You'd rather be late than incomplete. And to prevent, so there was a chicken and egg problem, right? So if we don't release stable, some library authors just don't want to upgrade their stuff. But if they don't upgrade their stuff, then the ecosystem isn't ready. So you need to find ways to gather feedback and work with these library maintainers to upgrade their projects before you actually do a stable release, right? You need to give them confidence in private, saying, okay, like it's not officially released, but it's stable enough for you to start upgrading your library so that we can all have the ecosystem ready and ship together. So give the user a much better experience. Okay, so enough about the bad stuff. So at least we did something right. So here's what went right. The first right decision was we embraced TypeScript. Now, type checking nowadays is just table stakes for front-end solutions. If you don't have good type inference, good ID experience with TypeScript, people's gonna just think, oh, like this is from like what, 2013? And we also vastly improved the maintainability of Vue itself. So this sets up a very solid foundation for future iterations. And the second thing we did right was embracing composition. So composition API, I mentioned previously, it was inspired by React hooks, but rooted in Vue's own reactivity system. So if you are familiar with Solid.js, Vue composition API is in fact much more similar to Solid.js compared to React hooks. They are, so Solid, Vue composition API, they are a completely different execution model compared to hooks, but they do provide very similar composition capabilities. So component logic reuse and refactor capabilities are key to scale, and this was one major thing that was lacking in Vue's original design. And I'm now confident to say composition API largely addresses that void and fixes that problem. And led to really strong community efforts like Vue Use, which is a collection of view composition API functions, composables, that almost, if you think of some daily thing that's not in view core, looking to view use, there's a very high chance there's a solution there. Okay. And the third thing that we did right was investing in DX, i.e. developer experience. One of the reasons that Vue 3 took so long is because I, in fact, spent a very big chunk of that time working on Vite, kind of like to kill time, to sort of like an escape route for me to deal with the burnout during the process. But it turned out to be something great. Vite is now serving as the foundation of a lot of new and upcoming newer generation frameworks. Nux 3 is on Vite, Astro is on Vite, Quick is on Vite, Solid Start is on Vite, SvelteKit is on Vite. So in fact, anything not Next.js probably is on Vite. Obviously, I mean, you can also use RSPack, which is also great. And then we did invest a lot of effort into rewriting the docs, redesigned everything, restructured the content to make it more up-to-date, all the new best practices for Vue 3 and new introduction flows, completely revamped the thing to support both Composition API and Options API at the same time. So that was important to onboarding users who are now just taking a new look at Vue 3. And then Volar, which is our official VS Code IDE extension, we actually spent a lot of effort into this, so we now get vastly improved IDE and TypeScript experience. So for a very long time, if you've only worked with Vue 2 with the old Vita extension, you're probably just used to untyped templates, right? And for a very long time, people were like, oh, the only reason I prefer React over Vue is because React has TSX and it has all the type inference. But if you never tried Vue 3 with Volar, you'll notice that inside templates, you get syntax highlighting, type checking, everything you get from TSX, you get the same in Vue templates as well. So for Vue developers, the developer experience is just vastly improved. And the final thing is that with all these things put together, Vue 3 is indeed better than Vue 2 in almost every single aspect and is growing nicely. Right? It took much longer than we'd hoped, but today Vue 3 has largely fulfilled the goals that we started with, and now it accounts for over 40% of all Vue downloads and almost doubled growth in the past year. And the ecosystem has caught up and thriving, and I personally find Nux 3 really a joy to work with, and there are people working on new component libraries. So there are already pretty mature ones, and then there are new people working on these headless accessibility-focused components for Vue 3. There's Aku UI and Radix for Vue and all the exciting things that's coming. And there's someone worked on Trust.js, which is a Vue 3-based thing that integrates with Three.js so that you can use Vue component trees to render 3D scenes and all that. So exciting stuff coming. And for us in the Vue core side, looking forward, so stability is really the key, right? We want to let the ecosystem know that there's not going to be this kind of interruption in the future, right? No 2 to 3 style breakage in the future. Focus on improvements that are seamlessly adoptable, right? So one major thing we're working on right now is Vapor Mode. It takes the same template, compiles into something completely different under the hood, but it's opt-in, so you can opt in at the component tree level in your existing Vue 3 application, and it compiles those components into something more like the solid compilation output, which it plays really well with Vue's reactivity system. So it results in much lower memory usage and insane performance. And also in the future, we plan to do some lower level optimizations in the internal reactivity system and parser level. So these will be completely invisible at the API level, so the user don't need to do anything, just upgrade, your app becomes faster, your build becomes faster. So these are the short to medium term goals. Yeah, so the goal is to give the ecosystem a period of time where they know things are going to be stable, they can do all the crazy things built on top of the ecosystem, and at the same time, things just invisibly gets faster and more efficient under the hood. And that's our current strategy. So, thank you.
Thank you, Evan. I hope you like the shades. So welcome to the closing keynote of Cityjs 2027. Here I'm going to be introducing Carl Simpson. As you know, this is a Java conference, and Carl Simpson has written lots of books for the community on JS. And so please, let's give him a round of applause for teaching all of us about JavaScript. And when he's set up, we will get going. And so just a hands up, who has read Carl's books? Awesome, so have I. So just to let you know as well, Cityjs has been using Next, Free, and Vue.js over the last year as well to improve its site, and it's going really well. So thank you for teaching us about that today.
Good? Yeah, we're good. Well, welcome, Cityjs 2027. This has been a fantastic conference. Hands clapping for all the speakers and the fantastic organizers. I am thrilled to be back here, and I see so many faces that I recognize from 4 years ago on this very venue stage, 2023, we were all together, and now we're all distributed. Well, I see all of you because you're plugged in with your VR glasses. I personally am presenting from a Caribbean island right now. It's exciting that we're all able to be together in this amazing VR venue. You know, they rendered this entire model in just 6 hours with ChatGPT VR version 19. It was fantastic. So it's really been exciting to see all the booths and everything be able to explore while also sipping on a margarita. This was me back in 2023 on this exact stage giving a talk called A Tale of Two Webs. And I thought that it would actually be really interesting for me to update that talk for the last 4 years that's happened since 2023. So much has changed. In fact, so much has changed that it's hard to fit it all into one talk. By the way, the slides back then, they were fully just two-dimensional slides. If you're using the latest technical preview of Apple Vision OS 3.2, you should be able to see all of these in 3D, but unfortunately, if you're not using that, then you'll just get the 2D experience. It's our best viewed-in tradition of the web. But thank you very much for being here. And so there's so much that has changed about the web, and in fact, so many common themes are still pulling through. So I wanted to revisit the talk before, and my creative name for this talk is Tale of Two Webs Continued. So let's dive in. In some ways, the web is kind of the same as it was back in 2023. We're still arguing about how to do state management and data binding, whether we use hooks or signals. I mean, do you remember how last year we took a term from way back in the 1970s, the word pointers, and we repurposed that to mean variables that get updated magically? It's so much fun. And we're also still arguing about CSS syntax and where we put our CSS. I mean, way back in the day, we had Bootstrap and OOCS and BEM and Atomic CS and styled components. But do you remember, even after Tailwind, right after that, they came out with Fluff CSS, and not only 2 weeks later, then they had no Fluff CSS that replaced it. It's exciting times, right? You know, if I had one big regret, still, even today, is that our industry keeps spending so much of our attention and so much of time and talent focusing on improving the developer experience. That's what you've heard all day today at this conference, is how these new amazing products focus on developer experience. And there's this implicit assumption that developer experience, by improving that, it will flow down to improved user experience. I think the shift back from developer experience to focusing on user experience is still one of the most pressing needs, but we've made a lot of progress. So much has changed for the web too. I mean, I was only hinting at those possibilities back in 2023. In that talk 4 years ago, I couldn't have imagined just how much the web would change in such a short period of time. I think the word that comes most to mind for me is acceleration. Everything is coming faster and faster these days, and no, I'm not just talking about new versions of Next.js. As both builders of the web and users of the web, we are here making and experiencing together this completely different relationship between the devices that we use and the users, who, by the way, are humans, and the devices that we use. That relationship has been completely remapped. To the joy, or perhaps horror, of many, today's veritable digital cornucopia, the web experience, is a swirling maelstrom of AI-generated content, smart contracts on blockchains, 3D virtual worlds filled with, well, frankly, still viral meme dance videos. I don't know why. But all of that is seamlessly bouncing across every screen in our lives, from phones to tablets to watches to reality glasses to TVs. Well, actually, you knew all of that. So what is it that makes all of that work so well? I think one thing that most of us can agree on is that the biggest pivot point for the web is when we pushed and pulled apps and content, kicking and screaming, out of the cloud, way over and beyond the edge, all the way across the wires and the waves, directly and locally onto users' devices. It's when we finally realized, or maybe just admitted, that our best chance to weave the web everywhere into our lives was for all of our devices to communicate directly with each other, peer-to-peer. It was to go fully zero server, as it were. But I think I'm getting a little bit ahead of myself. Let's jump back into the past, way back in 2023, and let me remind you of some of the troubles that I felt that we most needed to tackle and start discussing.
What exactly is it that web's just so broken here in 2023? Well, let's ask ChatGPT to see if it has any ideas. Number one, we have poor performance delivering large apps from the cloud or edge servers all the way to users' devices on each visit. Number two, we have loss of your data when offline or when internet connectivity is unstable. And number three, we have the loss of information privacy. Well, thanks very much, ChatGPT. That's very helpful.
Amazing. That was 4 years ago, and it feels like just the other day. Time really flies. So we had poor redownload experience. We had loss of access to our data when offline or when we had spotty internet. And we had basically no data privacy. Certainly not the only issues that the web has ever faced, but let's admit they're the big ones. We've come a long way. For those three worst sins of the web, we've seen this big turnaround. Sure, many were doubters and naysayers, but a lot of us pushed the web forward anyway. And yet, if we too quickly forget the mistakes of the past, I think somebody wise once said that we're destined to repeat them.
Why do web apps have to be re-downloaded on each visit? Why is that the way the web works? Let's see if ChatGPT has anything to share for us. So number one, browser caches are volatile. The larger an app is, the more likely the browser is to purge some or all of the cache resources between visits. We've all probably experienced that before. Applications typically bundle most or all of their resources and code into these single files, these bundles. And even a single change to 1 byte in that bundle requires re-downloading the entire thing. Those are often multiple megabytes in size. You see, your app lives here. It doesn't live on a user's device. Sure, it runs on their phone, but it actually lives here in the cloud many, many thousands of miles away. And that is a really long way for all of those bytes to be retransferred down to users' devices over and over and over again. Many, many thousands of miles of wire. And then, of course, the cell and the Wi-Fi signals as that last mile problem. Even with edge servers, they still might be hundreds or even 1,000 miles away or more. So the more that your app is being transferred down the wire, the more it matters to the user's experience because they are having to re-download many or most or all of those resources over and over again. The greatest lie that we ever told ourselves here in the web is that the web is this zero install experience, which is really kind of an absurd concept because the transfer in the web scenario is effectively an installation. So we really should be asking ourselves, how often do we want to ask our users to reinstall their apps?
I think most people back then thought that edge servers fixed all of these problems. But there's still like 1,000 miles or more from that server all the way down to a phone, and that's frankly just too far away, which leads to more than 1 billion people in the world experiencing on a regular basis too many timeouts. That was probably the hardest thing for us to admit back then, if we're being honest. I mean, there was a lot of huge and popular companies who fully bought into the idea that the web was inherently needed to be delivered on each visit type of experience. You have AWS and GCP and Azure, trillions of 2023 dollars invested, hundreds of thousands of businesses all over the world. And all of them were building their whole web presence right in the middle of the cloud. And you also had hugely successful companies like Vercel going all in on web infrastructure as a service. For decades, the web had just entrenched itself in this client-server model. It was really hard back in 2023 for most people to even imagine a web that did not involve cloud servers. Understandably, a lot of people didn't like hearing that maybe the web needed to move away from the servers and directly onto people's devices. A lot of businesses stood to suffer their competitive advantage if they allowed the web to truly distribute itself. And obviously that wasn't going to happen overnight, so those companies wouldn't give up quietly. Most people just dismissed these ideas as idealist and a pipe dream. They were partly right. The web wasn't going to go through that pivot right away. It took quite a while. But eventually pivot, the web did. The tipping point seemed to rise up later in 2024, several years after Local First began chipping away at the foundations of the entrenched server-full web. I'm just glad that we finally reduced much of the stress in arguing about how to optimize our apps for delivery from server to browser. You know, all that noise about server components and whether we are using server-side rendering or static-side generating or all the stuff about core web vitals like LCP, CLS, FI8. Who even knew what all those meant? It was all just so confusing and distracting. When we eliminated the repeat trip that the bytes had to take to get rendered onto a device, when we just installed those bytes directly onto the device once, most of that complication just went away. The smart folks who used to spend all of their time and their talent thinking about these problems, they've largely repurposed all of that intellect and intelligence and skill on, frankly, more important problems. That whole serverless thing, do you remember that, like back in 2018 up into about 2023? I think everyone has finally admitted today that it was all bogus. Everyone knew that there were still servers in serverless, and that meant that most of the core problems of the web, they still existed. They didn't go away. They were just somebody else's problem and blame. It was so much better for users when this shift started to happen as well. When businesses started moving the web experiences from browser to server down to locally installed, users didn't even realize that much was changing. But over time, those improvements started to really matter to the users, and it became very clear. Some of the early companies to make the shift were the pioneers. They were bleeding edge adopters. But by the end of 2024, it was not seen as weird anymore. Businesses everywhere, large and small, saw the announcements and the case studies of others that had gone before them making the leap, and they too got excited. The dominoes really started to fall. And now, how great is it that we have instant on experience with virtually every app, including web apps that we experience on our devices? Right? There's no more spinners. The same way that all the other apps have always been. We used to, do you remember when we used to get excited about like a 500 millisecond cold start? And now we have 0 millisecond. But that wasn't the only big problem that the web needed to solve back then.
Does a lack of reliable internet connection imply that it causes me to lose access to my data from a web app? ChatGPT, again, can be helpful here. You see, first, even if a web app successfully is able to preserve its code and its resources on your device, your data is usually only stored way out in the cloud. And this is typically touted as a convenience for you to keep your data backed up and in sync and keep it available, synced across all of your devices. But if you have no connection or you have an unreliable connection to the cloud, well, you cannot access your data. How many of you have seen this icon? I certainly see this all the time while I'm traveling. Because no connection to the cloud, or even an unreliable connection to the cloud, makes you effectively data-less. So I think the question that we should be asking is, why aren't we storing it in both places? Well, unfortunately, there are issues. So what does ChatGPT have to say about why we can't just store data in both places? Well, number one, despite many years of efforts to evangelize the offline-first methodology, most of the web apps out there, and the businesses who build them, quite frankly, unfortunately, they don't seem to care. They have your data, and that's how they make money. More recently, this local-first web movement, more on that in just a moment, has been gaining steam and spreading the mission that data should first and foremost be stored locally and then optionally stored remotely out in the cloud. This local-first web development group is an extremely exciting group, and I highly encourage all of you to come and join. The movers and the shakers, the forward thinkers in this space, many of the people who founded the ideas behind local-first development are part of this community.
Local first might have sounded like this niche idea back in 2023, but we all know that here in 2027, that is one of the most pivotal inflection points in the history of the web. Let's revisit a few key tweets, or I guess maybe they're like X's or Zeets, or I don't even know how we pronounce those now, but from back in 2023 that signaled and summed up the mission of local first web dev. We've come to think of the cloud as a convenient way to store information. But what happens when there's a problem with the server or internet connection? Suddenly, we're unable to access our own data. We've become so reliant on the cloud, this loss can be debilitating. This is especially true for businesses or systems that rely on it. Local first data storage, on the other hand, solves this problem. With local first data, users can access and work with their data even when they're offline, without relying on an internet connection. This allows for greater flexibility and productivity, especially for users who work in remote areas with limited connectivity. Since data is stored and processed locally, applications that use local first data can be faster and more responsive than those that rely on those remote servers. Users also have more control over their data rather than entrusting it to these remote servers that may be vulnerable to hacking or other security threats. I think it's important to point out, by the way, that local first apps are just web apps built with whatever web tech framework you like. You use frameworks, or like me, maybe you don't use frameworks at all. That's mostly true, but not entirely. I think I'll be a bit concerned about using React to build local first apps if React sees React server components as the default React. Yeah, that was a bit of a disturbing trend, I think. See, React grew not to, you remember back in the day, they used to be just a front-end library? They weren't even a framework, and then they became a framework, and I think arguably by this point, they're just a platform, which brings with it all of the inherent server complexity. And I think most of us can agree now that that was the opposite of what we should be doing. Thankfully, the let's move back to the server trend was mostly hype and short-lived. So local first has been advocating as a primary foundational principle that we need to be storing users' data that they should own and control first and foremost on their devices. But web apps storing data on devices has always been troublesome, at least up to that point, with all sorts of issues from like 5 megabyte limits to purging data randomly. Here's how I summarized those issues back in 2023.
Why then can't we just store all of this data on our devices and again also out in the cloud? Unfortunately, the web platform has had historically some problems, and we talked about a little bit about this earlier in the talk. We have local storage, we even have things like IndexedDB, but unfortunately these are very unreliable. And many of these storage mechanisms that we can use in the browser, they might just decide to evict that data. Now, if it was like temporary data, like a shopping cart or something like that, that's not a big deal. But because we also want to be able to store really important user information in the browser, this is a big problem if we're trying to rely on these very unreliable mediums. Also, they're size limited. Most of them are limited to like 5 megabytes. Now, thankfully, there has been some progress on this topic. Somewhat recently, we've seen some movement in a file system API that's actually been in the process and gone through various revisions for almost like 5 or 6 years, a long time. But it's most recently kind of stabilized, and it's in Firefox and it's in Chromium. Unfortunately, this API has not, there's no signal yet. It has not landed in WebKit and iOS, and so I think you and I both know that means we might be waiting a little while for that.
Spoiler alert, we're still waiting. You see, progressive web apps, PWAs, were the primary way that the web tried to expand its capabilities, like the file system API, to have more parity with full native apps. PWAs are literally just normal web apps that, along with being built on top of a service worker, can actually be installed to a device and act mostly like a real app.
Speaking of PWA, don't these service workers inside of progressive web apps, don't they give us more control over the caching and the reloading behavior of these resources and our data? It is true, and in fact, one of the main advantages of service workers is that they do give us fine-grained control over the loading and the caching of those resources. However, most of the authors that use these, they neglect these capabilities. In fact, there are actually additional capabilities that are really untapped and really should be used. For example, periodic background sync. It's one of my favorite APIs that almost nobody uses, nobody knows about. It allows a web app to update itself periodically in the background, even if the user doesn't have the web app open, so that a user always has fresh, latest resources loaded, and they have a quick, almost instantaneous app launch. As of early 2023, unfortunately, this API is only available in Chrome. But the thing about the service worker is that it reorients the entire relationship of a web application. The whole architecture reorients and really kind of takes most of the important parts of the back end and puts them directly into the front end, co-located with that front end code.
Even the most non-technical of users understood back then how ephemeral and unreliable the web experience was. You would open up a website, start reading, clicking around on things to explore, and then you'd go get on a bus or a train or a plane and look back down at your phone, and the content and experience that you had before was now gone. It was dead. You couldn't even scroll through the content that had already loaded because the browser had, for some reason, discarded the background tab and forced a reload when you switched back. Users really, really hated this. They never understood why real apps kept working, but the web could just stop working. Maybe more than any other sin of the web, this was the thing that kept the web as a second-class citizen in users' minds. It's so much more beautiful and graceful of an experience now, isn't it? The web doesn't go away when our internet connections falter. Most of the web applications that we see that are popular and that are widespread use these days, they've all embraced that offline first, that local first mindset. They're all more or less preserving our data locally on our devices so that we always have access to our data no matter what our internet connection looks like. This has made a huge difference, honestly. Turns out users really do care about always having our data immediately at hand. Of the top 50 apps that are downloaded on the major mobile platforms now, almost half of them are local first web apps. That's huge. Before 2023, there had been just a handful of experiments into making local first applications that could scale up to these huge user bases, and they were led by forward-thinking companies like InKnSwitch. But today, there are hundreds of thousands of businesses and content creators who are delivering these local first installed web experiences. The latest market research suggests that these experiences are now reaching more than 500 million active users every day. That's a huge chunk of the world that has embraced what the web could be. I'm super proud to have been just a tiny little part of this big movement that has reshaped the web over the last few years. I want us to revisit what I said about my employer Socket Supply back then and how they would champion this effort.
Talk to you a bit about Socket Supply Company. I joined as a senior tech leader with this company back at the beginning of this year of 2023. And I want to talk to you about what I think that they're really doing that I think is pushing this space forward, and it's why I'm so excited to be working there. Socket Supply builds a free open source framework. It's a runtime, and it allows you to take a web application and package it as a native app, what we so-called hybrid app runtimes. And you've probably heard of things like, React Native and Towery, and even way, way back in the day, like PhoneGap and Cordova. It's kind of in that same general space. What it does is it takes a web view, it instantiates your web code inside of a web view, and so you can use all of the normal web frameworks and code the way that you like, or no framework at all if you roll like me. However you want to do it, whatever your web code is, you shouldn't have to change it because it runs inside of a web view. But our runtime wrapped around it adds very important additional capabilities to the web application that you normally don't get from the web APIs. For example, we namely have a full file system API, so we don't have to wait around on browsers to do that. We have full networking capability and full Bluetooth, and we have a few others that are hopefully coming along as well. But these native APIs are injected into your web scope, the scope of your web application, so you can access them much like Node.js web APIs, and you can use those in your applications. So you have full capability like you would in a native app, but you can keep writing all of your favorite web code. I think this is a really compelling story for businesses who have invested heavily in teams that are specialized in web development. Why ask them to go and relearn something like, learn a whole new language like Rust? For example, that's what Towery does. They say that they want you to write your backend or your main process in Rust. We don't think that that makes sense for web developers. And honestly, I think of this as sort of the next step from progressive web apps. It's really like we're taking the P from progressive web app and changing it into packaged web apps. That's really what this is. And I want to say that it's not just an option, like similar to Electron and Towery. Yes, we are in that similar space, but it's not just another version of those things. Because we do offer some truly groundbreaking capabilities that you really probably can't do in those. And I want to talk a moment about a few of those. First and foremost, one of the things that we're most excited about is that because we have a full networking stack, we can actually do true zero-server peer-to-peer. That means that apps can talk directly to each other without having any server middleman whatsoever. What that means is you can literally build almost any application that you normally build with some cloud backend. You can put that logic into each of the app installs, each of the app instances on your users' devices, and basically say goodbye to all of the cloud services that are creating all the complexity and often huge costs and overhead for your business. You can just simply have their apps talking directly to each other, exchanging data as they need to. What we think is that if you do not have to pay so much for the cloud, it's going to drastically reduce the cost to running businesses and running these kinds of apps. That's going to allow significantly more apps to be able to be created that may not be able to be doing so right now because of the unfeasible cost of scaling in the cloud. That's one of the great things about peer-to-peer, by the way. When you're scaling in the cloud, the more users and the more data you add, the more cost there is and the more difficult it is to get the complex system working. But in a peer-to-peer, it actually works inversely, because the more users you get, the more data that's being transmitted around, actually the cheaper and more reliable and more stable that network becomes. And that's one of the things that I think we're most excited about.
2023 was when Socket emerged to embrace the promises of the local first movement, the idea that these apps should be built to default to storing user data locally on the device rather than defaulting to storing it out in the cloud. And along with many other great projects in the local first space, Socket Supply bolstered these efforts to bring those local first app capabilities to the masses and to the web. To break free from the ransom tyranny of the cloud, these apps have to be able to communicate with others without servers, and that means peer-to-peer. I'm not just talking about web peer-to-peer like WebRTC. I'm talking about a native, fully capable peer-to-peer protocol. In 2023, Socket launched a stable peer-to-peer protocol that handles the incredibly hard problems of NAT traversal between peers without needing centralized stun and turn servers. A protocol where if two peers are online at the same time and have discovered each other, they can talk directly to each other. Nobody has to pay for a server to transmit that data. But a protocol that, unlike WebRTC, also works asynchronously and asymmetrically, meaning that two peers can communicate even if they're never online at the same time. The way this works is because Socket's peer-to-peer is a relay-based protocol, which means that we send your data encrypted, is by default relayed through other peers until it reaches its destination. Through a variety of techniques, including conflict-free replicated data types, apps communicating peer-to-peer like this can negotiate and collaborate with each other at arbitrarily large scale. Socket launched all of that way back in early 2023. And then later in 2023, somewhat after I gave that previous talk, Socket pushed the boundaries even further. They launched integrations with server-side generated frameworks where the generated static HTML just resides locally in the app. Again, no more servers. And then they launched native extensions where you could run language interpreters like Ruby, PHP, and Python, again, taking all that back-end code off of the server and just putting it directly in your apps. Along with peer-to-peer, this approach to putting the full stack of an app directly into the distributed on-device app completely revolutionized how we thought about, built, and experienced the web. Goodbye, servers. It did not take long before businesses got excited, by the way, and they started using Socket and others to build these same or better app experiences for their users, keeping all the necessary data and computation out on the peer-to-peer network. To date, tens of thousands of Socket-powered apps have been launched since those early days back in 2023. Most of these companies significantly reduced their cloud reliance. Some of them closed their cloud usage down entirely. Others left only the heaviest of data storage and compute activities out in the cloud, meaning their cloud bills were slashed by 75% or more. They report profits are skyrocketing along with their buildings, it seems. And users of these apps have been happier too. Apps that start instantly since they're already installed on their devices. Data is local first in these apps, so regardless of the internet, users can access their own data. Users easily keep all their own devices synchronized, either via the peer-to-peer network or more proximally through local Bluetooth. And when communicating or collaborating with others, data communication is usually almost instantaneous, since there's no costly round trips out to the cloud to worry about. There's a lot of amazing things going on in Local First right now. From its humble beginnings a bit before 2023 to just 4 short years later, it's really taken over the web. Arguably, it's now the default of the web to build local first, rather than the old way of building cloud first. I don't think it'll be much longer before we grow from reaching just 500 million users with local first experiences to billions. The cloud's days are numbered. Local first and peer-to-peer are where the future of the web is going to be built and experienced. There's still plenty to keep fixing, by the way, including the fight to keep our data private and the fight to keep centralized authorities from trying to wedge themselves back in between users and their own data. Back in 2023, the problems were many, and some of the solutions were just starting to emerge. But the hope for what the web could be, it was great. The bets that we started making back on local first back then, they've really paid off today. In the now, a bit more than 30 years since the web was first commercialized and mainstream back in the early to mid-90s, it feels like we're really finally seeing the web realize its best and fullest potential. So as I wrap up my thoughts for you today, I want to share with you this quote. Most everyone has heard or read at least part of these famous opening lines from Dickens' timeless classic, A Tale of Two Cities. It was the best of times, it was the worst of times. It was the age of wisdom, it was the age of foolishness. It was the epic of belief, it was the epic of incredulity. It was the season of light, it was the season of darkness. It was the spring of hope, it was the winter of despair. We had everything before us, we had nothing before us. In short, the period was so far like the present period that some of its noisiest authorities insisted on it being received for good or for evil in the superlative degree of comparison only. Dickens wrote these words in 1859 in a time of political turmoil, but they were about historical events 70 plus years earlier, another time of significant political and social upheaval. Most literary critics agree that the point that he was making was that the back then, the 1700s, just as the now, the 1800s, everyone likes to make bold assertions about how we're in the worst times that we've ever seen. But more importantly, in those same times, there are those with the vision and the hope for building a brighter tomorrow. In fact, the whole story of the web has been that same narrative. We've built amazing things, then become frustrated with the downsides of what we built, thrown it all away, become disillusioned, and then later laid out plans to rethink and work towards something better. So, just like Dickens, we can choose to accept the way the current web is, or we can choose to use it as the basis against what we hope for next. There really are two webs. The web that we see now with all of its good and its bad, and the web that we will have in the future. So back in 2023, I asked those of you in attendance to envision that future. What web did we want when we got back here in 2027? Would we, 4 years later, still be arguing about signals versus hooks or SSR versus SSG? Were we going to keep arguing about the ergonomics of the framework code or where our CSS sits? Or were we going to completely rethink deeper assumptions about how the structure of the web connects and communicates? Wasn't that a much more important topic to dig into? I'm so glad that we started to have those more profound conversations back then. Then, as now, whatever we choose to argue about and work on, we cannot merely complain about it being the worst of times. We also have the responsibility to start planning, to build for the coming web and its best of times. It truly is both the worst of times and the best of times for the web. And I think that's what makes it so exciting to be part of. Thank you very much for listening to my thoughts. Thank you very much, 2023, or Cityjs 2027.
Thank you, everyone. How's everyone? Happy? Yeah. I'm really happy because, last year it was the first time we're doing the conference in Singapore. It was like a smaller scale kind of thing because initially I was thinking of doing like a virtual event, but the guys here, they wanted to do an in-person event. And we were only like 70 people, and today we were like a full venue like this. So I would like to thank everyone for coming. We were able to bring more international speakers here, like Kyle and Troy up there, and many more people. And we had even Evan. And yeah, I have to say that our website is using Next 3. And over the past year, we have gone through the migration process. So yeah, a lot of the things you said, they sound really familiar to me. I would like to thank the organizers, the MC, come here. Our organizers, Iris, come up here. I'm a developer, so I cannot do it by myself, so I need support, so Iris has been helping me. Our volunteers, Diamond, Anne, come here, come here. Tan, where's Tan? Tan, come down here. Tan is now going to take me to Penang. I took him down to Athens, so he's going to give me now a tour tomorrow. The speakers, where are the speakers? Come down. Without speakers, there's no conference, right? Michael is the man. Please look after Michael. Seriously. Okay, give a big clap for the speakers. And then all of you, come down here. All of you, come down here. We need to take a picture. Yeah, we're going to go more wide. Or yeah, stay down here and we're going to take a selfie. Yeah. Who's going to take the picture? Come down, come down, come down. This way, this way, this way. So we can all fit. Are you confused? Confused.com? No, no. Look at me, look at me. All this way, this way. Facing that way.
Stay in the seat, so if we take photo from this side, we can see everyone's face. So sorry for the misinstruction before. Yeah, just go back to your seat, and we can see all your beautiful and handsome faces on the photo. Yeah.
Okay, who's going to take the picture? Photographer?
Yeah. Stay, manage everyone go back seat or maybe a little organized together.
We're all sitting down and we can all get a selfie.